Hi guys, welcome to the second day of RoboCup 2025. We're here with Roberto. Roberto, can you present yourself to us, please?
Yeah, thank you. Thank you, Sofia. Thanks for having me. I'm Roberto Bonilla. I'm RoboCup Executive Committee member representing RoboCup Junior. And I work at JP Morgan Bank, who is also a proud sponsor of RoboCup this year. I have been in RoboCup involved since 17 years now. I started as a participant, mentor, committee member, general chair, and now I'm here to the executive level.
Amazing, Roberto. It's such an experience.
Long time here.
And what you're taking care of Junior League, is that right?
Yeah, exactly. So I'm in charge of RoboCup Junior. Basically, RoboCup Junior is like a side event of RoboCup, which is meant for students. Like we focus on the educational aspect of this, and we have here teams from 14 to 19-year-old. Happily this year, RoboCup Junior is part or is being held in more than 45 countries that we have represented here. And we have around 150 teams participating, so it's amazing. Across different leagues that we have soccer, we have Onstage, and we have rescue challenges for them.
From people from all around the world.
From people all around the world. So yeah, I believe being here in Brazil for the second time in a long time. Last time was 11 years ago. It's amazing. No, also to see how the Brazilian people is welcoming, and also how they have developed after RoboCup was here 11 years ago is just amazing.
Amazing, Roberto. How the students are involving is the same approach for leagues that are not junior. Like they build their robots, they do the same.
Yeah, so it's interesting because in major, basically they prepare the robot or the project and they submit it. And that's the way there are people, the technical committees that reviews whatever they have done, and they qualify the teams. In our case, it's different because we have 45 regions. All of them, they have the regional competition, which usually they have 50 to 200 teams participating there, and just the best team on the regional competition is allowed to come to the international event. So we have a lot more students that are not here. So basically, it's the way we work. No? So yeah, it's fun, but a lot of people here. So basically, here we have the top teams of every region. So it's a really good challenge.
Some juniors are better than the mayors.
I cannot confirm or deny. No, but to be honest, basically what junior kids, like a 14-year kids, is doing here is basically the same thing like as an undergraduate team will do. No, so they have to look holistically like the problem that they have to solve. They have to work in iterations. They have to do research. They have to do prototypes. They have to do like the design, the development of the robot, the testing, and there is a continued process, all the way around. And also when they come here, basically the scenarios and everything will be different to what they have done in the regions. So they have to adapt to make it work here. So I would say like a junior high school student is doing basically the same type of work that an undergraduate does.
Okay, we're gonna see the rescue simulation here.
Perfect.
Roberto, what is it?
So this is one of my favorite challenges. The rescue simulation is like, as you know, we have 3 different challenges: soccer, Onstage, and rescue. And under it we have different sub-leagues. And this one is one sub-league that won as a community request, basically, to have an approach to what RoboCup means without having to spend money on building a physical robots. So what we try to do here is basically simulate a real environment. You can put it like maybe a disaster that happens somewhere of the world. You will see different, the robot basically needs to navigate all the labyrinth and needs to try to find the different victims that are all around. While doing that, they need to, or they will also fall. So where they will see some different like challenges there. So roadblocks, like noise on the labyrinth. So they need to find the proper way to go around and to try to rescue all the victims in the less time. One of the main things, like the difficult part here, is that they have to use AI, so they can basically map the full labyrinth, get to know like what are the different areas, recognize the environment, because the field can be totally different across runs. They don't know the field beforehand, and the robot needs to do it everything autonomously.
Well, it's one team at a time.
Yeah, exactly. So it's one team at a time. They compete versus other teams who can rescue the more big teams, and also who can do it in the less time. So right now they are preparing this team that is Esper Shari, if I say it correctly, and we'll see how they start the run.
Oh, they're gonna start now.
Yeah. So they have something important. They have 8 minutes, basically to try to complete all the labyrinth. But they have to do it in depth at that time, and also they can stop whenever time they feel that they have done whatever they can do.
But it's always only one robot to try, or maybe more.
Yeah, so you have one robot, basically. They send the code to the main computer, and the main computer execute the code. So we have like client server configuration there. So it's fair for all the teams that they use the same setup. Because also here plays a lot what the capacity of the computer that we are running in play, no? So yeah, they have not started yet,
but the time they can start at any time after the time starts to count.
yeah,
Right.
yeah, exactly. Because it's also part of, again, the robot needs to do it autonomously, so they cannot control anything about it.
Yeah.
So they know what the robot can do. So it's part of the strategy. So the things that you can do is basically the robot trying to solve this problem, but also them outside, they need to play the strategy. They know what the robot can do. So whenever they see like, hey, we already done all the things that my robot can do, I prefer to stop the time, because basically also the time at the end plays a vital role. Like
Got it. What about the arena? They know. Do they know how is it gonna be? What are the challenges they will have to face?
So basically they know what are the elements that they can find in the different, so you can see the different colors, like the victim, like kind of things that they need to do, but they don't know what is the structure of the labyrinth. So it can be like this labyrinth, and the next game will be something totally different. So that's the beauty of this. We can adapt the labyrinth, and we can build like as easy or as difficult that we want. And also what we try is, as we move forward in the runs during RoboCup, trying to make it harder. We don't want to get them like a really hard feel on the first day, because it's not part of the learning experience that we want to give them. So we give them something that they can solve easier, so they can adapt, they can run their code, and we increase the difficulty across the days.
What about the stage? I would only ask you to speak a little closer to the mic.
Yep.
Yeah. What about the stages? Do you have first stage, second stage, or is only one competition?
No, this one is just one competition, that is Rescue Simulation. This year we have 10 teams participating. So again, what we do is basically the rank. What you compete is basically by yourself, not trying to do it better each time, and then we'll have a ranking where basically we collect like which one are the teams that get the most of the points with team the less time.
And how many competitions do they have? We have 4 days of event.
Yeah, so basically how it works, and something that is unique to RoboCup Junior, is that we have the regular competition, that is this, that we run in the first 3 days. They have to try to test, to validate their code, their models, everything. And then during the last day, we give them a challenge. Well, basically we pair them 2 teams together that speaks a different language, well, mother tongue, and then we give them a challenge that they have to solve in a few hours. So basically, there is what I was explaining you outside the live. It's not only the competition. It's not about getting a trophy. It's not about getting into the first, second, or third place. It's more about the learning experience, what we try to give them. So basically, on this, the idea is that you need to help maybe another team that was not good this year, so you can work collaboratively and you can be the best super team and win that award. So yeah, so that's the two type of sets that we run here. One that is the one that they know, and the super team that is something based that they can solve in few hours with the knowledge that they already have, paired with another team.
Got it. Got it. Did you participate in this one?
No, this one we have a different type of labyrinth that was called Cosplays a couple of years back, but what we tried to change it, this one, is to make it look more on the same platform that they use in rescue simulation in Major. So what we are trying to do is that, yeah, they can go here, they can learn about the technical aspects, the same thing that the Major team does. So basically we can have a smooth transition from junior to major. At the end, the idea of RoboCup in RoboCup 2050 is to solve a challenge. No? They want to have a humanoid team of robots competing that can win versus the World Cup champion of that year. But to make that forward, if you think about 2050, we are in 2025. We're talking about 25 years to go. So basically the teams that will solve that challenge are teams that are starting in junior right now. So what we're trying to do is to make that transition. You start in junior, you get engaged, and how can we make easier to go from junior to major so they can be part of these teams. So that's the idea of this, not trying to make or use similar technologies that they use in major. So when we were asking, like, which one is better, junior or major, it's different because there are different platforms, different technologies. But what we do is we collaborate, we work together to make this transition easier for them.
Got it. It didn't start yet, right?
Yeah, no, not yet. Again, it's because they run in the computer. Sometimes they have some problems or the code is not working, so they have to go back and same computer. So yeah, that takes a bit more time. But yeah.
How many teams do we have participating?
We have 10 teams registered this year to participate in 10 teams. From around the world, it's pretty amazing because we have teams from Brazil, Argentina, teams from Europe, teams from Asia, Japan. So yeah. And again, the idea of this one is like do something that they can easily start in robotics. No, I don't have. What happened in a lot of countries is I don't have the resources, I don't have the knowledge to build a physical robot. No, so they ask the schools, they ask the mentors. Sometimes they have some pushback there because it's like, yeah, you need to spend something that you know it's going to work. But if we give this type of platforms so they can start working, actually demonstrating that they are capable of, they can solve this challenge, they can adapt, they can work extra hours, because a lot of things, they can start at school, but they are working together after school, maybe long time, like working on this, trying to do iterations on their code. So they can prove that, hey, I really know what I'm doing, this is what I have, and then I want to move to another league. No, so it's going to be like similar aspects on the software development kind of thing. In this one, we're talking about robots. They use Python as coding language that is widely used around the world, so they can make a smooth transition also to other leagues.
But Python is not the language that all robots use or mostly used by.
No, it's not the widely used, I would say, but it's one of the easiest ones to start. So if you want to learn Python, now, for example, myself, I do a lot of languages, but Python has a really good, easy entry. You can do a simple code and as more like complex code as you want there. So it's a really good start for them here.
Yeah. Well, about rules, do we have any changes from last year's to this one?
So basically, the rules change a bit about what are the environment things that we can, how can we make like more difficult the scenarios or more easy scenarios, because we also need to adapt. No, we don't want one team that something really interesting about this one is that there are some teams that what we look for them is the progression. So a lot of them, they do the code and they have open source the code. So you can access the code from a team, for example, from Argentina, from another region, and you can have a good start there. So that's the idea that the best team in the previous year, the next year, all the teams should be at that level.
Starting at the same point.
So we can have a really good progression. If you're a new one, if you compete with some veterans teams that haven't participated 3 years, for example, back, it's difficult. But if you have a good start, then it's how do you adapt your code, how do you adapt your model, how do you make like it work for this one, so you can be one of the best teams in the next year. So what's what we look basically here. So it's pretty exciting, and also one of the things that happen is with the boom of Gen AI, it may harder because you can see like
I would ask about. I was thinking about it.
And that's something happening. It has been challenging how to make Gen AI work with us because it's like it happened many years back when the calculator exists. You cannot find the calculator. It's used like it should be used as a tool, but it's used not to be used as something that solves your problem. Here, because you have although it's not a physical robot, you have the environment, the lectures, they have to adapt, we change the environment, so for the robot it's totally different. They still have to use different sensors, for example, ultrasonics, light sensors, GPS, whatever they have to understand where they are on the field. So that's why we make more challenge the fields, we change them a bit, so basically they can keep improving the robot. So if they solve the robot or they think that they solve for one field, it doesn't mean that in the next one the robot will perform the same. So they need to keep adapting the robot.
They need to really learn how to do it.
And that's the part, like we are talking about 14 to 19 years old students where we run through interview process, so we check that actually work is done by the students, not by the mentors. So they have to know if they use maybe another code. They need to know how everything works, because that's the spirit of this. So it's not like, I just copy something and I just put it there and that's my score. No. So we check everything, like what is those. Like the Super Team Challenge is also to make them like, hey, you have your code. You need to change your code to make or adapt it to this new challenge. So that's part also of the experience.
So you talked about adapt to the new challenge. Is that teams can, before the competition, teams can know what the challenge is?
So they don't know exactly what are the fields, because it's something that they get when they go to the run, so we avoid this trying of pre-map the field, no? Because if they know the fields, maybe they can do some pre-mapping, they can do some field recognition and give data to the robot that we don't want. So basically they don't know what's going on until they get into the run to basically start the robot. But what we do, and to make fair, because we're talking about that just the top teams are here, but there are many, many teams that are not here that also will have to live like this experience or get what we have done here. So if they make it to the next year, they have a fair participation also, no? Like, it's not something new. So we, after the fact, after the competition, we publish the fields so anyone can download the fields and can practice on them. So yeah.
Great,
so
great. We're gonna see soccer right now,
Perfect.
and I think we'll be alternating between soccer and rescue. So maybe it's
Let's see
going
what
to
we have.
change. Oh, those little robots are so fast.
Yeah. What do you think about them?
I think they're cute. But first, to be honest, I don't understand how they work.
Yeah, so this is the fun part. Basically, what we try is to simulate a real soccer scenario. So we have a teams, two robots versus two robots. Again, the robots are totally autonomous, so they cannot control. It's not remote control the robot. They just can put the robot and start the robot. And basically, in this case, we are seeing open soccer. Open soccer, what we enforce them is to have vision. So what they have, if you can see, the ball is basically orange golf ball that they can locate in the field, and they have to score basically versus the other team. So here right now you can see that they took the ball and they scored versus their own goal. No, so, so that was not that good. But they have to recognize the field. The robots cannot get out of the boundaries of the field. So, and also they cannot, for example, push the other robot, so they have to find the ball. Something that makes it challenging is that you don't only need to understand the field, but also you have another three robots that are moving in front. So you have to know how to move around them. You need to recognize if it's a robot, what is it doing, what is going to be your strategy. And we have a controller that basically they start the robots and we control like, hey, it's a goal, we can stop the robots and they can put in the initial position and they can start again. So it's in a summary, that's how it works.
Well, are they grabbing the ball?
So basically they have kind of a dribbler. They cannot hold the ball, but they take the ball and they have to spin the ball so they can kick the ball into the goals. So like in a real game, a real participant will do, no? So you have the ball, they have to keep it moving, and then they can kick and score the goal.
Why does this arena has two balls and three robots?
Because this is not a real game right now. They are just practicing at this point. So basically that's why they are calibrating before the game, no? Because then we have different fields that they have to put the robots and they need to calibrate the field so they can start. In this one, you can see the referees, they are actually having the game there. So, yeah, when the robot do some type of penalty or if the robot get damaged or something happened, they have to remove the robot for a couple of seconds out and then the other robots can continue. No? The idea is that you have always robots moving to make a fast-paced game.
Okay, then the two robots are out and the game continues. How many seconds do they stay out?
It's about a minute, less than a minute that what they have to get the robot out. So for example, they score the goal, so they are going to start again. So the team is going to start the kicking, so I believe they already started the game. And it's a lot of fun. So you have your goalie and you have your basically your kicker robot, no? So
how long does a game take?
It's around 10 minutes.
10.
Yeah. Yeah, we have also half times. So yeah, try to simulate a real game. It's pretty amazing. And what we're going to do is tomorrow we are going to have not tomorrow. We have some type of challenges with SSL as last year. So we do some kind of demo with some robots to see how we can jump from junior to the SSL league.
Cool.
So there are pretty similar communication kind of things. So again, for them, it's a really great experience to see, hey, how can I that I'm in high school can do work that the undergraduates does. So it's pretty amazing.
And I think we're gonna see another game.
What do we have?
What do we have?
And well, we were looking in the meantime. We have the next one. We are looking at Open. We have another league that is also soccer that is lightweight. So the thing that it makes difference is the ball. So we don't force them to have vision. We have more an IR, infrared balls. So the robot needs to find the light to know where the ball is, and they can play. So, yeah. So it's the variant of that one. So yeah, now we have a simulation again. So basically, the idea is that the robot will go through the field, earning points. There are different areas that I cannot enter. For example, the red zones, the robot cannot go. And the idea is that they need to map all the field. So they should be able to find all the field, like having like make the way through all of it. And what we do is we add some noise there also, no? So we can, like the mapping, we try to make not that perfect. So you can see some walls that are really straight, and there are walls that are more like rounded, for example. So the idea is, again, is like they go and they try to identify all the different items that we have. Each one of them, they will give them a different score value. For example, at this point, we're not sure what they have done in the past, but they already have 845 points about this. And yeah, and also they have some obstacles. You will see some like squares that is just to create more noise into the labyrinth. No?
Well, so is it regular? Those colored spots, what are they for?
Yeah, so each one gives a different scoring element. So basically the idea is that they go through all the maze and they need to identify the different areas. There are some areas that the robot cannot go. The black areas, for example, the robot cannot go because it's like maybe a dangerous zone. A dangerous zone. But yeah, the others give just like different points, no? For example, now the robot make it to the side, no? So now could be that get stuck there because it's not like a red wall, but yeah, the robot did correctly.
The robot's trying to get to. Is it a person in red there?
Yeah, so there are like. Yeah, so it can be meaning like a kind of thing like a personal situation. There are areas that they cannot go cross over, so they need to go around. And something that you can see on the left side, you have the scoring panel, you have the map, and in the middle that you have the two screens is basically what the robot is looking at. So you can see right now that there were an edge there on the wall. That edge means that it's a harm victim. So they need to identify, say, hey, I found a person here that we need to, like, the idea is that they send the signal to the rescue team to say, hey, I found a person here, send all the resources to rescue that victim. So although, again, all this simulated, what we try, the robot is in a real environment for the robot, no? So they see the walls, they see the victims, the obstacles, etc.
What about this calculator there?
Yeah, so
What does it do?
it's something they do. For example, here you can see the robot, in this case, needs to identify some victims, so we rest some points. That's something that we said, like, it was not a real victim, and the robot say, hey, I have a victim there, that rests some point. But also, they have some bonuses points if they go back to the initial area, or if they do different things, they got bonuses. And the calculator basically is what is the total amount of points that they get. And that's what we use to make the ranking. At the end, if they have the ranking and we have team side, we use the time for make a differentiator between teams.
Well, we have the points and we have like 4 minutes and 32 seconds.
Exactly. So they in 4 minutes 32 is what I basically when they start doing all the points. You know the robot. You know what the robot can do. So the idea is that you collect most of the points in the rest of the times. So in this case, the team stop the time after this, saying, "Hey, this is all the things that I can do. I want to stop the time, and I end my run here."
That's great. So it's not something I thought that they would always have to use the entire 8 minutes.
No, it's part of the strategy, basically. If they think that they can do more things, they can use at most 8 minutes. But in 2 minutes, they do all the points that they want. They can just stop the
Kids
run.
must have so many disagreements about this.
Yeah, so that's the part. So we have just a captain making these decisions.
Yeah.
But outside, you have the parents, you have the mentors, the other team members
They
telling them what to
don't
do. Like, basically,
Leave it
he cannot
there.
do anything when the run starts because the robot is autonomous. So it's a lot of pressure for the person that is actually the captain there. So it's part of the learning experience and the skills that they acquire.
Great. When it ends, they they are making some notes.
Yeah.
What is
The,
it?
the thing of RoboCup Junior is that it's run by volunteers. So we have a lot of fields, and basically we have few committee members that do the rules and run the competition. So to make this happen, we have some volunteers that we give training. They make the best that they can to be as fair as possible. And also, most of the volunteers are from Brazil, so they speak Portuguese,
Yeah.
and many of them don't speak well English, the same way as a lot of participants don't speak English. So it's part of this communication that they try to say, we cannot be there in other fields, so if they see something that, oh, maybe the computer did something wrong, or the volunteer, I think that he or she judged me wrong, they can put comments and we review each one of the comments. So we follow up with the judges to say, hey, what happened? We follow with the team to try to make the fair decision. So whatever they have, if they believe like, hey, the points are wrong,
Great.
they can just put it out there and we can review after the fact. Because we cannot be there reviewing because we have the next team coming to
Yeah.
participate.
To
So
manage all of
if we
it.
try to solve it on the spot, basically we can delay all the other activities. So that's the idea, and then both people have to sign. No, the captain signed to say, "Hey, those are my notes. I agree,"
Okay.
and then the referee also signs saying, "Yeah." They can also the referee can put their comments. They sign, and then this is what we use for the general rankings after we
Okay.
review each one of the
Great.
participations.
Actually, I didn't think I wasn't thinking about the communication. Like for me, for some reason, everybody could speak English. But yeah, it's such a difficult thing. Like for people to communicate between themselves.
And again, we're talking about teams from 14 to 19. So maybe
Yeah.
to 17, 18, 19 is
Yeah,
easier. But
after
a
that.
14 years old kid, 15 years old kid is not that easy. And they really do a hard time. And the same thing that I was telling you, we do interviews. And they have to be
Yeah.
able to explain the code what they do in English. Sometimes we know
It's
that it's not
another
possible, so
challenge.
yeah, sometimes we have a translator. We have been helping them to, for example, I have helped to translate from Spanish to English, things like that. But most of the cases, they try to do it by their own. Like whatever they have with the supporting materials, with their posters, with the technical description papers, with their presentation to explain what they have done.
Amazing. Thank you, Roberto.
It's fun.
I think you're gonna see at work right now. So
Uh,
they're putting the competition that it's happening.
okay, this is not junior, this is major, but yeah.
Hello everyone and welcome again. And as we see, we are going to get a view in the at Work League. So I'm here with...
Hello everybody, my name is Amir Hossein Soltani. I come from Iran and here I'm competing with my team from Bitbots from Germany.
Oh, that's awesome.
Yeah.
You're from Iran
Yes.
and you compete to a German team?
Yeah. So I study master student in Germany.
Oh, that's awesome.
Yeah, and here we have our team with our robots, which is gonna compete today. Also, we face some serious issues at the
Really?
last minute.
Oh my God, this always happens.
Yes, it's
Yeah,
competition.
part of the process, right?
Exactly.
So it's your first time here at RoboCup?
Yes, it's my first time here at RoboCup, but I've been participating German Open competitions.
Yeah.
But the RoboCup, first time here in Brazil.
Yeah, and what are your expectations about the event and the competitions and the people here?
About the people and the culture, I would say it's really amazing. It's totally new. It's another world. But about competition, I would say there is a very good infrastructure and platform.
Yeah.
And there are very good people and teams competing to each other, very good robots. And yeah, we should see how it goes.
Yeah, that's awesome. So, can you explain more about the league, like the main goals of the league, the main rules, and also the main challenges of it? Like, what is the most difficult thing your robot must do and stuff like that?
Yeah, so the challenges are a lot.
Yeah.
So basically, we are at work team. Our robot has to perform some industrial tasks like grasping, manipulation, transportation, finding its way through the arena and avoiding the objects. So there are some specific objects that our robot needs to detect with the vision system and also needs to grasp them and take them to the target position. The challenges are the different shapes of the objects.
Oh.
And because our vision system, which is an AI system, will detect each object and the size and the pose of the objects, and based on that our manipulator or arm will grasp the objects. So with different lighting conditions, which is different in every condition. Here is too bright, but our vision system, which has to detect the objects, will go crazy. It cannot detect.
Really?
Yeah. So one of the challenges is to adapt our vision system to new environments. So we need to train our model again to be adapted to here, the
To
environment.
here. To the light here, right?
Yes, exactly.
So you said you use artificial intelligence, is that right?
Yes, sure.
Sure. So how does it work? Like, I know the robot cannot see as we see, the robot cannot think as we think, but can you explain me a little bit more about how do you use artificial intelligence and how is that, do you know something that you must use to recognize an object?
Yeah, so robotics and artificial intelligence go together hand by hand.
Yeah.
They are not separated from each other. So we need to give this artificial intelligence to robots so that they can understand and they can perceive the environment. In robots, it is used in many different ways. Mainly for our at-work team, the artificial intelligence is used, for example, in perception. When the robots, we have eyes and that's how we perceive the environment.
Yeah.
But the robots have only one camera and also other sensors, of course. But the perception for robot is that from the camera image, what you can see in that image, what objects are there. And this is done by artificial intelligence.
Oh, so the artificial intelligence like the brain of the robot?
Exactly.
Awesome.
It's the
Awesome.
intelligence of the robot.
Yeah, the artificial
Yes,
intelligence.
they're robots.
That's awesome. And you said something about the light. So back in Germany, right? You trained the robot to recognize objects in a certain environment, and then you came here, and the environment changed. And right now, what are you trying to do to solve this problem? What are you thinking about? Like, thank you for being here today. I know it must be very, very difficult.
Yes, of course. That's a very good question. So we need to gather more data of this new environment.
Right.
That's what we did through past days. So we have more data. We fine-tuned our model to be adapted to this environment. And that's actually a very critical step, because if your vision system does not detect the objects,
you
no
cannot do
matter
anything.
how good your robot is, you cannot detect and pick.
Yeah, without the software, the hardware cannot work properly.
Exactly.
But without the hardware, the software cannot work properly as well.
Exactly.
So can you please tell me a little bit more about the hardware? Because in some leagues, we have like standard hardwares or very similar hardwares. And as I can see here, I think I'm seeing two or three robots, and they seem pretty different from themselves.
Yeah, so it's, I would say that teams are very free in this regard and can be very creative with their ideas.
Awesome.
So the robots here are completely different from each other. As you can see, there are different types of arms or platforms or manipulators. It's something that is built through time by the students and the researchers in that team, and they figure out what are the shortcomings and they add more parts to it. And it just evolved through time. And our robot, for example, has been evolving since 2011.
Really?
Yeah.
Oh my God. And day by day, or competition, step by step, competition after competition, the robot just get better.
Exactly.
That's awesome. So I'm really curious about this arena, about this field, this workplace. I mean, it's a very bright image, the lightning is very, very strong here. And I see a lot of white boxes. Can you explain me, like, how this works? Like, how there is a path that the robot must follow? Can you explain me more about it?
Yeah, sure. That also goes back to artificial intelligence.
Oh, nice.
Because the robot actually needs to find a path through the arena and avoid all those objects.
Oh,
so how it is done is that we have different algorithms. One of them is for finding the path through the arena. That's an artificial intelligence. There are different algorithms like Digestra or A-star that we can use.
Oh, right.
Yeah, and before using the algorithm, we need to have a map of the arena.
So all the possible paths, right?
Yes. So what every team needs to do is to do mapping, basically. So they send a robot through the map, and they, in the end, have a map of all the locations of the objects and all the walls. Then this map is given to the robots, and the AI comes to the play. And whenever you say your robot go from, for example, a start to some point, given that map, the AI can generate a new path for you.
Oh, that's awesome. So the robot is completely autonomous once you have the mapping?
Oh, absolutely. Absolutely. No human intervention. The robot can just figure it out, and that's the magic of the artificial intelligence.
Yeah, definitely, but that must be very, very hard.
Yeah,
like you cannot tell the robot go this way and go to another. You just have to I don't know, the software probably is so complicated.
Yes, of course it is complicated. but the algorithm is there and there is some logic behind it, and
Yeah.
it works.
And this is technology and
Yeah.
innovation, you know. I think that's all about RoboCup is all about technologies and innovation. And
Exactly.
I see that in all leagues we have different tasks, right? So what are the main tasks of at work?
Yeah, so the task at work is divided into several steps. So one of them is, which was yesterday, was basic manipulation task.
Awesome.
So there are some simple objects that the robot needs to do manipulation, also do grasping. Today it's gonna be basic transportation task, which is divided into 1 and 2. And tomorrow it's gonna be advanced tasks. So the step by step, the difficulty and the complexity of the steps is gonna be increased. Today more objects are gonna be involved and more platforms that are far away from each other, so the robot needs to go through all the map.
Grasp and choose a path and
Yes.
then just leave the object there.
Yeah. And tomorrow in the advanced section, for example, I can give you an example of an
Yeah,
advanced
please.
task. There is a rotating table,
Oh,
which is rotating in a fixed speed, but it is rotating.
it is rotating.
And there are objects on it, which the robot needs to grasp.
Oh my god, I think this is difficult sometimes for a human to do. You
Of
know?
course, of course, yeah. Yeah, and you know, the camera is usually installed on the top, and the arm is here. So you need to have a very exact calculation of the time when the arm needs to move and pick the objects.
Definitely. So you said the camera is, you know,
Yeah, it's usually installed in a place where the robot can actually see what it is in
it
front
is.
of it.
Oh, okay. So the robot has his own camera.
Of course.
Oh, I thought the camera was like right there, you know,
No.
above everything. So they see exactly the path to move. Oh, this makes very
Yeah.
more difficult, you know.
Yeah, the cameras are actually like the eyes
Yeah,
for the robot. you know?
for the robot.
Yeah.
And what is the main objective of this league? Like we saw the rescue league, you know, where the main objective of it, not thinking only about the competition, but is to improve the technology over a rescue situation, over, you know, some disaster, or to save people's life. And I mean, at work, the name says it's a robot that can work, but what do you think is the main objective here?
So at work, robots have the duty of reducing all those laborious and difficult tasks that the people have to do in industry, especially all those repetitive tasks that we need to do. That's gonna be replaced by robots, and which
So-
would be a great help.
So we can be occupied doing things like,
Yeah.
to know, or to rest a little bit, definitely. And I mean, robots are already used since a long time ago in the industry, and with these robots, I mean, I think they are going to, you know, change the game, of course. And you said it's your first time competing, so you're a competitor. Well, I would like to know how is I'm making these questions for everyone that gets here. How is the vibe? Do you know, like, people are do you know, like, communicative, thank you. They are maybe a little bit of stress involved in this. I mean, it's a competition, as you said. Everything can go wrong anytime. So, what is the vibe? I mean, people are having fun. People are, you know.
Yeah, so that's a very good question. The vibe is something very spectacular. There is at the same time a lot of teamwork
Yeah.
between the team members, and also there is a lot of teamwork between different teams.
Different.
So we help each other. If any team needs help, we support each other with the software, with the hardware.
Oh, that's
So I
awesome.
like this aspect, so this cooperation. But at the same time, there is this rivalry and this competition
Yeah, this competition between,
between us.
like everyone wants to win. Yeah.
Everybody wants to win.
Everybody traveled a lot, very far from here. They want to win, but I think the communication is the key,
Yes, of course.
and helping each other. It's awesome.
And it is the competition. There is a lot of, I would say, excitement
Really?
or stress.
Yeah,
I
a
would
little
say,
bit.
You know, for example, 3 teams lost their chance to perform their task because there is only 3 minutes of preparation time for each robot.
Oh, for each robot.
And after that 3 minutes, the robot should actually start performing the task. So if you lose that 3 minutes, for any reason, there are many possible causes that can
Yeah.
happen. You will just lose your points. Or like the accident that happened today,
Yeah.
and my friends are. I can see that they're
Really?
still trying to resolve the issue.
Is this your robot?
No. This
No?
is not. This is the American team's robot.
Oh, right.
Yeah, so they are put it in the start position,
oh.
and as you can see, there are the objects on the platform. There are 4 objects that the robot.
Oh, the black objects. I don't know if it's
yes,
black,
yes.
but
They're a bit small, but
yeah, very small. So you need to have a really good mechanism to, you
to
know,
grasp it.
grasp it.
Yes, of course.
But it has some restrictions of the size of the robot or something that the robot must have. Like at home, the robot must have a really big head bottom. So if anything gets wrong or maybe confusing, the referee can just press the button and you know.
I think all the robots have an emergency button.
Really?
Yes.
Oh, in this
So-
case too.
Yeah. So when you push it, it will kill everything, and the robot will
Oh.
stop. We use it actually a lot.
That's awesome. And now they are going to start the competition.
Yeah, so I think they're having their preparation time. As you can see, now it's a start and the robot moved.
I think I need to use the Portuguese again. Pessoal, oh no, I don't need. It's okay. They
Alright.
got the cameras for us.
So now the robot is reaching the platform and it's aligning. So there is
probably seeing the objects, right?
yeah. So now it's aligning to the platform, and the camera, as you can see, it's on the top right.
Yeah, in the top. I got really curious about the wheels of this robot.
Yeah.
Do you know how these wheels work? Like they are really different, right?
Yes, of course. So we have different wheels for different environments.
Oh.
So, for example, the rescue robots,
Yeah.
as you mentioned, they have totally different
yeah.
wheels. And these wheels are so-called caster wheels that give a lot of freedom to the robots. They can turn while standing on one point. They can turn. They can go back. It's really maneuverable, free wheels. You know.
That's very interesting. Oh, I see the red button right there.
Yeah. So it detected the objects, and now the arm is going to do grasping.
Oh. Okay.
And now it will place it, perfectly. This is 100 points, a successful grasp.
And each stage, each task has his own challenges and own points.
Of
right?
course, yeah.
That's awesome.
So that's how the teams gather points and they win. If they do successful grasping, successful placement, reaching to the platform,
To the platform.
which is navigation, that also has 100 points. So this robot so far has gathered 200 points.
Oh, really?
Yeah.
Because the robot is in the right place
Exactly.
and grasp an
Yes.
object,
Yes,
right?
yes.
Oh, that's very interesting.
And there is one critical rule that the robots needs to consider, and it is while they are moving through the arena, they should not hit any of those walls or objects. Otherwise, it's considered as a major collision. And they have two options. They either can restart from the beginning,
Yeah.
or they lose 50% of the points.
Oh no.
Yeah.
I mean, that's very, very bad.
That is very bad.
Imagine having a lot of points. Like, we're gonna win, and then
Yes.
25%. And the object, not the object, but the obstacles are all white. And I
Yeah.
mean, I think I'm starting to understand the problem.
Sure.
Like when you see computer vision, especially with AI and detection, object detection, I think it's very, very hard to see very bright objects, right?
Of course.
Very bright obstacles. So
Of course, yeah. So the robot could successfully pick two objects, and now it's going to the target platform. So far it has gathered 400 points.
this is very, I mean, fast. I couldn't see the robot grasping the other object. Now I see that
Yeah.
we have only two objects there.
And there is this time limitation. So
Oh,
all
really?
the tasks need to be done, for example, in this specific task,
Yeah.
it needs to be completed in 6 minutes.
Oh, so each task has a time limit.
Of course.
Oh my god.
So they need to be fast.
So yeah. And what happens if the robot grasps an object, but then the object falls?
Oh, that's one of the cases where they lose points. It's called
Oh no.
object loss, and they lose 50 points for that.
Well, if you imagine a workplace station or industrial scenario, you cannot leave anything behind.
Of
I
course,
mean,
yes.
any mistake, it's a major problem for the company. So yeah, it's very, very fair, I think.
Yeah, so it grasps the other objects. Each robot is allowed to carry at most 3 objects. So this robot is fully loaded now, and
Can I ask something else?
sure.
What happens if the robot takes the object, the fourth object?
The fourth object.
Yeah, it's like have a limit of 3 objects that they can carry on, right? What happens if they get 4 or more objects?
They are not allowed, and the object is not considered. It's, I
Oh.
think, if I'm not wrong, it's called wrong object manipulation. So it will be
Right.
100 points of loss.
Oh, really?
Of course.
Okay, so we see that the robot just left an object.
Yeah, so it was supposed to grasp one object from this platform and place one of the previous ones here. And now it's going to navigate to the other location to place those objects there.
It's very hard not to think that this robot is controlled by a human. Like,
Yeah,
he's so
this
smart.
is fully autonomous.
This is
No
like
human.
magic, don't you think?
Yeah, of course.
Or just AI. I think it's a kind of AI and hardware and robotics and teamwork,
Everything. Yeah.
communication.
Everything. Yes, of
It's
course.
it's very awesome. And I see we have different kind of places, like this one that is right there, you know.
Yeah, yeah.
Looks like a broken table.
Which one in case? Which one? Which table? That was the tables that inside the arena
Yeah.
are carefully designed by the referees and.
Really?
Yeah.
They try to make very, very difficult, right?
Yes, 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 yes. As difficult as possible.
That's really awesome. I mean, I really love to heard more about the league and to understand and to get to know it better. Because as I explained, we as hosts, we need to know a little bit about all the leagues, and it was just very, very interesting. And I hope that the problem with your robot gets solved. I
Thanks,
really,
I really
really
hope
hope
so.
everything will is gonna be okay. I mean, with communication, teamwork,
Yes,
you
yes.
know, and we can see a lot of people there working hard on the robot. So I thank you so much for your participation
You're welcome.
and
I
for
really enjoyed the talk.
telling us everything. It was really, really good, and to clarify what is this league and what is happening. I hope we can see more of the league later or tomorrow. So thank you so much for your
You're welcome.
participation.
My pleasure.
And in the next league is the rescue robot. So we are going to get an overview of the event so we can see what is happening now.
Guys, hi, welcome back. We're here with Adam again, right?
Yeah.
Adam was here yesterday, and we are here to talk about the Rescue League. Can you say a bit about you, please?
Well, so my name's Adam Jacoff. I'm from the National Institute of Standards and Technology in the U.S. I'm here with RoboCup Rescue, the league that focuses mostly on emergency responders that are in harm's way and need robots to project their tasks as remote operators. So they need autonomy, they need mobility, they need dexterity, and they need mapping. And that's all the scoring that goes on in RoboCup Rescue.
Got it. So they're not autonomous robots?
They are trying to be autonomous robots, but it's
Okay.
very hard when you see the worlds that we put them in, terrains and obstacles. They get 4 times more points for being autonomous in the
Great.
lanes.
Amazing.
So the incentives are there. But when they can't quite do it, like the stairs are occluded, it's really hard, they can always fall back to remote teleoperation. So the operator is always outside, not looking at the robot, working through the interface.
Got it. Adam, we're gonna see a competition, a rescue competition here, and I will ask you to tell us what's happening there.
Okay. Okay, so we have such a wide variety of robots in RoboCup Rescue. This is day 2, so we're in our preliminary phase. So you'll see a series of lanes set up. These are standard test methods that are available to everybody. Emergency responders help develop them and refine them because emergency responders have robots too, or they need to buy robots. Here, this robot is trying to pick up an object of interest that weighs a certain amount. And they get extra points for being able to carry payloads throughout the arena. So the terrains that you can see behind him are really difficult. Wheeled robots were everyone's first idea of robots. The league, because of the terrains, moved into tracked robots with independent flippers in the front and the rear. And now we're seeing legged robots, and sometimes legged robots with wheels. That's brand new. And so when you see that, you'll know the difference.
And are the robots the same? They have any standards or weight, height?
Well, we have a certain size limit, and this is about the limit, but it's not a hard and fast rule because the arenas themselves imply that you can only be so big. You'll see how tight a turn that is in that complex terrain. So that's about as big as the robots get, and it's heavy. Here's a much lighter, different model. Legged robots that can be purchased. Oh, this one's special because, well, you see both. The one on the left has a payload on top that is an operationally significant payload, and we'll talk about that when it gets to it. This one here has a more RoboCup payload with a manipulator on board, a brain. They're always carrying their autonomy with them, so there's a certain amount of payload. This one is a commercial product with a faked payload on top. That is a flashlight and a weight which mimics an X-ray. So for example, bomb squads are responders that are in harm's way all the time, and they need to go downrange and X-ray packages often. They do that manually very often. In a padded suit, they walk downrange and they put a backplane next to an object and then place the X-ray to get a look at what's inside. Is it a problem or is it not? So this robot, we're trying to show that two of those robots can do that job together when they collaborate. So you'll see, he'll get back to it. Right now he's doing laps. So the way the scoring works is the robots spend the first 10 minutes of a 20-minute trial just doing mobility. So they walk from end to end to end, dealing with these angled obstacles to avoid because they're magnetized. If you bump them, they'll fall down. So it's an unstable environment that they need to be very careful in.
Yeah.
And they're just walking 10 laps to show that they could get 100 meters downrange.
And they doesn't seem really stable. Is it meant to be like that?
Well, it looks complicated, but it is stable. It's physically safe. It's safe for the teams. It's safe for the robots. That's the point of a standard test method. Standard test methods need to be first safe and then repeatable and incrementally difficult. All these pallets and pipes here are stacked too high. Those are 10 centimeter, 4-inch pipes. So he's climbing platforms that are only 20 centimeters, 8 inches. That appears in nature everywhere. That's like a tall curb on a roadside. The reason why the pipes are there is because a tracked robot or the wheeled robot we just saw has a lot of trouble with a spinning pipe, a slippery front edge. The legs don't even notice. The legs step right over.
But is this autonomous? No.
This one's remote teleop. You can see the back of the operator on the right. He's facing the other way.
Oh.
So this is the lowest cost version of a robot. The one on the left does have autonomy. It's hard to tell sometimes. It looks usually a little slower but smoother when it's driving autonomously.
Oh.
And he has an excellent manipulator. So he's approaching a task, that Omni task, is to identify objects of interest. Our objects of interest are omnidirectional or linear in nature. You see both of them here. On the far right, there's a linear set of pipes.
Yeah.
They need to look in there to show that they can get every angle of a package. When they want to inspect something, they need to look at it from multiple angles. So he's doing his first 10 minutes is mobility only. So he's proving that terrain, he can go 100 meters downrange in that terrain. Then the next 10 minutes is all dexterity. Any one of these laps could be done autonomously for 4 times more points. Any one of the dexterity tests can be done autonomously for 4 times more points. So the incentives in the scoring is what drives the autonomy.
Yeah. And how does a participant, a team, actually win the game? It's only about the object, or does it have time? The time counts. How is it?
So they're time-limited trials, but that's mostly to make sure we have a structured day.
Yeah.
There's 10 different start points. There's 10 different lanes set up, so they're very concurrent. So today is a lot of activity going on down there. The awards that we give out are really the secondary part of RoboCup Rescue. So RoboCup Rescue is really about evaluating your research in public, showing everyone your approach. Bring a new approach, prove that it works, the whole paddock sees it, the whole paddock can then adopt it, because our teams freely share their excellence. When they do something well, the whole paddock has access to it. The code, the designs. In this case, we have points that add up eventually to a championship, but that's a secondary concept in our league. We give out prizes for best-in-class dexterity. This is a strong candidate for best-in-class dexterity. We will count throughout the week how many of these dexterity tests he completed successfully. So there's best-in-class mobility, there's best-in-class dexterity, and there's best-in-class mapping. And mapping is the third leg of the stool, where robots that go into unstructured environments need to come out with information for the emergency responders. They need to be able to say, I know where there's a victim, I mapped my path, and oh, by the way, the shortest route in is not where I came from, it's the back side of the building. So come in the back window and you will be right near the victim. So the map is one of the most important products these robots can come out with.
Amazing. Well, so they can rescue objects, but not people.
Well, so the way we look at it is these are better tools for emergency responders first to stay out of harm's way themselves. Before they even get to finding a victim, they need to search a lot of voids, a lot of spaces that are structurally unsound. So think about like after an earthquake, half a building comes down, the other half has to be searched.
Yeah.
There are very likely survivable victims in there, but we don't know that at the initial point of the collapse. So the robots need to go in. Robots, drones need to go in and clear those spaces without risking more lives.
Yeah.
A secondary earthquake, an aftershock, could bring the whole rest of the building down. So, but once they find somebody, that's what the human rescuers do very well. Go in, shore up the situation as they go so they're safe, and very carefully bring a person out. The robots aren't going to be dragging people out of these situations. They're going to find them, they're going to map them, they're going to bring sustenance.
Find a way for it to be done the best possible way.
And to administer to the victim at the same time. Bring communication so we can talk to them. Bring water, food, whatever's necessary.
Yeah.
All right, so you see this robot. So this is a lightly equipped robot, which is why it's wearing the X-ray payload. He's just trying to look in all of the pipes to get centered, and there's visual acuity targets in there. But for the autonomous robots, we put in QR codes, so they're automatically recognized. We put in partial hazmat labels, so that image processing has to be applied. You know, the League is not inventing image processing. That's pretty well solved, but they're carrying it in their payload. Thermal sensors, they're carrying all the payload, the sensor suite, and trying to apply it to this operational task.
Okay.
So
And
these robots are brand new. These legged robots, these quadrupeds, are starting to dominate the terrains that we've been putting out there. So the terrains change every year. First of all, this is the 25th year of RoboCup Rescue.
oh,
Every year it's gotten harder, like markedly harder. Because anytime there's an advent in technology or someone in the paddock applies technology in an innovative way and it works, that kind of gives us permission to make all of the settings harder
yeah.
and expect the other teams to keep up. So the teams basically act as a group, and they're very collegial. They help each other. They help each other fix their robots throughout the week. When one
Right.
robot demonstrates something special, everyone's aware of how to do it for the next year.
So, do we have new? What do you have? Do we have like new rules that were not?
Been fairly stable for the last few years. What changes is the settings in the test apparatuses. So the rules being do 10 laps to go 100 meters, and then do dexterity, and then do mapping. That hasn't changed in a long time. What changes is the settings of the standard test methods, how aggressive those standard test methods can be year to year. And usually we start easy in the preliminary rounds, which is still easy here. This is only too high. But by the finals, all the terrains will be inclined to 15 degrees. All the extra low friction spinning discs will be in there so that the robots are having a much harder time getting through.
So, what are the stages the participants have?
So preliminary round is individual test lanes. So this robot stays in this lane for the whole 20 minutes. And there's 10 of those lanes, so 10 lanes concurrently operating. The teams are scoring themselves in this round.
Oh,
They're learning how to fill out the forms. They're learning how to conduct standard test trials so that they can do it at home within their research program. You know, they shouldn't wait to come here. These tests are well known. They're standardized. They're disseminated throughout the world. They should be optimizing for the tests, and they need to optimize across all 10 tests. So if they do that, then they're doing something operationally significant. Yeah, here you see it's trying to lean in to read what's inside the pipes. Could be QR code, could be a partial image, might be a gauge, visual acuity. There's a series of targets we could put in there. Could be a thermal source if he were wearing a thermal sensor. Whatever it is, he had to get up on that pallet to read the pipe he's looking at, but a robot with better dexterity, an arm, like the wheeled robot we just saw, would be able to get anywhere near that and clear the entire 5 orientations from one position. A good manipulator should do that. And we're forcing that issue with these omnidirectional apparatuses. So hopefully he's got his flashlight on, and hopefully he's going to line up on the X-ray panel now.
How many teams do we have?
We have 15 teams, about 150 researchers, I believe, which is pretty good, considering we're pretty far south, pretty far away. Typically we have 20 or more. In this case, we actually have more than that. That's in this scale of apparatus. So this is the major league, but we have an RMRC, a rapidly manufactured robot competition that is the smaller scale of tests. So all these standard tests reduce down to 60 centimeter 2-foot clearance and then 30 centimeter 1-foot clearance. It's not easier to work in the smaller test lanes. The smaller test lanes are actually sometimes harder because you're trying to put a lot of sensors on a small robot. But the key is that league, those robots are typically 3D printed.
Oh.
So they're rapidly manufactured. They don't have to be 3D. They could be kits. We don't care. But the nature of that league is that they're disposable at that point. So if you're going to put a robot into a subterranean void and it's unsafe and unstable, maybe you don't even expect to get that robot back. And that small size league leads researchers toward that. That in effect, I mean, sometimes the robots are in hazardous spills and you just don't want to have to clean that robot after the fact. It is hazardous waste, so it's disposable.
Amazing.
Yeah, so we haven't seen a tracked robot yet, but RoboCup is rather famous for a class of tracked robots with flippers that came because the test methods were hard, because the terrains were, topologically difficult. You see this one is crossing ramps. There's just not a flat spot in the whole lane. But that's the easiest setting of this lane.
Whoa.
So tomorrow you'll see a harder setting. Finals, you'll see the hardest setting. And this is where the tracked robots are almost essential. The wheeled robots will stop performing well when the arenas get really hard. But those tracked robots were RoboCup, all the teams optimized on the track systems as soon as one of them started winning. And it was the Japanese that invented the idea of the body tracks and for independent flippers, but it was the Thai teams, there are 100 Thai teams that took that idea and optimized it further across all those teams. They're literally all tracked. So now we're getting into this legged phase. There's advantages and disadvantages to everything I just said. Wheels, tracks. Wheels would be very efficient in this expo center. Tracks are the only possibility in certain rugged terrains, but these legged systems, and now the legged systems with wheels, are going to start dominating all these terrains. This is an advent in technology that we have rarely witnessed.
When this quadruped robot it came out,
So quadrupeds have been out for several years. There are some larger ones that are pretty popular, but the notion of this size is only a few years old and is kind of ubiquitous because it's so inexpensive. So a lot of researchers can adopt it. RoboCup Rescue, our league, actually has the notion of a standard platform now, and it's a legged system like this. So we're going to have a subclass of like-kind mobility. We could have a subclass of wheeled systems. We could have a subclass of tracked systems. But we're definitely going to have a subclass of legged systems that are equipped with the same manipulator and the same computers so that we can better evaluate and compare the autonomy that's on board.
So cool. Well, I hope to see it.
So in the back, you see, you're probably not going to get a video inside, but the back with the blue tarp over the top, that's our maze. So our maze is where we do the mapping, right? So that's an unknown environment inside that 10 meter by 5 meter world. Robots don't know where it is. They don't know where their start point is. They have to go in. There's a little bit of terrain, but there's objects of interest to find and map accurately. It's a little dark. It's contained so that we can fly drones in there safely around people. So we're thinking that the next phase for the league is to have drones launch and land off the back of the ground robots. Ground robots are open indoors. Drones won't do that. Ground robot opens the door.
The rest of it work.
Drone launches.
Yeah.
Explores what it can. Figures out which is the next door to open. Meanwhile, the ground robot's still trying to catch up. Gets to the door, opens the next one.
That's incredible.
And so we'll have some teaming, air to ground.
That's incredible. So, the arenas, how many of them do we have?
There's 10 total start points, 10 total arenas. In the preliminaries, we stopped today doing individual lanes, and starting tomorrow, we do sequences of lanes. So tomorrow we'll have 3 lanes tied together, where the robot has to do stairs and then do the inclines and then do the pallets or something.
The
like
same robot has to pass
Same
through the
robot,
10.
yeah. So these first 2 days in the preliminaries, they're optimizing on each lane, figuring out what autonomy settings they need to be successful. Tomorrow they need to recognize when to switch algorithms to be successful in a sequence of lanes. So you can't optimize completely. You've got to be prepared for a wider range of challenges.
But the researchers can change something in the robots from today to tomorrow?
Yeah, this is a total development effort. That's what I'm saying. It's less of a competition in that way. It's a complete, intense development effort. They are coming here with their notion of how their robot's going to work, and it will come out of this competition better than it came here.
Yeah.
And they will learn from the next table over, and they will learn from the next terrain over, and as a league, we are moving closer and closer to operationally significant tasks.
So is it actually? Do you use these robots for rescue purposes nowadays?
These are all invariably prototypes of ideas. This is an academic competition for the most part. They use some commercial chassis as their mobility base, but still, we're pushing on the state of the science here, as opposed to trying to deploy anything. However, there's stories from RoboCup 2006. We were in Bremen, Germany, and one of the award winners from Bremen, Germany, happened to be a German robot, is now the best-selling bomb squad robot worldwide.
Whoa.
Because it was doing things that were advanced in our terrains and our dexterity. It was reliable, it was doing it well. It took a few years to become commercialized, because you got to harden it and you got to make it commercial, but it did, and now it's everywhere. So the next wave, you're looking at the next wave of robots that will be deployed. The legged wheeled systems, guaranteed.
Amazing. So Adam, thank you for everything. We had a great talk. You're always invited to be here with us. I have learned so much. And guys, you there, we're gonna have a lunch break. We come back at 1, and we're gonna be here with more interviews, seeing the competitions, me and Fernanda. Hope you guys have a great time. Follow our social media. We are also posting there, and thank you for everything. See you soon.
Hi everyone! Now let's get to know a little bit better about At Home League.
Hello.
So I'm here with Fagner Pimentel. Let's come in.
Welcome to the At Home Arena.
So Fagner, please tell me a little bit more about At Home League.
Well, this is one of the most interesting league in here in the competition because we have domestic robots. The robots should take a lot of tasks in this domestic area, so like take up the garbage, to out, make dishes, grab objects to the people. I think the most expectation of this competition is because we will have robots that's training here. For tomorrow, the robot will be in your house, so this is a very good thing.
Definitely. And tell me more about your expectations about the whole event.
Well, the whole event today is the first day, so the teams are in the warm-up days. They are mapping the arena, take pictures of the objects to the robots, and identify all the objects. In next days, we'll start all the tests, and the final in the last day.
Okay, thank you so much for receiving us.
Hi guys, today I'm here with...
Hello, my name is Martin Löser. I'm from Germany, and I'm basically currently head ref of this league and also in the technical committee of this league. I'm part of the team SWAT from University of Applied Science in Würzburg-Schweinfurt. And the general concept of our league is basically that we have a transportation task from workstation A to workstation B. So basically all tasks contain that. And on top, you change the difficulty level. So you add, for example, obstacles that were not known before. You add parts that are not part of the normal part set, like as decoys. Or you add basically different backgrounds. So currently the arena is very white and there is not much color.
Yeah.
But for example,
For now.
there can be like aluminium foil. And you have to detect the silver part on top of the aluminium foil. Yeah? And that makes the difficulty levels then, and you just increase the level from competition task to competition task till the final.
Okay, and what are some expectations for you for the event?
Always a nice community, so hopefully it will be a nice community event again, and we all learn from each other and can help also each other to gather new knowledge, because it's a big part of this event, that we build a community and try to reach the current goals basically of the rule book, and also then in the future years can extend the rule books to new and more complex tasks, because hopefully at some point all the teams have solved the easier tasks. And yeah, we are currently, to be honest, world champions. So hopefully
Congratulations.
we'll do that again, but we will see.
Hi, could you present yourself to us?
Yes, my name is Thiago. I'm a professor of robotics in the University Federal Paraíba, and also local chair and exec of this demo league, which already happens in Brazil for some years, but now it's the first time we are doing a demo in RoboCup.
What are the biggest challenges of your league?
This league is for autonomous drones. They are not teleoperated. The pilots is just to ensure safety, but all the drones must localize themselves and fly autonomously to perform 4 different tasks. The first task is they have to land on all these bases autonomously, recognize them because they don't know where they are, and they have to land and take off from each one of them. The second one, they have to do a package transportation delivery. The third task, they should also land on the base, but now commanded by gestures of humans. There is a human operator from each team that's doing some gestures, and the drone should recognize those gestures and interpret that as a command. And the fourth one, they should go through this labyrinth. It's a confined space where they should enter from one side, leave the other side, recognizing some paper tags.
Seems way too much. And what are your expectations for this event?
We already have some years in the nationals, and the nationals teams are able to perform like 80% of the tasks. So it's kind of hard because this is state of the art. I don't know how these teams are going to perform because at least the Brazilian team, they are not the first places on the nationals, but let's see how they handle it. Let's hope that they can do a really good job this year.
Thank you so much, Thiago. Hi guys, we're here with
Trent.
Hi Trent. Can you tell us what's your league?
So my league is the Humanoid League, which is the robots that we get to control the hardware. So we get to choose which parts go on and how they go together, and then we build our own robots so that they can compete in the competition. And specifically, we're limited to human-like sensors. So we can't put anything that a human wouldn't have, which, you know, has been fun from time to time when we can't put things like compasses on our robots and lasers, but the constraints make it very, very rewarding.
Seems way too complicated. What are your challenges in your league?
There's a lot of challenges that have cropped up in this league over time. One of which is that, especially recently, the pace of technology growth has been explosive, which has been really great for our league. But it also means that a lot of teams have to spend a lot of time, you know, learning new techniques and learning new things, which is really great, especially since most of the people who are in these competitions are students. So it's a great opportunity for them to learn. But yeah, the rate of technology growth has been explosive recently. So
It's amazing how things are really going way too fast. So what are your expectations for this event?
I'm actually really excited about this one because the first RoboCup I ever went to was actually the last time this was in Brazil. which I think was in 2013, a long time ago. So it's really interesting for me to see, coming back here to Brazil again, how much has changed in those last 12, 13 years, just how much the robots have changed and grown. You've got, back when those robots were playing all those years ago, the goalposts were yellow, there was just green carpet, so there wasn't grass. The soccer ball was just an orange ball as well. So, and then seeing that from the robots going on that environment all the way to now where they're playing on proper grass with proper goalposts, and many teams doing team play and walking, and it's just been really exciting to see the growth of the teams and growth of the league as a whole just over these last decade.
Amazing, thanks. Thank you for the interview. I wish you luck.
Thank you.
Hello. Can you tell me a little bit more about yourself? What's your name and what league are you responsible for?
Hey everybody, I'm Oscar and I'm currently in the Onstage League, which is a league that I used to participate in as well. And I'm very thankful to be back here and being judged in the competition this year, which is in Brazil.
Awesome. And can you tell us a little bit more about the league and what are the main challenges of it?
Yeah, of course. On stage, differently than the other junior category leagues, it doesn't provide you with any challenge besides elaborating a performance as long as you stay inside the stage. And staying inside, you can basically do anything, such as a theatrical piece or a robotic showcase. And by designing your performance, you come up with your own challenges and your own technical difficulties that you will try to solve it, which is the interesting part of Onstage.
Definitely. And can you tell me more about your expectations of the whole event?
Oh yes, I'm waiting to see a lot of innovations here this year, specifically because an international competition here in a big venue and also a lot of teams coming all around the world.
Hello everyone. So please tell me more about yourself. Tell me your name and what league do you represent?
Hi, I'm Tom. I'm from the executive committee, but I was working with the Rescue League, which we can see the fields over here. Yeah, working with this over the past few years and now overseeing more of the leagues.
Awesome. Can you tell me a little bit more about the leagues and what are the main challenges of it?
Sure. Over here we can see the fields for Rescue Line and Rescue Maze. These are two of the main parts of the Rescue Challenge. We also have Rescue Simulation, where we put the maze also in the computer in a simulated environment. But over here the robots need to follow the line and then collect victims, which are like silver and black balls, and then put them to a safe spot. So this is like a disaster scenario. And over here in the maze, the robots need to orient themselves in the maze fully autonomously, find victims on the wall, and then drop them rescue kits so they can help themselves and can be rescued later.
Oh, perfect. And can you tell me a little bit more about your expectations of the event?
In this event we'll have the best teams from all over the world coming together here in Salvador, Brazil, competing for in the different leagues for the championship. And we're gonna see a lot of innovation, I believe, with the new challenges. We're evolving the rules every year and seeing the teams responding to that with new creative ideas.
Thank you so much.
Hi guys, today we're with
Daniel.
What you do, Daniel?
I'm in the TC of the Logistics League and I'm also with Team Car Logistics from Germany.
So can you tell us a little bit more about your league?
Right, so the Logistics League is all about modeling a manufacturing scenario where robots build orders on demand. So it's a bit like this modern idea of mass customization, where we try to optimize the utilization of machines to produce lots of varieties of different products.
Cool. And what are some expectations for you from the event?
Well, I hope for a good competition and to see some nice fights, I guess. Nice battles.
Okay, thank you.
Hello, I am Marco Simões. I am the General Chair of RoboCup 2025. We are here in the Salvador Convention Center preparing everything to start the competitions from July 17. We hope you to watch in our live stream and have lots of fun with the most amazing competitions of robotics and artificial intelligence.
Hello, I am Reinaldo Bianchi. I'm one of the general organizers of the RoboCup competition, and we invite you to watch the competition in streaming. We're going to have several games, humanoid robot games, soccer challenge, rescue challenges, domestic tasks for the robots to be doing, and it will all be streamed. We wait for you to watch our competition. Thank you.
Hello, please tell me more about yourself. What's your name and what league do you represent?
My name is Adam Jacoff. I am from the National Institute of Standards and Technology, and this is the RoboCup Rescue League.
Awesome. Can you tell me a little bit more about the league and what are the main challenges of it?
So, as the Rescue League, we're the ones on site that are working with emergency responders. So this is firefighters, police, anyone who's going into really hazardous situations and need to do so from a remote standoff. So the robots in our paddock, you'll notice, are very mobile, legged, wheels, tracks, independent flippers, manipulators, and we use all of these test lanes to make sure that their mobility is ready for the complex worlds of the emergency responders.
Awesome, awesome. And I mean, what are your expectations about the event itself?
So every year, our teams as a group have really improved the state of the science for robots in general. We see already some robots here, early arrivals, that are going to break new paradigms for us. And those are going to be the legged robots with wheels. You'll see their feet are wheels. And so they'll be doing climbing tasks like that one over there. Things that we haven't seen in the league ever before.
Awesome. Thank you very much.
Hi everyone, I'm here with
Amy Iguchi.
Nice to meet you. So can you tell us a little bit more about RMIC?
So RMRC is Rapidly Manufactured Robot Challenge. This is very new challenge if you look at the entire RoboCup. As a matter of fact, we did the first demo in the last competition in Brazil in 2014.
Okay.
Yeah. So those little fields, apparatus, is the challenge. And then those are all test methods that first responders actually use. So we're actually responding to the needs of the first responders. This is actually a real thing. It's part of the inter-rescue competition.
Okay.
But we have the smaller challenges, which is good enough for even high school students to start participating in the major rescue league. And this year we are using new test methods. So everything is, not everything, some of the methods are very new this year. So I'm expecting the teams to come up with very interesting, innovative challenge way of solving the challenges, and looking forward to see the solution.
The arenas are pretty amazing, not gonna lie.
Yeah, it's very complicated. Yeah.
What are some expectations from you for the events?
All the robots are 3D printed, and then they actually design the robot, and depending on the test method that they want to actually solve. So it's not like everybody has to do all the challenges. So they can pick and choose which one, the best one to get more points. They can choose remote operation, teleoperation, using the remote control, or autonomous mode. So very interesting to see which strategies the teams actually use to get the points.
Thank you so much.
Hello, please tell me a little bit more about yourself and what league do you represent?
Hi, I'm Will, and I'm the Junior Soccer Chair, so I manage both the Lightweight League and the Open League for the soccer divisions. The soccer divisions are a 2 versus 2 robotics competition where the teams will build their own 2 robots to verse another team's 2 robots. And we have a big tournament between all the different countries of the world, which is really awesome to see everyone come together for soccer. We have, again, 2 leagues, one being lightweight league, where they use like an infrared ball, which is very easy to see for the robots using like little sensors like in your TV remotes. And open league uses a orange ball that they use like cameras to detect. And we're slowly moving towards like a more realistic soccer game, using kind of eyes for the robots, and then drive motors to try and, play soccer like the big major leagues do.
Awesome. Can you tell me a little bit more? What are the main challenges of this league?
So some of the main challenges are obviously because it's a team versus another team, you're obviously battling it out for a soccer game, right? And so you're trying to always one-up each other in each competition. So every new year we see all these new technologies. So, year on year, we see all these new innovations trickle down to the teams. It's really cool seeing, high school students using crazy new technology that's just coming out.
And tell me more about your expectations of the event.
So I'm really keen to see what teams are coming out with now. We've got things like generative AI that is used for text-based applications, but also in AI, there's a lot of vision-based applications that we're starting to see a lot more teams use now. In addition, there's a lot more sensors coming onto the market and a lot of the prices of a lot of edge computers coming down. So there's this really new kind of availability for so many different teams to afford all this crazy new technology, which is really shaking things up.
Thank you very much for your participation.
Hi guys, I'm Sophia and today I'm here with
Gabriel.
Gabriel, what's the league that you represent here?
So here we have 2D simulation soccer. So it's a league about simulated soccer on multi-agent system. So the agents play soccer on a simulated server.
And what are the main challenges of your league?
So we don't have physical problems since the league is all simulated. So we need to focus even more on algorithms and how our strategy works. So we need to implement AI algorithms and enhance even more our strategies to make the team and the agents play even better.
Doesn't seem easy. And what are your expectations for this event?
So we have a lot of teams competing this year. So we have 10 teams. So with this competition, we expect that people can network themselves and also enhance even more their team codes, their source codes. So we have a evolution, a development of the league as the entire leagues seems to work. So we are expecting good relationships and everything else. Yeah,
it's gonna be huge. Thank you, Gabriel. Wish you luck and we see you soon. Hi guys, we're here in RoboCup 2025 with
Alan.
He's from the league, the technical commission from the league.
Well, I'm from the 3D Simulation League, and here we have humanoid robots, and they will have to play soccer, and which is kind of funny because in RoboCup, a lot of leagues will have to play soccer, and we use this kind of approach, so we are able to develop our technologies, and those technologies, they can be transferred to real life problems, so we can solve them in new ways.
Way too cool. Right, and what are the biggest challenges of your league?
Well, we imagine kind of a futuristic robot, so we don't have this kind of robots available here physically. We have robots that are more complex, they have more joints, and they resemble better the human body. So and our challenge here is they have to learn how to coordinate themselves, they have to learn new skills, they have to learn how to move in correct ways, and as they resemble the human body, they have more challenges than the other leagues that are the physical ones.
What are your expectations for this event?
My expectations are that we learn a lot, we share a lot of experiences here, and hopefully my team will win.
For sure. Thank you, Alan. We wish you the best.
me more about you. What's your name and what league do you represent?
I am Emiel Steerneman. I'm from the Netherlands and I represent the small size league.
Oh, awesome. Can you tell me a little bit more about the league and what are the main challenges of it?
So we at the small size league compete with very small robots. We might actually see a few of them there on the table. And what we do is we have one central computer that controls all of these robots. And we have our fields here. There are cameras above the fields. The robots have color codes on top of them, and then the camera sees the robots. That goes towards the computer, and then the computer decides for all the robots on the field what to do.
Oh, that's awesome. And let me ask you, what are your main expectations of this event?
I am looking forward personally to lots of Brazilian food, definitely. Yes. And because now we're also very close to different leagues like Humanoid, I'm looking forward to those, see what they can do. And of course, just lots of fun and lots of interesting new things.
Thank you so much for your participation. Hello, tell me more about you. What's your name and what league do you represent?
My name is Dr. Timothy Wiley. I'm from Melbourne, Australia, and I am one of the 3 executives of the Soccer Standard Platform League.
Awesome. Can you tell me a little bit more about the league and what are the main challenges of it?
Sure. In the Standard Platform League for soccer, every team has the same robot, and we are using the Aldebaran Now version 6. The challenge of our league is software-based. We ask our teams to write the best soccer to play 5v5 or 7v7 soccer. And it is all about the teams who can write the best code. And these robots are fully autonomous, so there is no human interaction. They play soccer all by themselves.
Oh, awesome. And tell me more about your expectations of the event.
I have been attending RoboCup for about 15 years, so I'm very excited to be here and see what we can bring to Brazil. We're hoping to have a fantastic competition with our 12 teams, and we're looking to see some fantastic soccer, some very strong results, and enjoy ourselves while we are in this wonderful country.
Awesome. Thank you very much.
Thank you.
Hi guys, we're back here with Katie. She's gonna talk a bit about SPL League. She's in the organizing committee, right?
Yes.
Can you present yourself, please, Katie?
So I'm Katie Gunter. I've been part of the various committees with SPL since 2013, so I've been around the league a long time. But this year I'm on the organizing committee, so we set up the schedules, we run the Instagram account, pretty much just do everything that needs to happen to make the organization run cleanly.
Amazing. Have you been here in Brazil last time? Oh, great.
Yes.
Yeah, and can you tell us more about the SPL League?
Yeah, so the SPL League is different than a lot of the RoboCup leagues you'll see in that all of the teams use the exact same robots. We all use the Aldebaran now. So instead of having to build your robots or like tinker with your robots, instead you're just programming the robots. So we're focusing on who can write the faster walk or who can see the ball better, things like that.
Thank you. We're gonna see the competition here, and I'll ask you to explain what's happening.
Awesome.
That's it. It's a play. We have 5 robots each team. Is that right?
That's correct. So at this phase of the tournament, we'll have 5 on 5. Later in the tournament, we'll actually move to 7v7. But yeah, right now we're just seeing the start of the game, so it's kickoff. In red, we have Be Human, which is from University of Bremen. In yellow, we have Now Devils, and they're from Dortmund.
So it's more difficult with more robots, right? Because of the size of the arena.
Yeah, so as there's more robots on the field, you have to better coordinate and communicate with your teammates. So you'll see when the robots fall down, they have to get back up on their own. But that robot there just got removed from the field because it pushed its opponent.
Oh.
So you're not allowed to push your opponents.
But even if it's not like, it's just, oh, I was by accident so close to you and...
Oh, that was a nice save. So yeah, you'll see the goalies when they're within their own goal box, they're allowed to dive, and as you saw, they just had a really nice save. But in the end, it didn't matter.
Sad.
So now, I guess one thing to kind of point out is that all of the robots are acting autonomously, so no one's remote controlling them from the sidelines. They have to figure out where to go and what to do based on what they can see on the field. So you can see the different lines, they can see their teammates, they can communicate with their teammates, but they have to figure out where to go.
Great. How was the vision? How you developed the vision of these robots, code and that kind of stuff, to make them so aware of everything around?
It's complicated. So back when I was programming a vision algorithm, probably 10 or 15 years ago on these robots, we would actually color segment each of the images that the robots got in. So we would literally sit there by hand and say what the different parts of the image were. So like you would code the lines as white, you would code the grass as green, you would code, back then we had different colored goals, so we would color that, and then the robots would try and find those colors in the image. But now there's much more advanced ways of doing your vision.
Yeah, we also have the outside, which get the colors kind of messy.
Yeah, so one of the challenges we implemented a few years ago was starting to have some games on fields with natural lighting. So if you were watching the broadcast yesterday, you might have seen our game that was actually in an outdoor field, still covered, so the rain isn't going to hit the robots. But I'm trying to get some like sunlight and clouds and things that change the lighting. But yeah, we almost had another goal. Let's see if Now Devils can save it and not score on themselves, hopefully. Oh no.
So close.
Oh, maybe? Oh, but here comes Be Human. Yeah, you'll see they're trying to do little dribbles. That's kind of a quick way to kick there. So there's another goal for Be Human.
The range of the kicking is different, or it's always the same kick, you know?
No, it's very different. So you'll see sometimes, so getting up to the ball and actually stopping at the right place to do a standing kick, it can be really hard. But like here on kickoff, you'll probably see Be Human, the team in the red, walk up to the ball. They'll actually do a pretty solid kick. But then if there's opponents around them, they're actually smart enough to know I need to do a quicker kick here, so they'll do a quick dribble. But yeah, Be Human can kick various different distances. They're a very advanced team.
Amazing. But and what about the rules? Do we have different rules this year?
We do. Each year there's some advancements in the rules. One of the cool things you'll see in our league is we have kick-ins. So if the ball goes out of bounds, the robots actually have to position to be able to kick it back in, and the opponents have to stay far enough away. You'll see corner kicks. I guess those were some of the bigger changes. We have two different kind of leagues. It looks like one of the teams must have called a timeout here. That's why all the robots got the message to sit down, and you'll see the teammates come out and pick up the robots. Each team can get one timeout per game, so I guess that's what we're seeing.
How long does the timeout take?
So the timeout can be 10 minutes, but you can also decide to end it early. So once a team decides to end it early, the other team has to be ready to play within 2 minutes.
Oh, got it. So how does the location, how does the robot know where is he in the field?
Yeah, that's a complicated issue. So historically, we actually had two different goals. We would have a blue goal and a yellow goal. So then you knew, okay, I'm starting on this half of the field. I'm always trying to score on the blue goal. So you could tell based on which goal was closer to you, kind of where you were. But now it's a lot more complicated because there's white goals on both sides. So you have to actually kind of know, okay, I'm walking into the field here, and then look around and see. You can see goals. You can see maybe things on the sidelines that you've trained for. You can have your opponents or your teammates telling you, hey, I'm here. I see that you're this far away from me. But it's complicated.
So does the robot know what side of the field he should be, or is you just put the robot there and it starts?
So yeah, at the beginning of the game, you'll actually see they'll set down the robots on the sidelines. So the robots know that's where they're starting. But then once they start walking, I mean, hopefully you can keep track of how fast you're walking and where you are. But yeah, some teams are a lot better at that than others.
How about the balance of the robots? I mean, I find it really impressive how they can stand. They fall and just get back so quickly, and it depends. They fall differently, and they just get up. How the balance works?
Yeah, so these robots actually they have gyroscopes, they have pressure sensors on their feet. So you'll actually hear the red team we were watching earlier. When you pick up the robot, they'll actually say, like, picked up. And when you put it back down, they'll say ground. So you can use those sensors, but yeah, I mean, you'll see like the robot just toppled over. Usually when you land on their side, they'll try and push one way or the other because they can only get up from their stomach or their back. And you'll see different teams have different get-up motions. Those are programmed by the teams.
Oh, great. And what about, so some things can happen that are not planned during the game, like if they get out of the field, what happens?
Yeah, so of course that's one of the things that makes RoboCup and especially SPL so interesting, is because you do have all of those unknown things that you have to handle. So yeah, if the robot starts leaving the field, then they're penalized. And then they're put out for a while, and then they'll be put back in a standard, like, known position on the side of the field, and then they can try again.
Oh, and I see people taking some robots out. Why does it happen? Is because of the robots, because of the team organization, or anything else?
Yeah, so usually it's due to something the robot did wrong. So it could be the robot falls and it tries 3 times to get up and it can't. Then it could get removed. It could be that it pushed an opponent, which, as we were discussing a few minutes ago, like, isn't allowed. It could be any number of reasons. The teams can also request at certain times in the game to pick up the robots. So, like, if, say, a camera's broken, once the robot isn't affecting play, they can be like, hey, can I pick up that robot? And usually the referees will let them.
Got it. About the referee, does the robot need to look for the referee, or is it not necessary to see for them to see the referee.
Yeah, that was one of the new things we added both last year and this year, was that the robots actually have to recognize certain referee signals. So at the start of the game, you'll see the referee hold his hands or her hands over their head, and that tells the robots, like, hey, it's time to go out into your positions onto the field before the beginning of the game. And then if the ball goes out of bounds, you'll see the referee stand on the sideline and hold their arm out in the direction of pretty much the team that doesn't have the kick. So you're pointing at the goal that the team that has the kick is trying to score on.
And can they like make a confusion, like mistake the referee with another person if another person stand his arms or anything like that?
Oh, definitely. And obviously we don't let like the teams. So you'll actually see an example. The guy in the orange shirt there is doing one of the hand signals. So he's saying that it's a kick in or a goal kick actually in that case. But yeah, if another human was standing there and was doing hand signals, the robots would be confused. But we obviously don't allow people to purposely try and confuse them.
It's because the referees always use this shirt. Is it make any difference for the robots, or it's just formal?
The shirts just look nice.
Okay. Okay. Wait, I forget. The robots are now. Can we know if the game is finishing or is the middle?
So this is the second half of a different game. So SPL, both for entertainment of the viewers, but also for the refereeing assignments, we have usually 2 games that we're interleaving. So we play the first half of one game, which you saw was the red team earlier, Be Human, and now Devils. And now, then we would play another half, and then we kind of switch back and forth. So this is the second half of this game, which is between Hulks, which is from Hamburg in Germany, and we have SPQR that's from Rome, Italy.
How many teams do we have?
We have 12 on site here. We probably have 20 or 30 total worldwide, just some weren't able to come this year.
How long does the vision of the robot go? How to where, like meters, or I don't know how to measure it?
Yeah, so since each team has their own vision algorithm, some teams can really only see accurately maybe for a meter or 2. The best teams can see 7, 8 meters, so pretty much all the way across the field. But again, it depends on what you're looking at. Are you seeing that your teammate is down there, or are you trying to see the ball? Like, obviously, because you can't see as accurately the further you go.
Yeah.
Goal! Looks like a goal for Hulks.
And where is the score? Do you have like a table with the score there?
Yeah, so on one side of the field, you would see the referee who was doing the hand signal earlier. And on the other side, we have pretty much a computer that is keeping track of the score. It's keeping track of the penalties. It's also, these robots communicate with each other as well as this game controller, so the system. So the system will tell them when certain things have happened. But it's usually delayed because we want the robots to listen to the whistle and see the referee signals and things like that. But there is kind of a fallback where they do eventually get messages from the game controller telling them, hey, it's time to go have another kickoff.
And just out of curiosity, what's the highest score you have ever seen at the end of a game?
So we actually have a mercy rule throughout most of the tournaments. So you can only, once you've scored, or once there's a goal difference of 10 goals, we call it, because you're probably not going to come back at that point. But we have had, I think, a game that was 14-4. So I think that's probably the highest we've seen.
Ooh. And is this why did you set this? Was it got to a time that it became common to one team do many goals and another one?
Yeah, I mean, we have varying skills of teams. So we have Be Human is always very good. And yeah, I think before we implemented that, sometimes they would just score a ton, and the other team, sometimes it would, and it's also a lot of wear and tear on your robots. So if you know you've already lost the game, like,
Yeah, but the way you count points to the finals is not like you count more. You have 10, and then you have 10 more and 10 more, or it's just like each time you have a play, it begins from 0, and it's just the team who won that play, they go further.
Yeah, so most of the ranking is based on who wins and loses. But if you have a tie at that point, then it can get down to goal differential, which can be difficult if a team is kind of capped at having 10.
Yeah.
But usually that team hasn't lost any games, so it doesn't really matter.
Got it. So this is Human and
No, so this is SPQR is in red and Hulks is in green. So it's a German team versus an Italian team.
Okay. The game is almost in the end.
It should be about halfway through the second half, I'm guessing. I can't see the time right now, but and I can't tell you who's winning either. But I mean, both of these two teams are very evenly matched, as you can tell. We're seeing good gameplay. We're seeing a lot of robots up and moving about. These are two very experienced teams too.
And do you having people close to the arena, does it does it make any difference in the play?
It can. So as I was mentioning earlier, the robots at certain points of the game are listening for whistles, or they're trying to see signals from the referees. So if you have a bunch of people around cheering, that can really make the whistle detection really hard. Sometimes the robots might also see balls and like people's socks or shoes. But yeah, so the more people you have around the arena, it's harder to hear. It can make the vision harder. They might see like that water bottle over there as a ball potentially. So, because a lot of times teams are used to practicing back home at their universities in this single lab that they know how it's set up. So then you get here and you're working in a completely different environment. So it can be really challenging. So here we'll see a corner kick actually. Or I don't know why he placed the ball there. That didn't make sense. Okay, yeah, so corner kick. So one team, the team taking the corner kick has to go in position over there, and the other team actually has to stay 0.75 meters away from the ball until the corner kick's complete. So we'll see if the team gets over there to take their corner kick or not.
But he just places the ball. He doesn't touch the robot or tell the robot anything for it to kick there.
So the robots would have gotten a message saying, hey, the ball went out. But then they have to look at the referee to see which way the referee is pointing, because that's going to tell them which team gets to take it. But it looks like the game is over now, so we should be switching back over to the Be Human game because this half is over now.
God, and how you decide in the first place? How do you decide which team goes against the other?
That's a complicated aspect. So coming in, each of the teams is ranked at the beginning of the tournament. And then as we get game results, we use the Swiss system to pretty much try and find like pairings of teams to play like each round. So we're in the fourth round right now. So we have to recalculate the pairings so that no one plays each other again, but then you play the closest person. So it ideally creates really good matchups throughout the tournament.
But in the first time, when the first games of the competition, how does it work?
Yeah, so teams are ranked 1 through 12 based on their previous performance in previous tournaments. And that sets the pairings.
Got it. Oh, we're seeing the outside now.
Oh.
Which is the one that's by our side.
Yeah, so you can see the natural lighting is coming in through those big windows. There's also a big dome over top. So to humans, this might not look like a difficult lighting setup, but you see that shadow that's coming across the guy that's walking across the field. And to robots, like, that can be really difficult to see in the vision because you're not expecting that.
What about the turf? We interviewed a guy that said that it's an innovation to have turf in the field. is it better for the robots or not, or is just to make it more, it closer to actual soccer with humans?
Yeah, so it's actually a lot harder for the robots to be walking on turf as opposed to, say, normal carpet. The turf is a lot slippery, and then it's also probably different here than what was in the labs. So teams have been walking on this certain surface, like every day as they're practicing, and then they come here, and it's one turf, and then maybe next year when we're in a different location, it'll be a different turf. So yeah, teams have to calibrate their walks as soon as they get here. In various different ways. Some teams do it automatically, some teams do it by hand. But yeah, the turf is very difficult.
That's a thing. I thought, like, since you said it was turf, then I don't know, maybe the same person, same enterprise would, the same company would give you the turf, and it would be here and in South Korea. Amazing.
No, you pretty much go to your local like carpet store, and usually we would end up buying carpet that you would put on your boats, so like on the flooring in your boat. But yeah, I don't know where they source the carpet here.
Great. Most of the teams, they are formed by students, right? Researchers. How does it work? How a person can get into a team?
Yeah, so different teams have different setups, but most teams are based at a university. So the first step, if you're already at a university, would be seeing, does your university have a team? Or, I mean, we've had teams that have actually been created from scratch from people that have just really wanted to participate in RoboCup. And I mean, maybe they're undergrads and they have undergrad clubs. So we've had that from a few teams. We've had like Josiah, who I think you talked to the other day. He actually was part of a team that was in RoboCup, and then he went to his own university as a professor and started his own team. Or if you're looking at where you want to go to college or university, you can pick a school based on which ones have teams. That's actually what I did when I was looking at where I wanted to go for my PhD. I knew I wanted to do RoboCup, so I ended up going to the university I did, not solely because they had a RoboCup team, but it definitely played into the factor.
And what is your PhD about?
So my PhD is about algorithms for robotic birds, pretty much writing algorithms to influence flocks of real birds away from airports and wind farms. And I actually did some cool like simulations using the nowls where they would flock and then another now would come in and influence the flock to go around.
Oh, amazing. Katie, and what you're thinking of about the event? Is it okay? Is it like regular? Everything is working on.
Oh, this event's been great. It's been really well organized. The fields were like nicely set up when we got here. There's been so many good volunteers. Like it's been a really good event.
Thank you so much. Is that anything you want to add?
I don't think so. If you're in a country that has RoboCup teams, see when they have demos at the universities. There's usually open houses, so it's fun to go see it in person.
Yeah, I want to thank you so much, Katie. It was amazing interviewing you. And now we're gonna go to our next league. It's logistics. Thank you all for sharing this with us. Hope you have enjoyed it. Bye.
Bye.
Hi guys, we are back again, and now we are going to see the logistics leg.
Hi.
And I'm here with Till. He is the representative of the league. He represents the logistics league. And now we are going to get to know more about this league. We already shown yesterday, but I would like you to tell an overview about the league.
Yes, so the idea of the league, and I think we're going to see some pictures in a second, the idea is that we have a team of robots that need to build some product. So you can imagine like in a car factory where they need to assemble all the pieces to build a car. And so the robots need to move from the machines and transport all the different pieces and assemble them in the station. So it's very different to all the soccer tournaments that we see here. So it's more like an industrial robot that is tasked to produce something.
Awesome. So do we have the video of the arena? Not the video, actually, live stream of the arena. Just in a second, so we can see what is happening now, right? So awesome.
Oh yeah, so we see that the game has just started, and you can see it in the picture that we have these boxes, and these are the stationary machines, and these do the manufacturing. So the robot brings a piece to that machine, and then tells the machine, okay, now put, for example, a blue cap on my product, and then the machine continues. And the robot again needs to pick this up and then feed it back into the next machine. And it needs to do this for like a sequence of many different steps until at the end it has produced the product that was requested.
That's awesome. So, okay, I see 3 moving robots. Are on the same team or different teams?
Yes, so so each team consists of 3 robots, and they need to actually cooperate because this manufacturing is so complicated that a single robot usually can't even succeed at the task at all. So they need to communicate and tell each other, okay, I have done this step, and now you pick this up and put for example, a green ring on this piece, so we can continue then with the manufacturing.
Awesome. I have a lot of questions right now. I'm really interested in how this works. But just to confirm, the machines we are seeing that have a kind of not a QR code, but looks like a QR code on it. They are they're not moving. They are from the competition.
Yes, exactly. So these boxes, these machines, they don't move, and they are part of the playing field. So the team only consists of these 3 robots. And these machines are they're not smart at all. They just do what the robot tells it to do. So if the robot doesn't instruct the machine, then it just won't do anything at all. So all the smartness, so to say, has to be in the robots. And
so the robots need to do the mapping and know which machine to use and how to use.
Yeah.
And how is this communication between the robots and with the machines? Like, how do a robot say, or how the machine knows what it has to be done?
Yeah, that's a great question. So first of all, initially the teams don't really know anything at all. So they don't even know where the machines are. They first need to move through the field and find all the different machines. And then once they have found them, they can instruct them to do tasks. And because this is in an industrial setting, this is done basically through Wi-Fi. So they send a command through Wi-Fi that encodes exactly what the machine is supposed to do. And then the machine eventually tells the robot, okay, I now succeeded the task, you can now pick up the workpiece again.
Oh, so it's Wi-Fi signals like request.
Yes,
right?
Exactly. It's a request, and then the machine responds with what the status is. And this is actually actually one of the huge struggles that actually many teams have, because, well, you can imagine at home usually your Wi-Fi works quite well, but here in this setting we have thousands and thousands of people,
Definitely.
many robots, and sometimes the machine just takes a minute to reply, and then the robot kind of needs to decide, okay, what am I gonna do? Am I gonna wait for the machine, do a different task, and so on? So, yeah.
Yeah, but in real world, I think guys might have this problem too. Like machines in companies might have a little bit of problem, can have. But yeah, we see on flying robots, do you know, the drone competition, the Wi-Fi, not the Wi-Fi, but the connection was a problem as well.
Yeah, I guess
So,
it's a typical RoboCup problem.
Yeah,
but
yeah,
also
exactly.
in industry, actually, this is a very huge problem. This is why technologies like 5G are so important, because they allow most of our reliable communication, but also provide the bandwidth so they can actually send all the data that they want. And even though Wi-Fi works well enough for watching Netflix, for example, for a robot, the connection needs to be there 100%. And this is just and you won't even notice, but sometimes your laptop may disconnect for a couple of seconds, but Netflix buffers enough, so the video will never stop. But for a robot, that's not enough, because it needs to communicate in real time with the machine.
Definitely. For communication in real time, like in really real time, you definitely need a strong communication. And I mean, it's very impressive. And I just thought that we have a lot of numbers on the ground.
Yeah.
What they are?
So these numbers are only for the referees, so they know where to place the machines. The robots don't use them, but actually, for the robots, it's easier to find out where exactly they are than for the humans are, because this is such a big field. Then the referees often get lost in where do they need to put the machine initially. And here we can now see how one of those robots feeds one of those products, and this is actually a finished product. So this is now the delivery to the customer, which is so now it is finished, and
Oh my God.
the team actually scores. I'm not sure how many points, but this looked like a rather high rewarding product, so it's gonna be maybe 100 or 150 points maybe.
So just to make it clear, it's a real product. Like I thought the machines were like the robot says to the machine, I needed to do that, and the machine's like, okay, I received a message, I did that, but
They actually do. So as you can see here, we see one of those example products.
Oh my God.
And now the robot's gonna feed this into the machine. And if we just watch what happens for a second, what the machine does, so this product's gonna move through the conveyor belt. Now the machine disassembles this. And then the robot eventually will move around the machine and pick up this workpiece and then continue with the next step. And this really, so one of the big challenges here is that we actually have many of these steps. So often we need 10 or 15 machine steps to actually produce one of those products. And then the robot actually needs to move around between all the machines, because every machine has its own purpose.
Yeah.
So they can't just be used interchangeably. That's why, for example, now the robot picked that up and gonna move on to the next machine and then do the next step there.
And you have a certain order to do that. Like
Right, exactly.
you cannot do with oh, now I want this machine and I can choose another. No, you need to follow the sequencing, right?
Exactly. And as you can, so for each product, you need to follow the sequence, but the robots manufacture many products at the same time. So you've seen they delivered already one, but now this is like now the final step of the next product, and you can see how this consists of multiple pieces.
Yeah.
So you have this one big red piece at the bottom, then a small green, and then yellow and another green. So 3 different rings, and then finally on top this cap. And so these products look kind of silly, to be honest, but they kind of resemble like all the different parts that you have. So if you think about this as like for example a car, then you would have the engine, which would be the red piece, and you have the different wheels and the roof and the seats in the car and so on. And the assembly itself here is very simple, but apart from this problem is exactly the same as you would have as a car manufacturer.
Yeah, that's really awesome. And the communication between the robots, they are from requests as well, or they are different?
No, so I guess there are many different approaches, but so different teams use different things.
So this is part of the challenge as
yes,
well.
Yes, exactly. Yeah, yes. So there are some constraints by like the rules, but basically the teams can decide what they want to use. So some teams have one central control that tells every robot what needs to be done. And the advantage is that you have all the information in one point.
Mm-hmm.
The disadvantage is if the communication is problematic, or for example, a robot fails to do something, then this may break down easily.
Yeah.
A different approach would be more distributed. Each robot really acts on its own and only tells the other robots, okay, I'm currently doing this. What are you doing? So this requires a lot of more interaction, but makes it a bit more reliable, I guess.
Yeah, more reliable, definitely. Because if the central communicator stops working, then you have no communication at all.
That is true.
Definitely.
Yeah, but I think so. The team that we are currently watching, which is Car Logistics from Aachen, I think for a long time they used this distributed strategy, but in the recent years they switched to one single agent, what we call it. So one single control that controls all three robots simultaneously.
That's awesome. And can you tell me more about the team? Like, if you know which team won last year, RoboCup, and if you have like the top 3 strongest teams?
Yes. So last year's RoboCup was won by Team Grips from Austria.
Awesome.
They are unfortunately they are not here this year. But the second strongest team is actually the team. Well, second strongest team last year is the team that we are currently watching, which is Car Logistics from Aachen. And we actually got something very exciting going on this morning. We had the highest score in all the games in the whole history of this competition.
And this happened today?
Yes, this happened this morning. So I'm looking forward to the result of this game because I think, again, they're working quite well. We can see already they have another finished product. So
let's see another new record,
yeah, maybe we're watching the new record right now live.
It would be awesome. So we need to keep going and watching. This is very amazing, this competition. Like, I was there, and I confess I couldn't understand. Like, okay, but why do I have stopped machines? Like, fixed machines, and what are the robots doing right now? But looking as we can in this view, we can understand exactly what is going on, and this is very awesome. And I have another question for you. How do the robot understand how and where to put the product? Like, they have some computer vision on it, or just some sensors? How does it happen?
Yeah, it's actually also many teams. So every team has a different approach, I would say. But I guess most of them use computer vision to detect these conveyor belts. But this is actually a bit challenging because you can see these machines are very cluttered with a lot of cables and so on. For us, it's actually difficult to see where exactly is the conveyor belt, where it needs to be put. And at the same time, it allows only a very small margin of error. Like the robot needs to put this piece like within 1 millimeter of error range on that machine. So that's quite So the computer vision and manipulation task also is actually a very big challenge in this competition.
Very, very big, because if we are going like we are watching right now, I cannot see where to put the product.
Right.
I know that the robot is very. Oh my God! They just
small crash, but
excuse me, right? This happens a lot, right? With us as well.
As long as they don't crash too hard, it's not a problem. Yes.
As long as they don't fight.
Yeah, exactly.
So it's very difficult because these machines have, as you said, a lot of cables. We have lights, as we're seeing now. Like it has a lot of things that can make the robot kind of confusing. You know?
Yes.
It's like, and I don't know. For me, I think it's too hard. I mean, this is awesome.
Yeah, maybe you can comment a bit more on the sensor. So what you can
Yeah,
see very
please.
nicely right now is these two black cylinders at the bottom. And these are laser sensors, and they scan the environment by basically sending a light beam in every direction and then measuring the distance to the next object.
With the receiving the light again,
Yes,
the
exactly.
reflection.
So it reflects,
Awesome.
comes back, and by doing so, you can create a map of the environment, and you can use this to find out, okay, where the robot is actually located.
Oh, awesome. And I know this is not the only sensor, so can you tell me a little bit more? I mean, as you said, every robot has its own strategy, its own hardware, but I imagine that if something is going, it's good for the robots, the another teams can do it as well. So how is the other sensors, or do you think this reflection is the principal, the main? Sorry.
So I think every team uses these laser sensors, and actually I would assume that in most of the competitions here, many robots have a very similar sensor because they're very reliant. They're very exact, like they measure the distance within millimeters, so this allows a great precision and localization. Apart from that, I think most teams have multiple cameras on their robots, and there are actually different types of cameras that are quite common. So we have just a plain camera, which is really just a camera image as you would have on your webcam, for example. Actually, some teams use webcams.
Use webcams, yeah.
But there are also some cameras that, in addition to like a normal camera image, they also measure the distance to each point on the picture, and this gives them like a three-dimensional image, exactly. And this allows for like finding out, okay, for example, how far do you need to move to the front until you have reached the object.
Oh yeah, because the robot is placed exactly in the as you said, 1 millimeter of error.
Yeah. Yes.
Must be so hard. So another question I have to say is, I saw that we have participants walking through the space. Is this allowed? Of course. How does it work?
So these are the referees, and they really only they make sure that sometimes the machines need to have some maintenance. For example, if the machine is used very often, then it collects some trash, and this trash just needs to be moved out by the referees.
Oh, awesome.
So, for example, here we can see that the team actually completely used all the pieces on the shelf, and then we saw someone walk in to just replenish the shelf. But apart from this, there's really no interaction allowed at all. So the teams can also not instruct the robot to do anything during the game. They need to act completely autonomously, and they need to decide, okay, which steps they want to do to achieve the goal.
That's really awesome. And the robots can deal with people around, right?
Yeah, definitely. So this is also, for this they use these laser sensors in the bottom of the robot to detect dynamic obstacles, and they will just move around them usually.
This is awesome. This is very, very awesome. And we are seeing the same team?
Yeah, I think the game has just ended, which we can tell by these flashing red lights, which indicates that we are now at the end of the game.
Can you explain a little bit more about the lights? Like we have red and green and...
Yes. So the lights are actually only for the referees to understand what the machine is currently doing.
Perfect.
So we have some feedback of what's going on. So the robots don't use the lights at all because they already have the information from the machine. But we as humans, of course, we can't look into like the memory of the machines, and we also can't communicate via Wi-Fi with the machine. So that's why, in addition to this, we have these lights.
These lights, okay. So green stands for a free machine, like a
Yes.
machine that the robot can use. Yellow.
Yellow flashing means that the machine is currently doing something, so like a processing status.
Yeah.
And then once it's done, it just shows yellow and green, not flashing, but just continues to indicate, okay, I'm done. You can pick the workpiece up.
That's awesome, really. And what do you think? I mean, we have talked a lot about all the challenge, but in your opinion, what do you think is the main challenge? Like, in your experience, what do you think is the hardest thing to do, or the hardest challenging to achieve?
So I think in the logistics league, one challenge that's very specific for this league is the planning that is involved in these manufacturing steps, because the robots need to do up to, I don't know, 70 steps to actually fulfill the goal to produce something.
That's a lot.
And if they do any mistake on the way, then they need to correct and actually understand what's going on. And just this planning part, the strategic reasoning, is one of the big challenges that every team has to face, and also every team kind of develops their own strategy to this.
Awesome. So we have how many teams here in Brazil competing right now?
So this year we only have 3 competing teams, but usually we have more, usually 6 or 7 teams that compete.
Oh, okay. That's very, very nice. So we hope for the best for the team that we just saw. And this is awesome. And I'm very curious more about the robot. I know that a lot of robots have different hardwares and is open to the team to choose, but do you have some requirements, like some criteria, like the robot cannot be this size, should be this size? Do you have something like that?
So this is actually, so we only have very little requirements now. So the main thing is that the robot cannot exceed a certain height. So for example, you want to avoid that the robot just grabs over the machine and manipulates things.
Yeah.
But apart from this, the teams are very free to choose which kind of hardware they use. We have some limits also how wide the robot is, because we always have 2 teams competing on the same field at the same time, so we don't want one team to block the other team.
Oh, that's awesome. So some competition, it's simultaneous, like
yes, exactly.
Really?
So in addition to all the planning and so on,
Oh my God.
they also need to make sure that they don't collide with the other teams.
So the robot should be okay. I'm sorry, excuse me.
Yeah, exactly.
Oh, that's awesome. Very, very interesting. I mean, I thank you so much for all the information. I don't know if you guys in the live noticed, but I'm very curious and interested about it. It's really, really an awesome league and an awesome competition. And I thank you so much for all the information. And I hope you can see more about the At Work League. Or work. No, sorry, logistics. It's because I saw it looks so much like a workstation.
Yeah, this is true. Yes, actually, we have many things in common with at work, so I don't really mind if you confuse the two.
And I think logistics is one of the most important things in every organization, company, industrial. So yeah, I think it's something I'm really, really happy to get to know about all this. Thank you so much for your participation.
Thank you for having me here.
And now we are going to see in seconds the Humanoid Kid Size League. So now let's see a little bit more about the event.
pensar que a gente... O Ava entrar agora no ar. Eu já falei pra ele, quando acabar aqui, em vez de fazer isso, ele não quer que eu veja aqui. Ele só quer quando a gente vai ficar meia hora fora do ar. Porque vai ser retransmissão. 3h30 para 4. Aí já tem meia hora. Aí eu vou ficar lá ou aqui? Lá com a Black Magic. Entendeu?
Isso aqui é rapidinho também.
Ó, e aí quando a gente fizer isso aqui tudo, eu vou pedir que você suba com ela aqui. Eu não vou falar com o Roberto, você vai chegar lá com a câmera, a Fabio mandou trazer. Ah, por quê? Porque ele tá sendo inutilizável.
Quando vai utilizar, não
porque
presta.
o Fabio falou pra ninguém chegar lá e se bater. Entendeu? Pra depois você bata pra gente. Ele não tá usando.
Vai eu aí, ó. Bata pra gente, cair, quebrar.
Tá entendendo? Então, acabou aqui, quando ele sair também, for fazer as paradas aqui, você pega a câmera, chegou lá, bota lá no tio Roberto, a câmera pra ele saber que tio. Não, mas ele falou pra ele que a câmera tá lá. Mas por quê? Porque tá sendo inutilizado, porque ele não pegou nem ontem nem hoje. Aí ele tem que ver o que é. Eu acho que deve ser um conversor. O conversor é a saída. A saída CGI da câmera.
Tá ruim?
É, não pegou.
Ah, é aquela de ontem? Teria que conectar tudo em outra câmera. Mas ela, quando a gente testou na quarta, ela pegou.
Mas logo de começo, depois parou.
Depois parou, é.
Mas aí pode ser o conversor.
Então foi alguma coisa.
Não, bom, a gente pegou ela, colocou ela, puxa, pegou. Aí ele aproxima mais aí. Tipo, a gente tava aqui e tava filmando lá. Aí pra ir mais pra frente, tinha que botar a extensão de energia. Esse desligou tudo, botou emenda de energia pra não for pra lá, não pegou mais.
Então ela pode ter sido configurada mesmo.
Não, eu consigo ler tudo de novo.
Não, mas talvez não seja só isso.
Mas já tá indo.
O brother
É porque tem que estar intercalando com... Mas é o de Ângelo, ele agora tá descansando.
Hello everyone, back again. And now we're going to see the humanoid kid size. So we do have image. I think the game is going on. So, and I'm here with the representative, with the spokesperson of the league. So please tell me more about yourself, your history with RoboCup, if it's your first time, not your first time, if you're competing or not. Tell me more about yourself.
Yeah, thank you very much. Hi, my name is Jan, and I'm from the Hamburg Bitbots RoboCup team. We are also participating in the Humanoid League normally. This year we are not playing, but just supporting the league.
Awesome.
I'm studying computer science in my master's currently, and I started at the RoboCup team in Hamburg in 2018.
Really?
So. I have a few years of experience already, and went to a few RoboCups.
So I think you may know a little bit about what you're talking now, right?
A little bit. And
just a little. Just
it
kidding.
seems like the game already started.
Oh, really? So okay. Can you? Okay, this was a goal. Can you explain me more what is happening now?
Yes, of course. So in our league, we are playing with humanoid robots. Humanoid because they are like a human. They have the same joints. They can do similar movements, and they have sensors like a camera, and they can detect when they fall and so on. And they have to play soccer in a team here, 4 against 4 players, and it's all done autonomously. So. There's no human controlling the robots. It's all done inside the robot.
Really? That's
yes.
awesome, yeah. I think most of leagues here are autonomously, right?
Yes.
And this is awesome. So can you please explain why kid size? Like, okay, we have humanoids, but kid size? It's because they are small like kids?
They don't have... really behavior like a kid.
Oh,
it's
awesome.
still a robot. It's called kid size because the robots are smaller than 1 meter.
Oh.
And we play on a smaller pitch, 4 against 4. There's also the adult size league where they play with robots above 1 meter. I think most are 1 meter and 30 centimeters or 180. And I believe they are playing now since this year with 3 robots. In the past it was 2 robots.
Awesome.
Yeah, the leagues changed a lot during the past year.
Yeah.
Because in the adult size with the larger and heavier robots, there was a robot handler, so a human standing behind the robot, walking behind the robot to catch them when they fall. But these robots, they're capable of falling and also standing up again.
Really?
Yes.
Like they know if they just fall.
Yes, they have a similar sense like we humans have in our ear. There it falls.
Oh.
And you can see it's getting up again.
So fast. I think faster than me.
And this team just told me they also worked on their standing up capabilities and they improved it from this competition.
Really?
It's maybe not always working.
Yeah, no, but it must be very hard for them. But can you explain me? This is the game happening right now, or?
Yes, it's a game. We are seeing the red team with player number 1 at the moment. You can see
only
3 robots. One robot is missing at the moment. The red team is Team Roban from Bordeaux in France.
Awesome.
And they're playing against the blue
The
robot.
blue
You can
ones.
see it in the background.
Okay, I'm seeing now.
They apparently weren't ready yet. The blue team is Utra from Toronto in Canada.
Oh, so you tell me, you look like you know a lot about the teams, the name, where they're from. How many teams are competing here in Brazil at the RoboCup 2025?
I had to look this up for this year.
No,
and the kid size, there are currently 13 teams participating.
Oh, really?
Yeah, like we from
That's
the
a
Hamburg,
lot.
we as the Hamburg Bitbots also were qualified but then withdraw.
Oh.
So we are just supporting the league and taking place at the academic conference afterwards. And in the Edit Size League, there are 5 participating teams.
Oh, awesome. So in the kid size league, we have more participations, more teams.
That's also because it's much easier to handle the small robots.
The small
They are-
ones.
You can take them in your hand luggage in the
Yeah.
plane, so that's cheaper.
Yeah,
They're not that
easier,
heavy, easier
cheaper.
to repair.
Yeah.
Yeah.
So can you explain me? I'm really curious about how they see. And I was talking with the representative of Logistics League, and they tell, they use computer vision to see.
Yeah, that's right.
That's right. So these robots use it as well, right? And can you tell me, as a competitor, right, how they know when they fall? Like, is they look at the sky and like, okay, I think I fell, or
No.
a sensors?
They don't do everything with computer vision. So these robots, the roots say what sensors they can have and which ones they don't.
So they have restrictions, right?
Yes, they can't have any non-human sensors like some laser distance measurements or
That makes sense.
magnet sensors or so. So for most things, they utilize the camera for computer vision.
Yeah.
They can have up to 2 cameras in the head. It must be in the head. But most teams just use one camera at the moment. Right, and they use the camera to perceive the environment, to detect the ball, other robots,
Awesome.
teammates. They have to localize themselves to find out where are they actually on the field.
Awesome.
So they don't score a own goal, or so they can plan their behavior and pass balls to other teammates.
Perfect.
And for falling, yes, you could use
The camera,
some
right?
vision, but mostly it's just an initial measurement unit. It's called IMU. It's measuring the rotation and just the acceleration. So
Yeah, so when a robot fall, the signal, it's like, right?
yes, when the robot falls, we can see, okay, the
Something
orientation
happened.
changes. So that's also how we know we fell to forwards or backwards.
Oh.
And depending on that, we have to do different motions to get up again. It seems like it's already half time. The first half time is over, so we have a 5-minute pause.
Oh, okay.
Now the teams can change the batteries and restart the software, change some behavior or something
Oh,
like
really?
that. Yeah.
So they have this new chance, right, to change something that is happening. Just like, okay, when he falls for the right, he cannot get back again. So let's change it. But they
Yeah.
only have 5 minutes, right?
Right. And I know Team Roban, they have 5 robots, but they can only play with 4. So they can substitute a robot if one is damaged.
That's awesome. Can you explain more about how the game works? Like, it's like the usual soccer or the humanoid soccer that we saw, like a lot of robots running to get the ball, or it's a little bit different? Do you have tasks or specific goals?
The main focus of our league is just this soccer game. There are also some technical challenges in the background and a software challenge just to keep up improving.
Yeah.
So it's similar to the human soccer. The rules are actually based on the official FIFA rules,
Really?
just adapted for our purposes.
Yeah.
Of course,
Awesome.
because we have a smaller pitch and we have to specify how the robots can be
Yeah.
designed. But yeah, it's really based on the human routes. And actually it's the goal to get to the human level. In 2050 we are planning to play against a human team with robots. So that will be really exciting. And in order to get there, the routes get harder each year.
Oh, really? The rules? Oh, that makes sense. So the rules, the restrictions on the hardware or software are totally made to make this more difficult, so people can improve and improve, right?
Almost 7 years ago when I started, there was a change from just green carpet with white tape on it to this artificial turf. It's like plastic grass, 2 or 3 centimeters high. And when they did this change, no team could walk anymore.
Really?
And every team had to adapt. Some could do it quicker, others not. And these lines are just white paint sprayed on there. And during the game, during the competition, these white lines fade, and it's really hard to recognize them. Sometimes they get repainted, but these lines are really important for the robots to localize themselves because the field is symmetric, and so it would be easy for them to switch sides and play against their own team. And we, for example, use this line detection. We detect all lines in the camera image, and then we look, okay, at which position on the field do these lines match with our expectation? Beforehand, we already know where the lines should be, so that's how we can localize. And then also strategize. So these robots, we play 4 against 4. So 4 robots in one team, they can communicate with each other.
Really?
Yes. Currently, they do it over just normal Wi-Fi.
No way! I really just thought that. I'm so sorry for telling you that, but once I thought they were just running for kick the ball.
Yes.
I really thought it was just that, but they have strategies.
There's a really wide, a range in this league from different behaviors. I know some teams just implemented the localization. They didn't have that before, so it was not really useful for them to communicate, but now it's changing. And this team, Roban, we were showing a second ago. Roban was is not the current champion, but Roban won the competition a few times in the past. So they're really good, and they're communicating a lot over Wi-Fi, as I said. In the future, we have to change that because humans can't communicate via Wi-Fi. So we have to change to gestures and speech and sounds. Yes, and they tell each other where they believe to be on the field, what they're planning to do, like where does each robot want to go, where do they see the ball. So when one robot just fell and has to look but doesn't see the ball, he can ask the others, where do you see the ball?
Where is the ball?
Yes. And they decide which robot goes to the ball. We do it just based on which robot can get there the quickest. Yeah.
I mean, that's awesome. At the same time that I'm speechless, I have a lot of questions, and a lot of ideas for the future. Like, do you imagine if we have someone telling, okay, halftime, come here, robot. So we need to do that and that. Only everything autonomously, like robots listening to robots.
Yes, that's where we are going to, but we're currently not there. Obviously, we can see we still need a lot of human support.
Yeah, definitely.
And there are also human referees. Each game is supported by 3 referees. One main referee who is on the field with a whistle, and this referee starts the game. Then he has a support on the game, on the field.
Yeah.
And here behind the screen we see a third referee. This person sees some control software where the person just tells, okay, this team scored a goal, or this robot has to go out because he did a foul or got a card, a red card, and has to leave. So this game information is shared also via Wi-Fi. So the robots receive a signal when the game starts, and they know how the score is. So if they are in lead or if they have to play stronger.
That's just awesome. I mean, I'm still processing the information that before the field wasn't like this. The field was just a green ground, and then in 1 year everything changed, right? And you
Yeah.
have to adapt. I'm still processing this information. This is awesome,
Like-
but yeah.
This Humanoid League exists now for over 20 years.
Really?
And obviously a lot changed during
A
that.
lot changed, yeah.
We have much more processing power. So in the past,
You're right.
teams had low resolution cameras, and it was hard to detect the environment. So also in the past there was a strong orange ball, easy to detect, and the goalposts were colored differently, so you could see by the color which goal you're looking at. and so on.
In junior, we have this of course, like the small junior soccer, we have this colored goals,
Yeah.
so they can see it's kind of easy to detect which goal you should try to do the goal.
Yeah, that's where we are coming from. So you're from a junior team?
Oh, we just did the interview with the junior teams, but I was more of a rescue competitor, you know. So I'm really just learning a lot with you guys. Really, it's getting awesome. And so I think they're on the halftime, but when the game starts again, we're going to see. So I need you to tell me some basic rules of the game, because you said, okay, it's based on the FIFA rules, right? FIFA soccer rules, but how can I say if that is a fault, you know? How can I say that, do we have side kicks? Do we have goal kicks? Can you tell me the main rules there are equal or similar to real soccer, and then the rules that are very different? Can tell me?
I can try. I'm not that into the rules because I never was a referee, for example.
Yeah.
Each team has to has to have a member who can referee the game.
Really?
Or multiple, but I've never done that, so.
But it's okay. Just try to
I
say
can
what
try.
you remember, okay?
Yeah, we play 10 minutes each halftime with a 5-minute pause, as I said.
That's a lot.
Yes, the first halftime just starts with one team having the kickoff.
Awesome.
They can be inside the middle circle and kick off, and they have to do one pass, or they cannot directly kick into the ball. There has to be
really?
another kick before that.
Oh my god.
Yeah, so even when you're playing against an empty field, you have to.
you
do
cannot
some
kick
more.
directly
No,
to
no.
the goal. No way.
Right, and yes, there are the penalties as we know them. There's a free kick, a goal kick, also a corner kick, I believe.
Yeah, corner kick.
And when the robots don't behave, they have to go out. They then get taken out by the robot handler. Each team has a robot handler. You can see the person with the blue jersey in the back. This is the only person from the blue team who can touch and handle the robot. And
That was a goal.
that was a goal, right?
Oh my god.
Unfortunately, I don't know the count score, but I believe red is in the lead.
Yeah, I see only one blue robot.
Yes, and the blue robot is also quite
Maybe a little bit
a little
confused,
bit
right?
a little bit smaller and slower.
Yeah. But they are awesome. Can you here? The robot, it's outside the field, right? The blue robot. Can you explain me why? I mean, if you don't know, it's okay. We're just seeing
I'm
this right now.
not sure why it was taken out in this particular situation, but now we are seeing it walking back in and trying to defend.
Yeah.
Let's see if it just walks.
Yeah, just
Yeah,
it's very
because
hard to balance it.
smaller, it's also a little bit slower than the red robots. Obviously, the red robots are really good because they are multiple times champion.
Really?
But this year it's much harder. There are newer teams in our league and new robots who are much more robust and also even larger than the red ones.
Really?
They can really run quite fast, so it's hard to compete against them.
In your team, what were you responsible for? Like hardware, software, or the kick? How was it?
A little bit of both hardware and software. At first I started with computer vision.
Oh, awesome! I really love this area.
So at first I worked on the ball detection
Awesome.
and the overall vision system. Then it moved to more machine learning. So now we are doing using some neural networks like artificial intelligence for computer vision. Where we detect the balls and the robots and the lines in just one step. And then it moved to a lot of organizing. There's always a lot to organize in the background. And also hardware. So I started designing some 3D parts for 3D printing.
Oh, that's awesome.
We can print some parts ourselves, but unfortunately we don't have the capability to machine metal or carbon fiber parts ourselves. That's where we have had a cooperation in the past with another humanoid team.
That's awesome.
They produced the metal parts and so on for us, so
This
we could do the
collaboration.
rest.
Yeah.
Our team also does some electrical engineering ourselves.
Really? Oh.
And then also my job is to solder on the PCB boards.
That's awesome.
That's also a lot of fun.
So for you, as you said, you have experience both software and hardware and computer vision. For you, what is the main challenge of this game? Like, what do you think is more difficult to do with the robot? Like the kick, the seeing each other, communicate maybe, or kick one to another. What is the hardest thing to do?
At Hamburg Pitboards, our main problem is definitely the robustness of the hardware.
Oh yeah.
So the robots break a lot. They can fall and stand up. They can stand up like 3 or 4 times, and at some point they break down and don't want to stand up. Yeah, you saw the robot also having a little bit of a problem getting up again. But Roban, their robots just survive. They can play a whole game and we probably have to take them out and change the motor gears and change some cables in between. That's really stressful. And after each game, we have to do a lot of maintenance. So
yeah, I can imagine.
that's our main problem. The software works pretty well.
Oh yeah, so
when we play in simulation, we
it's
do
very
really good.
it's very awesome. Thank you so much for everything.
Thank you.
It was an awesome participation. I really like talking to you because I am so interested in this soccer, the kid size. I have a friend who is trying to participate. So thank you so much for participating with us and talking to us. It was awesome. Thank you.
Yes, it was awesome. Thank you very much.
And we are getting back soon. And the next league we're going to see is RMRC. So I see you in some minutes.
Hi guys, welcome back to RoboCup 2025 live streaming. We're here with Amy from RMRC. Thank you, Amy, for being
Thank you for the
here.
opportunity. That's great.
No, it's my pleasure. Amy, can you present yourself to us, please?
Yeah, so my name is Amy Gucci. I'm a college professor, but here I'm one of the organizers running RMRC. That's a part of the rescue competition, but small challenge specifically for a smaller robot. Because rescue robots are gigantic and very expensive. RMRC uses very small 3D printed, less expensive, affordable robots, and then each team design and develop their own robots, and then you can see the different sizes.
Yeah. Is that what you teach about?
No, I don't. I'm under education, so my daytime job is to teach students to be teachers.
Oh, great.
But my focus is computer science education, education robotics, and AI literacy. This is part of what I do.
Amazing.
Yeah.
How long have you been in participating RoboCup?
So I am also RMRC is something called Bridge Challenge. That's very new sort of initiatives that we started to bridge the junior competition with the major competition because there is a big skill gap, technology gap, and a lot of high school kids who are advanced don't have place to go, but also undergraduate students struggling to get into the major league. So we are sort of accepting those students and giving the opportunity for them to do robotics. But also I am part of the junior league, and then I'm part of the Onstage committee, not Onstage committee, but Onstage competition. And I'm one of the people actually started RoboCup Junior in 2000. So this is like 26 years. That's crazy.
Oh
to
gosh,
think about.
I think you're the person with more experience that I have interviewed.
Maybe you're not born yet.
Yeah, I wasn't. Amazing.
Yeah,
Amazing.
it's been a long journey, I think.
Yeah. So RMRC is it a new league?
It's very new, but fun fact. We did a demonstration to the junior teams in Brazil last time in 2014. So we're coming back to where we were born. Yeah.
So special. Amazing.
Yeah, so like 13 4 years that we have been trying to do RMRC. Yeah.
Oh, great. So we're seeing a competition live, real time. Can you tell us what's happening there?
Yeah, so each team tried to do one of the tests. So all those are test methods for rescue robot. And then that's one of the test methods that robot has to go through, sort of like going through the bridge, passing from one side to the other, and then coming back. And then I think that's a tie team. And it's hard to tell from here because you can't see the driver, operator. But what's happening is the operator is sitting near the field, but facing the other side. So the operator is not looking at the robot. They're looking at the screen like this way, and then either controlling or decided to do autonomous. And then that's the one that I can't tell from here because I don't see the operator. Yeah, but so each run, like going forward and backward, they get 1 point. Yeah, so they're getting like 1 point here, coming back, but you can kind of see because aligning becomes a little bit off, right?
Until it falls. Until it falls?
Until they can move or time is up, I think.
Okay.
Oh, see? Like,
yeah.
Yeah, then they have to reset.
So the operator sees the robot camera.
Right. So operator doesn't see the robot body. It's just looking at the field through the camera.
Oh, the same that the robot is seeing. Great.
Because that's how the rescue league is there to really support the responders, like police, firefighters, and then those people actually operate the rescue robot remotely. So they do the same thing. They can't see the robot because once you deploy the robot, you don't know where it went. So they're looking through the camera and figuring out where to go and what to do and how to do the task.
Amazing.
Yeah.
How many teams do we have?
Well, so we qualified 10 teams, but 4 teams, no, 3 couldn't come, and then 1 team was trying to come, but then visa was issued
so
on time for
sad.
them to come. So we have 6 teams this year.
6 teams.
Yeah.
Is it a big? Is it a big league?
Not really, but usually you have like I think 15 to I don't know if we had 20 teams in the past, but good enough size.
Where are they from?
So this one is Thailand. There's a German team, a team from Uruguay, team from Mexico, team from Slovakia. That's how many. I'm forgetting something. Some teams, but
do we have a team from Brazil?
Not yet.
Oh,
We don't
great.
even have a team. So we have a team in the U.S. They couldn't travel to Brazil, sadly. I hope they're watching this.
Yeah. Hope next year's day.
Yeah. So now you can see it keeps dropping. So you see the people sitting on that side. Those are the drivers. One driver, and the one student is holding the cable. That's his job to make sure the road doesn't get trapped.
And so it's all about the time the robot has. I thought that when the robot if the robot fall, then it was over. But the person can.
So I think the person has to bring it back to the starting point and start all over again.
You know how long?
So
how
each
much
run
time?
is 5 minutes.
Each one is 5 minutes, right?
And then the person standing here is a judge, so he's judging how many times.
Yeah, I ask you if we can call it a field, assuming that's a field. How many fields do we have? We have stages with different, more difficult fields.
I hope my number is correct. I think we have 18 test methods.
Whoa.
But we don't have, so like this one is one method. The one next to it has 1, 2, maybe 3, 4 on one, but each team decide to do just one.
Okay.
Because it's a preliminary. So we have preliminary yesterday, and then today is the second day. All combine the result, and then I think we're thinking top 4 or 3 go to the final. So final is going to be tomorrow. Final is going to be a combination of different tests. Yeah. So then they have to go through different tests and see how many they can actually do it with one run.
And how do you know who won? You count points. You consider time.
Well, so time is just there so that they don't do it forever.
Yeah.
So 5 minutes within the 5 minute, I think the question is within this 5 minute period, how many points you can get, and depending on which test, the points that you can gain is different. But there are two different operations. One is the teleoperation, remote control. The other one is autonomous. If your robot is doing the test autonomously, their points gonna be multiplied by 4. So if the team gets 5 points multiplied by 4, that becomes 20. So you get more points. But autonomous is more challenging. So not many teams are doing autonomous, but I know the German team is trying very hard.
So if you choose to operate the robot is working autonomously, then it has to work autonomously for the entire 5
to do
minutes.
so different tests have a little bit different process, but whenever you decide as a team decided to do a teleoperation, you have from autonomous to teleoperation, you have to tell us we're changing to teleoperation, we're changing from teleoperation to autonomous, and then when the change happens, the robot has to go back to the starting position. So if the arm is out, the arm has to pull back so that we can actually see how they're changing.
Amazing. You said those robots are smaller and they are also 3D printed. How does it work?
Well, so all the design is done by the team. So the student design, and then most of the teams are sort of like repeaters. They have been doing this for several years. So they have a previous year's design. They look at the result from last year and then modify to make it better. Sometimes they change the wheel shape to a different shape or size. We don't see, not like a bigger rescue, which now has a 4-legged robot actually on the train. We don't have that in Junior yet, but so those are the things that you can do. Because you can 3D print. I think 2 teams this morning, they're actually printing the parts on site. Because one team's back, a flipper got broken, so falling apart. So they actually printed a new part.
That's amazing.
And then to fix it back to the original design.
Amazing.
Yeah.
So do you have any standards of weight and height or the size of the robot, how it should be?
No, the size is really up to the team. But if it's too big, and then, so you didn't see it, but there's a sort of a trail that goes this way, and then turn, and then go this way.
Yeah.
If a robot is too big, it won't be able to turn to go through, right? So there's some lights, and then also the width of the rails decided. So there's a size limit, but you can play with the size limit, height. If it's too high, then it's not very stable when you're especially going through the level. So it's really the team to decide the best design possible that they can come up with.
But they don't know how the field will be, right?
No, all the rules define the rule. I mean the different fields. And then I hope they have the similar setting back in their school. So they can test and they can practice. Because driving, have you actually did the joystick control?
Never.
I can't do it. I can't do it, but they're really good at driving the robot, and then so it actually takes the practice. So we have one team in San Diego. I've talked to the mentor, and he always picks the good gamer for the driving because they know how to control.
They are handling it properly.
Driving the control and moving the controller. I have no idea
Amazing
which is
skill.
like forward, backward, right,
I don't
left.
even play video games.
I don't either.
So I would never be chosen. Well, about the rules, do you have any significant changes this year?
We actually changed a lot of testing, and then I can't really remember which one. But that's one of the difficulties that we are having because we changed the rules, and then there are a lot of different changes that we have implemented. And then this is the first time we're testing the rules. And then good thing about this bridge competition is it's not organizers deciding the rule, and which is similar to Junior. Junior also involved the team feedback, but we are sort of like a community deciding the rule change and stuff. So the team's gonna give us suggestions, what's the best way, then we will try to integrate their suggestions into rules.
Great, but every year gets more complicated.
I guess. So good thing about this league is at the end, each team submit a team description paper. So team has to disclose how they actually built the robot, how they design the robot, and all the mechanics and then sensors and everything. And then their documentation has to be in the way that this can actually teach other teams to improve. And then that paper will be become all public at the end of the competition.
Amazing.
So we're trying to make the challenge itself to improve each year, so they can actually learn from each other. It's a community effort to make it better and better. That means rules gonna get a little bit complicated each year, but that's the exciting part of this community. Very well bonded, supportive community of students, high school students.
Amazing for society in general. What we are seeing here,
Yeah, so let me see what they're trying to do. I'm not 100% sure what he's trying to do. So this has to probably go inside. And I am guessing they're trying to do the keypad. Or maybe not, because it flipped the arm. Maybe trying to pick the white thing inside. So it's a manipulation task, and then you see the arm on the body. So they get closer, open the arm, and then you have to pick it up. And once you pick it up, then you get 1 point. And then if you can successfully move that into the black bucket next to it, then you get another 1 point. So total 2. But I think it picked up 1, 2, and then you can see dropped 2. So they probably got 2 points, but not getting 4 points. Yeah, so you can see kind of trying to figure out.
Yeah, and what is this in the middle?
The middle one is a keypad. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And the middle one is the 5. 5 is yellow, and then the robot is supposed to press 5 first, and then press other number.
But does the robot has this coordination of only pressing one number?
Yeah, so if you get, not this one, but if you get really close to the robot arm, some of the robot has some soft tip attached to it, so it can precisely press that yellow button. So there's a good design that teams come up with.
When they press 5, what happens?
No, just get point. So
yeah, okay.
Nothing happens, I think.
I thought like it would maybe like finish the
well, that's a good question. I don't know. But they're supposed to press only 5, like yellow. If they press 2 together, they don't get point.
Oh.
But they only get point of the side key, but not the 5.
It also takes 5 minutes, this one?
Yeah, so each test is 5 minutes. So this robot is not going to be doing the keypad because that's a different test.
Oh.
So this field has 1, 2, 3 different test methods actually on it. So you can see that it picked it up. So it's trying to move it to the black bucket, but because of the wheel actually got sort of trapped in the rail, it's getting harder time moving out and then moving. So they made it. Oh yes.
I
So
never thought I would be cheering for Robert. But it's amazing. I get really excited.
Yeah, if you are there, very excited to see it. Yeah, and then all the spectators, there are a lot of kids coming today because it's Saturday. They actually cheer. They go like, yeah! And I can see there was a success.
I'm really happy seeing it. Amy, we came to the end.
Thank you.
It was so
I
short.
hope it was good.
It was amazing.
Okay, great.
It's such a
Thank
pleasure
you.
to have you here.
Hope you have time to come down and look at it
I will.
in person.
I will.
Okay, thank you.
Thank you,
Thank
guys.
you so much.
We're back. The next league we're gonna show is Onstage. Stay tuned. Hi guys, we're back, and now we have Christian from Onstage. Christian, can you present yourself, please?
Hi everyone, my name is Christian. I'm the league chair of the RoboCup Junior Onstage League Committee.
What do you do? Were you a participant in this league?
I've been a participant, but that's quite a long time ago. So I started in 2010 as a participant in the dance league, was it back then? That's what now is Onstage, and 3 years ago I started working on the committee.
Amazing, Christian. Now can you tell us a bit about your league itself, about the league itself?
Yes. Onstage is the creative league of RoboCup Junior. So the teams have the most potential to develop themselves, come up with all the ideas they have, and just be very creative in what they do and how they build their robots.
So we don't have any rules for the robots, like the size of it. The teams can build their own robots the way they want, the way that will work with the performances, they're right?
So actually there's quite a lot of rules the teams have to follow, but as we can just see, the teams have a stage of 4 by 5 meters on which they can present almost anything they want. It can be a theater show, it can be a dance, almost anything they can come up with. They can think of their own story or use a story that's already known.
Great. We're seeing live, it's happening right now, a competition on stage. Can you explain us what's happening there?
Yeah. Currently on stage we do have a team from Slovakia, the team Compagnie Robots. Their story is about a drummer and a pianist that practicing a song. And during the practice, the whole thing just goes into a party. And then during this party, there's one dancer, that's the guy we can see behind the curtains waving. And then there's going to be a human dancing, and the robot just follows his moves. So that's the creative thing. So on the screen in the background, you can see the one person dancing, and the robot was following the same thing. So you can also integrate people in your performance. You can also have robots with robots interacting. Everything that entertains the crowd.
So the presentation, is the presentation over, or is it just a part of the presentation?
Now it's over. The teams have a whole time of 7 minutes on the stage in which they can introduce themselves, introduce their robots, introduce the whole project, tell the judges what they've been doing throughout the whole year, until they need to come to their performance, which is usually 1.5 until 2 minutes long. And then they clear the stage, as we've seen now. The judges are now going to take a few seconds or minutes to put in all their scores. There's a quite detailed score sheet on what to look out during the performances and on which the teams are going to get marked in the end. And then we're going to see the next team.
So we have all the presentations needs to have 7 minutes, is that right? Or the team chooses the time?
The teams have to come up with a performance that's at least 1.5 minutes long, and they have a total of 7 minutes on the stage, so they have plenty of time to prepare everything and then clear the stage. It all needs to happen within these 7 minutes, but the performance needs to have at least 1.5 minutes.
But does it count? It includes the time that they have to prepare to put the robots on and everything?
Yes, that all goes into the 7 minutes.
And also takeoff.
Yes, also takeoff. But the teams can usually use this time for preparations to introduce themselves. So it's not boring.
Yeah. How the judges count points?
So there's different rubrics on the score sheet for the performance. It's about the technology and about the entertainment, but also about 4 so-called features. So the teams have to select 4 elements of their performance which they are most proud of. These are their so-called features. So that might be a special robot, a special algorithm, a special movement that they've created and that they're very proud of. So there's 4 things you need to keep an eye on. And these 4 things are going to be the ones that you can get the most marks of. The other things that go into the score sheet are if you've entertained the crowd, so if you get a good reaction from the crowd, if they're cheering or laughing, whatever, dancing, clapping, then it's going to give you a high mark in the end.
Amazing. Can you tell us more about the teams that are participating this year?
Yes, we do have 15 teams coming from 11 regions of the world. We have a wide spread of different kinds of people. We have people of all ages between 14 and 19 years old. We also have a lot of girls and boys, so a lot of mixed teams. Onstage attracts and integrates all kinds of people, not only the very tech-savvy people, but also the people that like to be creative and go beyond the raw technology.
Amazing. So, how can someone how can someone participate of the Onstage, like form teams?
So we need a team of at least 3 people to participate in the Onstage League. And the easiest way to get started is to participate in the Onstage Entry League at your regional competitions. You can usually start in the age of 10 years and then participate in your own region and maybe also go to super regional competitions like the Asia Pacific competition or the European Open. And then if you've reached the years of 14, then you can come to the internationals in the Onstage League.
So you talked about you have locals and nationals, but the team uses does the team use the same presentation, the same robots, or do they have to change everything?
So they can use the same performance throughout the whole year. It depends on the country they're coming from. I know that Brazil has their national competitions in around September, so soon from now. And the teams that have qualified at the national competitions in September this year get the chance to come to the World Championship in next year. So these teams usually come up with a new performance for the next year. But we also have teams that have had their national competitions in around May of this year. So these teams bring the same performance again. But they are always allowed to improve in their performance. They can bring in new elements. So we see a lot of teams that have a pretty basic performance at the regional level and come up with even better things at the international level.
And how Onstage was created? It was 15 years ago, right? Or no?
This year is the 25th anniversary of RoboCup Junior, so this was almost when I was born. Could have asked Amy earlier about how Onstage was founded. That's far beyond what I know. But as far as I know, it was to create a platform for the creative people into robotics.
Amazing, Christian. And well, we're seeing there the stage.
Yes. We're seeing the next team prepare next to the stage. The teams have to submit multiple documents to participate in the Onstage League. One of them is a short promotional video that's like 1 minute long, and that's going to play before the team enters the stage. There's no marks on this, so they can do whatever they like. It should just prepare the crowd for their performance. And it also should bridge the time while the judges are making their scores, because that usually takes a short while. And after this, we see the team coming on stage, and their time has just started, and they're setting up everything. In the background of the performance, you see a big screen on which the teams can not only show an introduction video or images of the robots, they can also show a video during their performance that complements to their show.
And how does it work? Like, does it have the competitions? Do you have stages or like competitions? One and then you have another one. Is it like soccer?
It's almost like this, yeah. So we have 3 stages at this event here. 2 of them are practice stages, which are open for the teams to use at all times. And then we have this main stage where all the performances happen. There's 2 performances on this main stage. The better one of those counts. And we currently see the second performance here. So the teams already have had one performance yesterday, and now they've had the whole afternoon yesterday and the whole morning today to improve on everything that didn't work out as planned yesterday.
But they have to do the same presentation, or they come to RoboCup with some choreographies and robots prepare for more presentations.
So theoretically they could come with two performances to them if they want to, but usually, as you can see, it's quite a lot of material they need to bring and also a lot of time it takes to prepare everything. So they will normally just bring one performance, they show us twice. But that's not all. We also do have a super team competition, so there actually is a third performance. For the super team, we take 3 teams from different regions and bring them together as a new super team. And then they have the whole week of the event to come up with a new performance. They will show us on Sunday morning. They get a topic for this. This year the topic is sports. So every super team gets to choose one sport that might either be from one of their regions or a local sport from Brazil, whatever they want. And then they need to make the robots perform to the sport. So I hope we're going to see some spectators cheering to the sport, some athletes performing.
Yeah, I hope so.
It's open, they can do whatever they like.
Well, so the team build their own robots, or they just buy it, ask someone to do?
No, it's very important to build these robots themselves. So we don't score what the teams have, but we score what the teams have done. So if you bring a robot that's just been bought and you program it really well, you get points for the programming, but you won't get any points for the building of the robot. So if you want to score very high, then you build your own robot, program it really well, come up with a great performance, and then you're gonna get a lot of points for this.
Well, since the robot is programmed to do the same thing, like on a performance, is it common for it to doesn't work or not doing what is expected for it to do?
There always can happen unexpected things, and usually these unexpected things happen right when you're there to perform on stage. But that's why we have 2 performances. The teams always get a second chance to perform, so it's quite common for things to go wrong during the performance.
So, is the performance happening? It already started?
It already started, yeah. Here we can see the team Summer Survivors from China, and they've actually built a really cool robot which you can currently only partly see. We've just seen the legs of the robot on the floor moving around, and now you can see it has like 2 wheels, so it's able to spin. It's like a transformer robot.
I saw it, it was amazing. So creativity they earn points for that.
Creativity is very important, yeah.
And what about the amount of robots? Like, they have some in this team.
Yes.
Does it count too?
We don't give more marks if a team has more robots. They can have any number they like, but you can also get very high marks with only one robot, so it depends on how much effort you put into the whole project.
Got it. You organize, do you see the presentations before the real competitions?
We normally don't see the whole performances of the teams, but we do collect quite a few materials from each team. So the performance only counts for a small part of the whole rating in the end. We do collect a poster from the team. They also bring the poster to the competition, so there's going to be a poster session in which every team gets to show their poster and the other teams get to ask questions about the project. The other thing the teams submit is a technical demonstration video. So this is to show everyone the technology that's in the robots, because here they can only see the performance and all the robots with costumes and everything. But in the technical demonstration video, they're supposed to take off all the costumes and show us the bare robot without anything else on, and explain what's going on, explain your code, explain your mechanics, explain whatever you're proud of.
Amazing. So how many people are judging?
We do have a judging panel of 6 people this year, because for the amount of teams we get at the international competition, we need to split up, especially for the interviews. The interviews is actually the last part that counts into the whole rating. We take each team and the 3 of the judges for 20 minutes, and the judges get to ask the team all the questions they have, and the team gets to tell the judges how the performance is supposed to work with if not anything didn't go to plan. And in this live conversation with the team, you always get the most information out of them, because you can just go one-on-one with the team members and see who has done what, who has best knowledge about what.
If everybody's involved with, amazing. And what the judge, what are the specialties? What the judge work with? What do the judge work with?
So we usually try to get judges out of not only different ages, but also different professionalities. So this year we have judges in the age of university, so students. We have judges that are teachers. We have judges that are professors at universities, but also people from the industry that are working with the technology every day, and they can see how the people grow up and work before they get into their job.
Amazing. And how? Why is the stage that size? Like, has it changed through the years, getting bigger or smaller?
Yeah, it actually has changed. When I started in 2010, it's been 1 meter wider and 1 meter deeper, so quite a bit bigger. In the meantime, it also has been smaller, but now we're back to that size. So the judges try to, or the committee who's making the rules, not the judges, tries to adapt to the different things it gets to see from the teams. So previously it's been lots of teams with robots that follow lines. Therefore the teams brought big mats that almost covered the whole stage and has prepared the whole show on that mat. But we wanted to try and get the teams into using different sensors and different technologies, and not only these line-following robots. That's why there's always adjustments to the rules, and we're trying to push the teams in the right direction to get the technology.
Amazing. Since we have the size, do you have an amount, a total amount, a maximum of people who can be inside the field?
At the moment there's no limit for the amount of people on stage. We do only say that the robots need to stay in the focus. So one thing that gives you a lot of marks is interaction between humans and robots. So for example, a human giving the hand to the robot reacting to it, or maybe passing something to the robot and the robot grabbing it. So for that you obviously need people on the stage. What we don't like is a big amount of people just dancing around on the stage and blocking the view to the robots, because the robots should always be the focus. So there's no limit, but you need to have an eye on it to make sure the robots stay the main point of the performance.
So you said the robot can be, the team chooses the robot, but does it have sensors, cameras, like 3D? How does it work? They can incorporate the technology that they want?
Yes, the teams are encouraged to bring as much technology and as high developed technology as they want. So we see a variety of sensors. We have these just standard light sensors you can also find in the basic kits from Lego and the Lego Mindstorms or Lego Spike sets, like ultrasonic sensors, light sensors, touch sensors, all these things. But we're also starting to see more advanced sensors like AI cameras, like LiDARs. So a lot of sensors. We currently see the next team setting up. They also have a cool setup on different sensors. The whole story is about the minions, so I'm sure we're going to see the minions in a few seconds.
Oh, we saw people with minions there carrying it yesterday,
exactly.
and we got so
Exactly, that's
happy only
them.
to see it.
Yeah.
I'm so happy we're going to see the show.
Yeah, we're gonna see them performing now. So this team is called Nutella Bridge, and they are from Germany. And their story is about a thief that's stolen the crown from a spider.
Oh.
And then the minions get the task to protect the spider.
I love children.
Yeah, it's just fun. It's just fun. Fortunately or unfortunately, whoever you're for, then the spider sends out an agent, a spider agent, to get back this crown.
Yeah.
These minions use a localization system, so actually they always know where they are located on stage. And for this they use LiDAR sensors that measure the distance to the walls that we see on the side and also the wall we can see on the back. So you get everything from more basic systems like line following robots to more advanced robots like we can see here, that localize themselves on the stage.
Where is this team from?
This team's from Germany.
They show the video, right? And they can also talk to the judges, or is it that 20 minutes that you mentioned earlier?
You can show a video during your introduction, or you can talk by yourselves, whatever works best for you. If you need all the people to set up the stage, you can just show a video for the introduction, but now we can see a video that fits the performance in the background. So in detail you can follow the position of the minions in the plot. So there's different spots the minions are going to follow the crown that's sitting on top of the spider. So they're taking the bus to get from one location to another. And you can always follow the position of the minions on the screen in the background. That helps the audience to understand what's happening. So now you can see a cool interaction between the robot and the human. So that human is guiding the spider with a code it has on its hand, and the spider has a camera that detects the code and then follows it.
So there are 3 robots in this presentation, is that right? Or that screen? Or is that screen a robot too?
It depends on what you count as a robot. So the judges usually take anything that has some electronics in it as a robot. So in this case we'd have 2 minions. We'd also have the bus that opens and closes the door. I think it has a special effect that we're going to see in a few seconds. Then there's the spider, and then there's this LED screen in the back that changes according to the performance.
The door is also automatic, amazing. It opens and closes the right time.
Yeah, the door opens and closes. The minions use their stage localization system to find back into the bus and find back out.
Is that anything that was forbidding those last years?
So I didn't get that.
Is that anything that was forbidden last years?
No, it wasn't actually forbidden. We're trying to encourage the interaction between humans and robots even more this year. So we emphasize this in the rules and in the score sheets. So that's another way to push the teams in the direction we want them to go. And currently this is very much the interaction between humans and robots.
You told that people can participate with 10 years or more, right? So most of the participants are kids, or no?
Yes, most of them are kids, depending on the school system happening in the country of their origin, but they are all between 14 and 19 years old when they come here. We do have some countries that already send the kids to a kind of university at that age, but usually it's high school students that participate in the Onstage League.
The maximum age is 19 years?
Yes, that's the maximum for all RoboCup Junior leagues.
But Onstage is only for junior.
Yes, we do only have Onstage and Junior. We do have these leagues that are the goal to get the kids to. For soccer, it's pretty obvious. It's the soccer leagues for rescue also. So the remaining league in the major RoboCup would be the at-home league, which is pretty similar. You get similar elements. You need to come up with a robot that is there to fulfill multiple tasks and is able to adapt to its environment. So Onstage is pretty similar to the at-home league.
Got it. So, thank you, Christian, for everything today. It was so great to interview you, to learn so much, and we came to an end. Thank you guys for watching, and bye-bye.
It's been a pleasure. Enjoy the rest of the day. Bye-bye.
Bye.
Hello everyone, we
Hello.
are back again, and now we're going to present and talk a little bit more about the simulation, the 2D simulation. So I'm here with...
My name is Berkan.
Awesome. Can you tell me more about yourself and about the league?
Yes, of course. So I've been part of RoboCup in the 2D Simulation League for like 4 years now, roughly.
Oh, really?
And I've been part of my team, Fry United. I'm wearing the shirt. And we're a university from Frankfurt in Germany.
Awesome.
Yeah.
That's really, really nice. So, 4 years in simulation, right?
Yes.
And as I said before with him, as a competitor, you must know a little bit about the rules. So of
Yes.
course, you know all the rules and stuff. So I will ask you to explain a little bit about the league, like what is the main objective, how this works, what are some of the main rules.
Yeah, so of course, as you can see, we have like a 2D environment. So this means we have no high balls. We can't shoot into the y-axis. And we have a regular football rule set. So we have almost, I believe even all of the FIFA rules implemented as regular football has.
Awesome.
And what you can see on the screen right now is you have the blue dots versus the yellow dots, which are our agents. They all run autonomously. So they all make their independent decision and don't have any information about anybody else.
Really?
Yeah.
Oh my god.
So-
This must be really hard.
It is, because we are struggling with the challenge to get information from the other players. So we have our view cone in front of us, and the server sends us, at the bottom you see the timer, 3800. The server sends us information about what each agent says in real time, and each timestamp is 100 milliseconds, so we have to make a decision every 100 milliseconds.
Oh, really?
Yeah, so we have to be fast with our calculations, and each decision is a split-second decision, like 100 milliseconds, as I said.
And each agent, just like right now, the agent or the player, I think 9 is with the ball, so he needs to make decisions very fast and see where are the other players, right? So we are seeing 2 games right now.
Yeah, so in our league, because it is simulation, we can have multiple games running at the same time. On the left side, we have Group A, and on the right side, we have Group B. So these are 2 different groups that are playing right now. On the left side, we have RoboChin versus Helios. RoboChin is a team from Brazil. So, yeah, so unfortunately, they are losing right now against Helios, but Helios is the previous world champion, so they are the favors of the competition.
I got it.
And on the right side we have Robotic, which I believe is a new team also from Brazil.
Oh, awesome.
And IT Androids is also from Brazil actually, so this is maybe a little bit in favor for you guys.
Oh, and I swear it wasn't planned.
It was not planned,
It
no.
was not planned, but awesome. So I can cheer up for both. I am having a little bit of hard time understanding it, but okay. I mean, it's a field, and we have how many players?
So each team has 12 programs running. That's 11 players on the field, like regular football, and 1 coach. So
awesome.
The coach is able to send messages to each of the agents, or each of the players, I should say.
Yeah.
And can tell them like strategies. For example, please play more defensive or more offensive, or make sure you do this or that.
But this coach is a person?
No, everything is a program here, so everything is autonomous. Nothing in our league is being manually done by any humans.
So you just press play and hope for the best.
Exactly, yeah. We programmed the strategies.
That's awesome.
We programmed the strategies beforehand, and then the robots or the AI agents do the rest of the work for us.
And you don't need any hardware. I mean, like we see a lot of robots. So the challenge here is 100% software and strategy, right?
Yeah, exactly.
Strategy, sorry.
We're not really limited by hardware like the other leagues.
Yeah.
The other leagues need to have robots and have their motors running and make sure that they don't break. For us, we have a server, and the server needs to make all the calculation. Of course, that's like the only hardware we need. We just need a good server.
A good server.
Yeah.
And what do you think is the main challenge of it? Like the hardest thing, the more difficult thing? I mean, not like, kick the ball to the goal, but the communication or maybe the one agent, the programming one agent. What is the main difficulty of it?
So what we are trying to do is we want all of these 11 players are individual programs.
Really?
So the main difficulty is we don't have information about other players and we need to coordinate these plays.
So player 10 only know what is happening in the field?
From his view. So you can
From
imagine
his view.
you can imagine like us right now, you can only see what's in front of you.
Yeah.
And so the players also have this exact same concept. So they need to remember where each player is on the field and at what time what velocity they have, what speed, and then keep that in the back of their mind to see where it's going next.
And this happens by coordinates?
Yes, so we have, it's 2D, so we have X and Y coordinate.
Oh, yeah.
And that's what we keep in track. And then we have the vectors for the speed. So what you can see right now is we have a new match starting. So each of the players' programs are starting one by one. You can see they're being positioned by the coach. And on the bottom you can see the team names. So it's Titans the Robotica. It's a Mexican team, I believe.
Oh, really? I thought it was Brazilian because it looks like Portuguese for me.
It is a Mexican team, and Oxy is a team from Romania, if I recall correctly. I might be mistaken. I think it was Romania.
In this game, do you have a referee or is just the simulation that takes care of it?
So we have a server program that is, so to speak, the referee that does all the calculations for if we send the server a command, like we have 3 commands we can send the server. One is dash, go forward, backwards, and so on. One is turn your body. And the other one is kick the ball, because you have to be able to kick the ball, obviously.
Definitely.
What we also have in our league is you see like all the circles, and you're probably a bit confused by them, or like you don't quite know what they're supposed to mean. So, for example, player 9 who has the ball right now on the right field.
Yeah, I got it.
The actual player is the black dot in the center. So that's his body. The circle around it is the range of his leg. And the line that's in front, that's like where his chest is pointing towards.
That's awesome.
Yeah.
That's really interesting. Like, I really thought the player was the whole ball, you know, and then I was just thinking, how can I have like 2 players occupying the same space?
Yeah.
But we don't have, right?
We don't have this happen. We have collisions can happen if 2 players want to dash into the same direction.
Yeah.
But usually when this happens, then the players will light up blue because they made contact, but I don't think we had it happen yet. You can also see sometimes the players turn gray. This is because they try to tackle the ball. I guess we have a 4th command, I forgot. They try to tackle the ball, which means that they want to try to stop the momentum of the ball. And this is also done with like a specific percentage. Everything, I guess I should have added, everything you see on the screen or what the players get as information is added with noise. So they don't have 100% accurate information.
Really?
Yeah.
Oh, I think just to simulate a real game where you have like noisy information and you can not see properly what is happening on the other side, you know?
Exactly. And as a human, for example, you're not able to tell how far like a person is from you. You can roughly estimate it's like 2 to 3 meters. So it's to simulate this.
You're completely right. I mean, they think about everything during this competition.
Exactly.
Right, and I want to ask you about the rules. There is some new rule, or this year or last year's, like something in the rule that has changed?
For the rules, we don't have a lot of changes because we usually have our server. Although we updated each year, this year we didn't have a major update.
Oh, yeah.
Our last major update was that we added a bipedal dash model, so both legs can now be adjusted. So you have more ways to turn and accelerate your agent.
Oh, awesome. So, really thank you for the interview. I mean, I'm sure people who are watching can now understand what is simulation, 2D simulation, and how it works. And I hope we can see more games tomorrow, or we still have 2 days of a lot of competition. So thank you so much for participating.
You're welcome.
Let's see now simulation 3D in some seconds.
See ya.
So we are back again now with 3D simulation, right? So I'm here with Pedro, and let's see if we can have some image of 3D simulation. So we don't have. Please tell me more about the league, how it works. Awesome. What is the main challenges of it?
So the 3D Simulation League is a league focusing in multi-agent 11 versus 11 soccer. So we have like 11 autonomous robots that are simulated in simulated software. We usually use SimSpark, or Mujoko is a new one. And the simulated software usually try to replicate like real life things like friction, joint velocity, and trying to make the most near to the reality.
That's awesome. And I see we have 2 Brazilian teams,
Yeah.
Pequi and Bahia RT. You are a competitor or the league representative? I'm so sorry, I needed to ask this. Are you a competitor?
Yes, I am.
what team? What is the name of the team? You can tell us a little bit more about your story in RoboCup, first of all.
So my team is Bahia Rete, who is playing
No
right now,
way!
actually.
And I think Pequi is the team from Goiás.
Yeah, it's your
So,
team.
okay, we have a rivalry here.
Yeah, but Bahia Rete is gonna win, to be honest.
Let's see, but awesome, and they are just the robots from SPL Stand-Up Platform League.
Yeah, so we try to we use the same model, which is called now, NAO, and the goal is actually to make like a free software so they can use in the physical model, you know.
I got it. So you're doing the simulation and you're improving the software so they can use it in the real life robots, right?
Yeah, exactly.
That's awesome. About the field, it really looks like I'm seeing a real soccer game. There are some differences between the field, like the size of the field or anything.
Yes, there is a difference of the size because the nows are not the same size of human beings.
Yeah.
But because actually the physical ones are actually not the size of human beings too, so we
yeah,
need
definitely.
to make
Yeah.
that accountable. So, but the thing is, everything else is trying to be as realistic as possible. We have friction, we have they don't get tired. That's the only thing that
yeah.
is not realistic.
But I mean,
actually.
robots don't get tired too, right? They get
Yeah.
the battery gets low, but not tired at all. And I see that when they get up a little bit. Yeah, it's a little bit similar to how they would get up, I guess. And I mean, that's awesome. And Pequi just made a goal.
Yes.
Unfortunately, just kidding. Okay. For you who is watching, it's because Pequi stands for Pequi Mecânico. That is the team of my university, so I'm kind of cheering them up. But can you explain me the main rules of it, or is just like normal soccer rules? Like, I don't know the name in English, and I'm so sorry. I will search to know. The people in production will search to know. But I really wanted to ask if they have impedimento.
No, we don't have impediment. I don't know
You
in
don't know
English
the word?
too.
Okay, so production, please search what is the English for impedimento, please.
Yeah.
But they don't have it.
We don't have, but we have false actually.
Really?
Yeah, but it's a bit different. We don't have like yellow cards and red cards. The robot who makes a fall, he's teleported to the other side of the field actually.
Really?
Yes.
Like
to the offside actually.
Oh, offside, but then he comes back
Yeah, he needs to walk all the way back.
to the.
Yes.
Oh, that's why I'm seeing some players just disappearing.
Yeah, exactly.
Oh my God, that's very awesome.
Yeah.
That's very funny actually to see it. And so we have corner kicks, right? We have
Yes, yes.
kickoffs. And what is the time of each competition, of each game actually?
Yes, we have matches of 10 minutes, only 10 minutes. Obviously, 5 minutes for the half. No, it's the goal. It's the goal.
No.
It's the goal.
Sorry, guys. Sorry, no.
Oh, sorry.
Okay, it's okay. We can do it. Pequi, we can do it. Sorry, guys. I mean, it's so interesting, the league and everything, but it's so interesting to watch, you know. Oh, waiting for a second half.
Yes. Another 5 minutes.
5 minutes. So, wait, it's 5 minutes, and then how? Oh,
Yes.
another 5
Is
minutes just right now.
The second
Half.
Half, the second
I was
half.
I was only going to ask how many time, you know, how many minutes is between one half and another. So seconds. They don't need to prepare the robots,
they don't
right?
need to prepare, so it's the time that we can, the fastest we can actually.
Yeah, that's very funny. And the ball can be kicked outside the field.
Yes, it can be, and they will trigger a different play mode. You can see that in the corner, right underneath the Bahia hit the tag, you can see like play mode, play on. If the ball goes out, play on is the normal mode. When the match starts, the half starts, you're gonna see another thing like kickoff. You know, and if the ball is like out of the field in a
The
goal
corner.
side,
Oh,
you're
the goal
gonna go
side.
to corner kick
I got
in the
it.
play mode.
And what
So-
about now? If the balls go out there, I think it's side kick, right?
Yeah, it's a side kick. Yeah.
Oh, that's
Exactly.
awesome. That's awesome. Oh my god, so we have pass left.
By the way, we use a lot of AI,
Oh,
like
really?
reinforcement learning, to make
Oh,
the
really?
robots. Yes.
I mean, I was thinking like, it's a great thank you for saying that, because I was thinking like, this is sensors. I maybe think this is some like being search, you know. I was thinking things like that. So artificial intelligence, and you guys use only reinforcement learning.
Yes, we only use reinforcement learning because like we have skills, a set
Yeah.
of skills like a kick or a dribble, and we train it like we specifically by RT, we actually use a trained kick. Oh, it's the kicking actually.
Kicking, right? Awesome.
So we use a kick that goes like 18, I think, meters. So it's like more than half the field,
Oh,
and it was trained.
really?
Yeah.
So can
From
you
half, from
can you
nothing.
awesome? Can you please explain a little bit? I mean, in a very easy way, what is reinforcement learning and how it works? I can try to help you with that, if anything.
Yeah. So I think the simplest way to explain it is like
It's hard,
you have
isn't it?
it's like having a puppy. You know,
Okay.
the puppy is gonna
Yeah.
learn new tricks, and the tricks are gonna be learned by reward.
Yeah.
So if I want him to give him the paw, he's gonna give him the paw. If I give him some treat, you know,
Yeah.
it's exactly the same
A
thing.
cookie.
Yeah, it's a cookie, something like that. So it's like exactly the same thing. The robot is going to try to make the best he can do,
Yeah.
and that we have parameters who gonna change the reward. The reward for him is like 0, 1. It's a number.
Really?
Yeah.
Like, you did great or you didn't do great. Oh, yeah, like you
Yeah.
failed.
Yeah,
or
exactly.
like, that was good but not too much, or that was very good. So it's
Yeah.
like that.
Yeah, I have actually a kind of funny story. When we were training the kick, like we didn't like explain to him how to do a kick.
Yeah.
So he like learned to to kick the ball with his head. So he like
No way.
launched himself to the ground.
It did work it? I mean,
No. Like,
the main objective is to score a goal. Yeah.
Yeah.
So I think he gets a big reward when he does that, right? So if he does
Yeah.
with the hand, maybe.
the reward was quite kind of off actually.
Oh,
So that's
okay.
why.
That's why. That's very funny.
Yeah.
Yeah, and you've been working on it. I mean, must be very difficult. Okay, you don't have the hardware to stress with, but
Yeah.
what kind of language do you use? And I'm talking about programming language, you know.
Yeah, we have teams that use Java. We have teams that
Really?
use C++. Yeah,
No way.
just one team. They are warriors actually.
Oh.
But, like, yeah.
And do you use Python?
Yes, the main one is Python.
Yeah.
Everywhere.
Yeah, everywhere.
Like 80% of the teams are Python.
I will ask Piki what is the language programming they use. I'm very curious about it right now. And that's awesome. I mean, it's very funny how everything works. I just think that in this gray view,
Yeah.
should be a view from Salvador, Bahia. Don't you think?
Yes, I
Like
think
the
so.
half over?
Half over.
What
Draw.
about now?
Draw. It's a draw. Like
It's a draw.
Yeah.
Okay. Okay, so we can have draw. No penalty, no shootout. I think I started to get nervous. So
Yeah.
thank you so much, Pedro, for coming here. I mean, it was awesome. And it was a short time, but I think people that are watching have to understand what is simulation 3D. So I thank you very, very much.
Thank you for the opportunity to be here.
So
That's it.
that's it. Okay. Bye bye. We'll
Bye-bye.
come back in seconds. You can stay here for now. I need the production to cut. Thank Hello, we are back again. And now I'm here with
João.
João, yeah. So many names, you know.
Yeah, it's
I
hard to
get-
remember
It's
everyone.
hard to remember anyone, even the Brazilians one.
Yeah.
So now we are here to talk and see a little bit more of SSL
Yes.
League.
Yeah, so now we have a great match in the SSL. It's June League against Tigers, the Chinese team against the German team. They were the first and second places last year at the competition. Yeah.
No way.
So we hope it's a very exciting game right now. Tigers is playing very well. Junix is also playing well. He have a very dynamic match. So yeah, it will be an exciting and funny match for sure.
Something I got curious about when learning about standard platform league and humanoid and simulation is they communicate with themselves,
Yes.
right? They have different strategies, like okay, now my player number 2 is going to run, and then this happens.
Yeah, it's in our league. It's really dynamic. Each team elaborates their own strategy for the game. For example, Tigers, they like to do a lot of passes. So we will see this game they doing like really quick passes from the side to the other to make the ball move quickly. And then when they find a good opportunity to kick, they kick to the goal. Usually it's goal when they do it because they are really good at it. That's why they're champions. While Junix, the Chinese team, they like the dribbling strategy. In the SSL, we have a mechanism in the front of the robot. There's like a small motor in the front of it that keeps rolling and pushes the ball and actually pulls the ball and keeps the robot controlling the ball, like dribbling with it.
Yeah.
So the Junix was the first team to ever have like a good dribbler in the SSL.
Really?
Since like 2018 or 2019, they started doing it very well.
That's
and
awesome.
that's their main strategy, trying to like hold the ball and dribble
And walk with
the
them,
others.
right?
Yeah. So they're very good at it. Well, we'll see a lot of that in this match. It will be so fun.
I think it would be very funny because one team likes to just kick the ball to another playmate and then da-na-na-na-na, and another team's like, hold on, I
Yes.
got it. Let's
Yeah.
walk through it.
And you gotta be very creative to plan these strategies and also very precise on what your robots will do. Like you tell them to do and they really do what you want. Yeah, it's really hard for that to do that. Every team struggles with it a bit. And we can see now it's already 1-0 for Tigers.
Really?
In the screen there, you can see the scoreboard. It's a little, but
Can you tell us, if you know, of course,
Yes.
who is the Chinese team?
Okay, so right now we see Tigers playing with the white hull. We see the white team there. It's Tigers, the German team. And we see Junix, the Chinese team, in the black hull.
Black room.
And I think it's another goal for Tigers. You see them cheering there in the back, the German guys in black. So it looks like a valid goal. So right now, after the goal, usually the referees stop to check if there was any falls or any problems before.
And they just press the button and all robots are down. Like they stop immediately.
Yeah, like this is also automatically happens. Like we have an automatic referee that checks everything that's happening in the game. So if there's any falls or anything, it will like automatically press a button but not a real button.
Really?
It, like this is automatic.
I really thought it was a real button. But I really thought someone in there was just like...
Yeah, we have these buttons because we always have the human referee checking if the auto ref is working well, if it's making the right decisions. But in case of the goal, in other things that happen in the match, everything runs automatically. So if there's a fall or if the ball runs out of the field, the auto ref detects it, and the robots are supposed to place the ball in the place where it will be kicked. So the game just runs with no stop, no interference by the humans. But the only situation where we have interference is when we have a goal.
I saw that because it's hard for the robot to take out the ball.
Yeah. Also because the goal is like the most important thing that happens in the match. So we prefer to be cautious with it, you know. not
You're
making.
totally right.
Yeah. So when there's a goal, it's the only situation that the robots totally stop. We call it halt, a halt command. They receive a halt command and stop completely, so we can check if the goal was valid, and if it was, the human referee puts the ball on the center, and we go back to the match normally.
That's awesome. Like, looks like a real soccer game
Yes.
where the ball is out, the player goes there, take the ball,
Yeah,
put
yeah.
in the location.
Just like that. Just
That's
like a real game.
awesome. That's really awesome. And we have how many robots in the field?
So in the SSL currently we have 2 divisions. We have Division A and Division B. In the Division B we have matches with 6 against 6 robots, and in the Division A we have some matches with 11 and some matches with 8. We are in the group phase now, so we have a rule that if one of the teams wants to play with 8, both needs to play with 8.
Awesome.
But when we go to the elimination phase, all the teams have to play with 11. So right now I think we're seeing 8 robots. So
awesome.
it should be a match with 8 against 8. So, but in the elimination phase, we will probably have 11 robots on each team, which is a lot of robots. It's really hard to see everything that's happening on the match, because you can see it's like
So
really fast.
Yeah, they are so fast. And I got curious about the wheels.
Yeah, so
can you tell me more about it? Like,
yeah, so we usually teams use 4 wheels for their robots. Each robot has 4 wheels, and we use like what we call an omnidirectional wheel,
I got it.
which means that that wheel can move in any direction. Like if you think of a car, the car's wheel can't move back to the side.
Yeah.
They only move to the front. Yeah, but in these robots we have a wheel with little wheels inside it.
No way.
So it has like the normal wheel, like a car, and in the perpendicular direction of the wheel we have like little wheels.
So they can just.
Yeah. So the wheel can move to the side. So you can see that the robots, they move to all directions freely. That's because we use this kind of wheel, the omnidirectional wheel. And so we also call these robots like omnidirectional robots, because they move in every direction.
Every direction and very fast.
Yeah, and you can see now they are in. I think they asked for a timeout probably. So they will like pause the game to solve some issues, and each teams use their robots to make like the letters of their team. So you see Tigers with a T and Junlix with a Z. That's the first name, first letter.
Awesome.
Yeah, it's really fun.
It's really funny, and how they do it like so
perfectly. Yeah.
So fast and so perfectly. Like if you're going to measure, if you take it in, it's exactly the same distance.
Yeah,
I'm really shocked.
and Tigers, they also have one fun fact that at the end of the match, when they win, they make like a dance. They make like Macarena with the robots, or they make bowling. They like put their robots in a position. The other one comes and hits them, and they split. It's really fun, and you can see if we get to see the end of the match, we'll see that the guys from the team, they like dance together with the robots. It's really fun. They are really fun guys, and like not only good at the competition, but they are really fun guys and good to talk, and they share everything. It's really nice to have them in the competition.
Oh, that's awesome, and that's really important because, of course, it's a competition. Everyone wants to win, but as we said, the magic of the RoboCup is the communication between the teams, right?
Yeah, like science is about sharing information.
Definitely.
Yeah, so it's really nice to have them. They are really open to share how they solve problems. Yesterday we had like a session for poster presentations from all the teams from the Division A, from
really
the SSL, and we talked a lot with them, like how they solve this, how they solve that. They actually solved one of our problems when
really?
like not solved, but we were talking to them, and they said, "Oh, you can do this," and we tried and it worked. So
Oh my god, that's awesome.
yeah, it's really good to have them there. We learn a lot with them, you know.
Of course, of course. And I mean, I think for them it's better to give this, try this, maybe
Yes.
this, because the more good the teams
Oh,
get,
really good. Sorry.
it's okay. You can comment on it. It's very nice. The best the team get, the hardest the competition gets.
Yes.
So you know, everyone is improving year by year.
Yeah, it's like that. If they help us improve, we will
Yeah.
get like closer to their level, and they will have to improve as
improve
well. So it pushes the level of the competition for everyone.
Yeah, definitely that.
Yeah, it's. I think that's the mentality we all have to have
Yeah.
as competitors. You know, everyone push each other to be better,
To be better.
each year and to improve. And I think it's what everyone has in mind right now.
Yeah, this is the magic of RoboCup,
Yes.
right? And I got really curious about how these robots can do it. Like, okay, how can they autonomous? That
Looks
was a
like
goal.
a goal for Tigers. Another one.
Oh, how does they learn? Like reinforcement learning, artificial intelligence, or I don't know, neural networks, and how this
Okay.
works?
Yeah. So in our competition, we use mainly algorithms and heuristics to solve most of the problems. We don't do much like neural networks or reinforcement learning because we need a lot of data to
that's true.
learn with these algorithms and put them in practice. So we still don't have we still don't have a very good simulation of our robots that can represent them and like transfer this knowledge from simulation to realistic application. It's really hard to do that, but all teams have like really complex systems, algorithms, and heuristics for making decisions. Because as you can see, it's a lot of things happening. A lot of players also.
So fast.
Yeah, it's really hard to make decisions. So almost all teams, I think, improve with more heuristics and more algorithms and more old
Classic
stuff, you know.
Algorithms, yeah. And I really want to see a code for that. Like, really.
Yeah.
I'm really curious about it. Like, how can you guys do that with the heuristics?
Yes.
So it's awesome, you know?
Yeah, so I think
What
we
is
have
happening?
a time.
What is happening?
Yeah, I think we have a timeout now for June League. They looks like they have a problem with their robot. The guy is trying to fix it.
Oh my god, maybe the battery.
Yeah, maybe I can't see the screen now, but maybe it's already a halftime break because we have like 2 times of 5 minutes, and the game is running really fast. So
Really fast.
yeah. So maybe they went to the halftime break. So in the halftime they have like 5 minutes to do whatever they want. Usually we like change batteries, make some changes to the robots.
So they can change the programming also?
Yeah, they can change anything in the halftime break. Also in the timeouts. Not during the match. Yeah, when the game is running. If you touch your PC when the game is running, it's considered like a major fall. And
No way. Oh, yeah.
You can't like fix anything when the game is running.
Oh, and when a robot make a fall,
Yes.
the robot gets out of the game or no? Just the ball is placed.
Oh yeah, so we have like stopping falls and we have non-stopping falls.
Oh.
For example, we have bot crashes when the two robots crash. It's a non-stopping fall, for example. So the game continues running, but the team receives a foul, and we have a counter that counts all the falls for the team. And when the team accumulates 3 falls, it gets a yellow card. So they have to remove one of the robots.
No way.
Yeah, for like 2 minutes.
2 minutes. Oh.
And if the team accumulates 3 simultaneous yellow cards, they get a red card. which gets the robot permanently like
Out of the
removed.
field.
Yes. So yeah, we also have cards, and we see many teams actually getting better, like not better, get better from the other because the other team got a yellow card. So you have like a difference in the number of players, and
This is crucial.
yeah,
right?
it's crucial to have like a good number of players.
And I mean, I get really curious and interested in that because you have a code, you have an algorithm that works really, really fine with like, I'm so sorry, how many?
Oh, it looks like someone brought a robot from my
No
team
way.
here.
I don't know if I can hold
You
it.
can.
Okay.
Okay.
No way.
Okay, so we we have a robot from RoboC now here from my team. Yeah, just put on the table. This
Guys,
was not.
we have a robot.
Yeah, we have a robot here. This name is
If you want-
Bebeto in Romário.
If you want, I can hold the microphone for you, so you can
Oh.
show it, please.
No, we can do
We
it.
can do it?
But don't need to.
Take it, please.
You can take the other one off. Yeah,
I
just
can.
need,
Oh my
need
God,
to.
I'm just.
Yeah,
I-
just.
Guys, you just saw. He asked me, okay?
Okay,
He
you can
asked
do it. You
me.
can do it. No problem.
Oh my God, this is so funny.
Okay, let's open it.
Okay,
so-
can you hold it a little bit so we can close up the
Okay.
image like here?
Oh, wait.
I will.
Here? No, can you give me back? Okay, I can do it.
so
So
scared.
here's our robot from RoboCine, my team. We can see it here, the logo from RoboCine in the front, the little robot. See here, our sponsors. And here on the top, you can see the colors which we use in the SSL vision system to detect the robot. You can see here it's blue. The blue color says like the team, which team it participates, and you can see the pink ones. It's like to address the robot's ID. It's like his number on the shirt for a robot. But we annotate here because it's
number
the
of
number
it.
9. Yeah, you can see 9 here. And we-
Bebeto and Romário is the
yeah,
name.
yeah, we put names on all our robots just for
Oh.
fun. Some of them are not permitted to say.
So, do you want to show this part? For
Yeah,
us?
maybe we can like take off the.
Please, guys,
the
the
cover.
camera back to the normal. Oh my God, this
Yeah,
production
I
is
think it-
perfect. Oh my God, oh my
Okay,
God.
hold it here.
Guys, you are seeing, I'm not doing anything, okay? No way, we are just seeing the.
Okay, so here we have the inside of the robot. You can see here, these are the motor drivers, the boards that we use to control. Yeah, the wheel was told you.
That's awesome.
This has little wheels on it. And you have here the motor drivers, like these boards that control the motors. So we have like 4 motors. And on the top we have what we call the core board, which has the processor. We have like here one.
So it's the brain of
Yeah,
the robot.
it's the robot's brain. Yeah, that's it. We have like here a processor called Raspberry Pi. It's a Raspberry Pi. It's like a famous
It's
one.
very common,
Yeah, it's very common.
I mean, it's used on the Junior as
Yeah,
well.
yeah, they use it. But not currently we're only using it to receive Wi-Fi because we are communicating to our robot through Wi-Fi 5 gigahertz. And here down we have a board that we made with a microcontroller. We can see.
Have your logo here?
Yeah, we put our logo on everything.
That's awesome. Okay.
We are very fancy with it. Like you can see RoboCine here. We put RoboCine in everything we do. And this board also has a microcontroller that we use to control the whole robot. And I think it's not good to see right now, but inside the robot we have another board, which is the kicker board, because the robot has a mechanism to kick. You can see there on the screen.
Yeah, wait.
You can see here it uses this mechanism to push
You
the ball.
can you can show them if you go to like if you
Okay.
hold if you lift it.
Okay.
And then we can see. I'm very curious about it. Look.
Okay, so we have here. You can see the silver plate there. And it goes to
Yeah.
it goes like this.
No way.
It goes like this to the front. And
It kicks the ball.
Yeah.
And the other one is.
Yeah, it's for chip. What we call chip kick, like to kick the ball. Yeah.
No way.
Upwards.
No way.
So we have these two mechanisms to kick the ball.
Into the mechanism that you use to hold the ball.
Yeah.
Is
so
this one?
yes, this one on the front, what we call the dribbler.
Oh, dribbler.
Yeah, our robots, to be honest, we don't work much with the dribbler. We don't have, because we don't have enough motors for all the robots for dribbling. So if you see here, we have like a piece that's just a solid metal piece just to replace it, just to make the same weight as the motor, because we model the robot with that weight.
Important. I
Yeah.
hadn't thought of that. I will ask if the production can put the game again or another game, but this robot will stay here at least for this interval. I mean, I am shocked.
Yeah, it's a very complex project. I mean, the SSL league exists for many years, and it took the people from the league from these many years to get to the point where we can just like see the projects that are open source and decide to do these things, to go, okay, let's do the motor driver like this, the main board like this, the wheels, this whole structure. Each team does their own project, but if you check them, they are like
Very similar.
very similar.
Very,
They
very
follow
similar.
like the same path,
Yeah, and how much effort in talking about time you guys have to put on here? Like, I know maybe years of
Yes.
thinking and researching,
Yeah, and also making mistakes and fixing them, because sometimes we do a change and we say, okay, this change didn't work. Let's go back.
Let's redo it.
Yeah, let's go back. Let's try another thing. And every year we try to make new changes. For example, this year we changed our wheels. We used to have smaller wheels with thinner wheels, and this year we changed to a larger one. And it makes the robot move really faster. We also had some changes in this dribbling mechanism, because as I said, we still don't have a mechanism that really works well. It's not reliable enough to use on a match, but we are working on it, and this year it's better than last year. So we hope to keep.
We have something, right?
yeah. So we hope to keep improving it until we get to the point where we can use it in a reliable way on the match. But yeah, it takes many years. Like, you gotta start with the basic.
Yeah.
Start with simple things and go improving like step by step. Don't rush, Just don't rush.
Yeah. I really think like this, to get to this point. You have tried and so hard and for long time.
Yeah, I can say like about specifically about our project here. I can say like these boards are the same since 2018, I think, which was the first year RoboScene they had a project for this league.
That's awesome.
And also our kicker board, it's literally the same project since 2018 or 2019, because when we do changes, we are very conservative in the changes, because we know everything we change is a risk we're taking as well.
And as they say, don't fix it if it ain't broken,
Yeah,
right?
exactly. For example, also for this year, this core board we have here, we used to use another board, and we also used to use these parts here, which are the radios.
Yeah.
And we changed to Wi-Fi, but we said, okay, we are not sure if we will make it work up in time for the competition, so let's make a solution that we can also use the old solution.
Like plan B, right?
Yeah, we have a plan B. So for everything we have like plan A, B, C, D.
Into to the Z.
Yeah,
the
yeah.
Z plan.
Yeah,
But
yeah.
nothing works. I think the match is like 5-0.
Yeah, it looks like 5-0.
5-0.
I didn't expect that much.
Me neither. Like I got so excited about the robot.
Yeah.
And the game was playing. I mean, that's awesome. And I think the ball is where I don't see the.
Yeah, it looks like the referees are discussing something because you can see like that girl in green
Yeah.
by the side of the field. She's Carla. She's also Brazilian.
Really?
Yeah, she's an
Awesome.
OC for the SSL since 2019, and yeah, I think the game has come back, but the ball should be like on the left side of the field right now.
And is everything so fast that we
Yeah.
can. It's
But
very hard.
yeah, but it's impressive. They got like 5-0.
Yeah.
We got yesterday. We played against these two teams.
Really?
We played against Tigers and they did 8-0 on us.
Oh, that's
But
hard.
yeah, but that's. I mean, it's still an improvement because last year they got 10-0.
Okay, so we
yeah,
have
we're
something, you
improving.
know?
Yeah, we're getting better. And in the SSL, we have a rule that if the match is 10-0 for one team, the game ends.
Oh,
So
makes sense. So
yeah, we were happy that the game
Okay.
ended by the time, not by the
Yeah.
score.
yeah, that was definitely improvement.
And we also played against Unix. We got 1-0 for us against them. We won. We actually didn't expect that, but it was very fun, and we were so happy that we won this match. We also won another match today against Robo Dragons, a Japanese team. We did 5-0 on them.
Really? Oh, that's awesome.
So yeah, we're so
I think
happy.
you guys are very happy.
Yeah,
and,
yeah.
I mean, maybe more than you expected,
Yeah,
right?
yes.
That's very, very funny. And unfortunately, now we have to stop talking
Okay.
about the SSL, but it was really awesome talking to you again.
Thank you so much.
And get to know this robot. What is the name again?
It's the SSL. We have the team robots in here from Brazil, from the University of Federal Pernambuco.
Oh, awesome. And the name of the
Oh,
robot?
the robots itself, it's Bebeto and Romário.
So everyone with Bebeto, with João, Bebeto and Romário,
Okay.
and me, we are going to say goodbye. I don't know if the robot say goodbye, but that's it. So now we are going to have an interview with the sponsor. So bye-bye. See you
Bye-bye.
later.
Thank you.
Thank you.
See ya.
Can you tell us your name, where you're from, and what league you're competing in?
Yes, my name is Alexandre. I'm from Brazil, from São Paulo, and from RoboFei. I'm competing in the small size league from the soccer competition.
And what are the main challenges you and your teammates are facing?
My teammates are facing a big challenge that is the small amount of people that we brought in our team. You know, we're in 3 people here, so it's kind of hard to deal with all this competition with only 3 people. It's a really short team. And also, you know, our games, our robots, they are good robots, but people here have really nice robots, really nice code softwares, and it's been hard for us to keep up with them, but we're trying to do our best.
Is it your first time on RoboCup, or have you competed before?
Yes, it is my first time on RoboCup. Actually, all of my teammates' first time on RoboCup. We have only competed before on Brazilian competitions.
And what are your thoughts on the event? Are you enjoying it?
Oh yes, of course. It's a really big event for all of us that enjoy robots, such as myself. Awesome event.
It's amazing. Thank you very much.
You should take it slow.
Hi guys, we're back here with Tobias from Artwork. Hi Tobias, can you present yourself?
Yes, hello Sophia. My name is Tobias Kaub and I'm a professor in robotics, and I'm part of one of the teams at the at Work League. So I think we're going to see the run soon.
Oh.
So you will see what's it all about.
So how long have you been working with robotics?
All my life almost.
Oh.
Yeah. So I did a PhD in robotics and then started a company, and now I'm back in academia since about 6 years.
Great. Which part exactly do you work with?
So at the moment we are working with mostly in industry applications. So one of which is the At Work League, where it's all about smart factory operations. And you can see the arena now. It's just being prepared. It's actually been run already. And what the robot you can see on the arena is actually my team. So my team is going already.
Okay. Quick question. What's the difference between the logistics and At Work League?
Yeah, so they're both called industrial leagues. The At Work League you can see right here. It's all about transporting goods from A to B. So it's basically like in a smart factory where goods are distributed all over the factory and they need to go to a different place. So a mobile platform like the one you see will go and find those objects. So first it needs to autonomously navigate, and you can see there are tight spaces like now where you may get stuck, but it freed itself. And then it got a task to pick up goods from a certain area and take them somewhere else. So the challenge here is to recognize objects on those white spaces you can see and successfully grasp them, load them up and bring them to another place.
Are the places, the fields always the same?
Yeah, so the arena is basically fixed at the beginning of the runs like 2 days ago. So all the white things you can see here will stay constant. But the more you go into the competition, the more difficult it gets. So you may introduce some extra obstacles. So you can see the ones with the gray crosses.
Yeah.
So those are actually for this run for the first time, and the robot does not know about them. So it needs to use its sensors to find them, or not to find them, to go around them.
Great. It's always only one robot doing in the arena.
That's correct, yeah. So the teams go one after each other. You can see the other robots are already lined up at the edge of the arena, and every team gets the same task. So at the beginning you have a start state where all the objects are, and you're supposed to reach the end state, which is the goal where all the objects need to go. And the robot enters the arena and needs to conduct everything autonomously. So there's no operator anywhere here. You just watch.
Yeah. So in RoboCup, how many competitions teams gonna participate?
So in the At Work League, this year we have 9 teams participating.
9?
So 9, yeah. So it's a fairly small community. It's about always up to 10 teams, something like that. And this year we have a lot of new teams as well. So we are more experienced. We've started 4 years ago now, roughly. We're also the current world champion, so there's a lot of pressure.
So you're the favorites.
We'll see. Actually, the competition is tight, which is nice. This is good, you know, because you wanna see some thrilling runs here.
Yeah, there was another league here, and the person said that there were 2 teams that were really close to each other, and one of them couldn't come. Yeah. So they were like kind of sad, kind of dismotivated, because it's such a pressure to compete with against good people. So it's tight. Oh, good luck.
Yeah, exactly. But that's nice, because we also hear sometimes if the leading team is always so far away and so good, and no new teams want to start, and it's just boring, So I think it's exciting to be close. So what's happening right now is the arena is going to be set up again for the next team, and the people standing around in the center here, these are the referees. So I'm usually one of the referees, but today and now I'm here for a change. And so what's happening is that they have to judge how well everything worked, and basically deduct points if the so-called penalties if something went wrong. So there's a clear rule book about everything, and so you can score points in each run, and they all get added up in the end. Now we're on the third run, and there are 3 more runs after that.
Got it. You said you were the referee sometimes, but only when it's not your team. But even here, your team is participating in this RoboCup. You are also a referee here?
Yeah, so it's very democratic. So even like here, every team has 1 referee, and they all participate in all runs. So even if your own team is running, you are judging it. But you're one of 9 referees.
Great.
So at the end, you have consensus. Yeah.
Amazing. So how long does a play? Is it a play? A round? A round takes.
Yeah, so it's different depending on which one. It starts with a very simple one that happened yesterday that takes 4 minutes. Then next one is 6 minutes, and now we are at 8 minutes, I think. There's also a preparation time before that, about 3 minutes, where the robot is being prepared, and the operator can still touch it at that point, and then you either press a button or you pull a cable, and then your runtime starts, which is, I think here it's 8 minutes at a maximum.
So you said the time changes. We have stages, right?
Stages?
Everything happens the first stage, and then you have another.
Yeah, so preparation is 1 stage, and then the actual run is the second stage. And then once the runtime is over, you stop, and then you look at the points. How many points did the team achieve, and how many penalties are there?
And what does a team have to do to win?
Yeah, so collect as many points as possible. So you get points for successfully navigating to a certain workspace where you pick up objects. So you can see now another team is preparing in the start area. That is a small robot. That's a very experienced team that won the World Championship many times before. But this year they had some challenges with getting their robot here. So they brought a very small robot, and basically just starting from scratch here again. What you will see here now, my guess is they will only go and navigate and not pick anything. So you get more points for picking objects, for placing them correctly. But we'll see. I don't think the arm will be moving. The robot will just be navigating. So I think it will need to go to the area where you can see those 3 objects. So it successfully went around the box with the cross, which is a new obstacle. And I think it will now approach the so-called workspace. And see, it has some LED eyes, so the eyes said I successfully reached it. So this is a gimmick they introduced. Like we have a speech output, for example. You can work with lights, or you can just not do anything. This is not required, but it helps the spectators and everyone else to see what's going on.
Got it. You talked about the robots. So how are the robots for this league? Each team builds it. Does it have anything that is mandatory that it has to have? Does it have size, and a specific size? How is it?
Yeah, there are certain rules around it. That's also defined in the rule book, like maximum size, minimum size, things like this. But other than that, you can build the robot any way you like. So you always have a moving platform at the bottom and an arm on top. Yeah, that's what you need to navigate and to grasp and place things. So you can see there's an arm on top here, but it's not doing anything now. But what's also interesting here is most teams have a platform that is so-called omnidirectional. So you can move in all directions because the space is very tight. So these wheels are special and you can move sideways. Yeah. So you can see that sometimes in the maneuvers here.
Do you have any specifications about the sensors, the cameras, the hardware that it needs, or it's up to each team?
No, not really. The teams are free to choose. So you always need a LiDAR of some sort, or most people choose a LiDAR to navigate. So a 2D LiDAR just looking at a few centimeters above the ground usually is sufficient for this kind of environment to find your way around. But in addition, you also need a camera then to find the objects, like recognize them and also pick them. So it's a special camera usually, because you also need to measure the depth, the distance from the camera, so you can successfully localize the object on the workspace and pick it.
Yeah. Okay. Can you tell us what's happening there?
Yeah, so now the platform again is navigating. You can see the wheels, those mechanism wheels that are special. And yeah, I think they're getting close to finishing up.
Is it still your team?
No, this is the team from Nürnberg, another German team that brought this new robot this time, which they're still like developing even during the competition.
Oh my gosh! So, since you're from a team, can you say a bit more about your team? Who are the people who are a part of it? What they usually do? How they came to the team?
Yeah. So I started a team myself about 5 years ago, and the people rotate around because we want to get students for this competition. So the first year, 3 master students basically built up the basic capability together, and then we started participating straight away. And then things evolved over the years, and we also involved university lab engineers. So I think this is one of the recipes why things work so well, because you get actually trained engineers to help you with assembling the platform properly. But yeah, people rotate around. There's not many that stay on the team constantly. I think people are watching maybe now from home. I just sent them the link to this live stream. Who have developed most of this capability we have now. So this is the spirit of the RoboCup, to keep passing on the knowledge and keep developing it.
Amazing. What about I see that you have, comparing to other fields, other arenas in RoboCup, it's big. Why is it that size?
Yeah, this is a fairly big arena. We've also had smaller ones before. You're talking about the arena or the robot?
The arena, right?
Yes.
Yeah, that's it.
It's simulating a smart factory, and you choose the spaces in a way that this type of robot with its size can just fit through, but you don't make it too easy, right? So, so this is, the size can be a bit bigger, a bit smaller, but the principles are always the same. The bigger, the more interesting it gets as well. So you now see another team starting up in the start arena. This is our main competitor. They've also won the World Championship before. They're also from Germany, by the way. So they're very good. And we'll probably see an exciting run coming up now. And maybe something else to mention. So these objects that are getting picked, they are known. So people, you know which objects are there. But at this stage, you also introduce some so-called decoys. Decoys are objects that look similar to the ones you're supposed to grasp, but are not the same. So it gets more and more difficult for the robot to distinguish between the two. And more fun to watch for the spectators, because the robot may pick the wrong thing, which is, always gives a laugh.
Which leads me to another question. What do we have different new rules this year? different or new?
The rulebook evolves as well, but it hasn't changed much recently. So there is like it's 20 pages or more, and it gets refined, I would say. But what you don't want is to make it too hard for new teams to start. And this year we have a lot of new teams, including Brazilian teams, of course. So this is great. And you can also simplify certain tasks for the new teams. So one simplification is to use, instead of the real objects, you use so-called April tags. So cubes that have a QR code on top, and it's much easier to localize them. Yeah? So basically the task is getting simpler. They just need to navigate and pick those objects that are easier to pick, and they get only half the points then. Yeah? So there's a penalty for it, but you can develop your capabilities step by step.
Great. So there's a question that came from our chat, that how much is it approximately to build one of those robots?
Yeah, that's a good question. That's a bit up to the team, right? What kind of hardware you want to use, and so it's up to your budget. We've seen robots in here that are fairly low cost, but you always pay a performance penalty for that as well. We were lucky to actually get a good budget when we started first, so we have an industrial grade platform and an industrial grade manipulator. So on the hardware side you're quite good. We integrated it all ourselves and added the computing and the sensing and everything else. So that by itself, and the power, that by itself is a real challenge, but it really helps to have some good hardware. And I mean, if you go in that direction, then you can easily spend $50,000 for a platform. But you can enter the competition with a platform that costs maybe $2,000 as well.
Oh, great! What about the development of it? Since they're autonomous, right? What's the most difficult part of it?
Yeah, good question. The focus is really on once the hardware is solid, then you can focus on the software development. And there are two components here: navigation and manipulation. And I would say navigation is not the hardest part here, because the environment is not that big and it's fairly structured. So manipulation is the hard one. So recognizing objects, detecting them, localizing them properly, and then picking them. So whenever I say that, my navigation people get upset because they think their part is also difficult, of course. But if you ask me what's more difficult or maybe more non-standard, and you have to develop more yourself, that's the manipulation.
Great. You are in this field. You were working with robotics for a long time. How do you consider the innovations of this area? Is it like a lot, or you think it should be more? It could be more.
Yeah, I think this type of competition is excellent for transferring knowledge into industry.
Yeah.
So we had some industry projects that are very related to what we do here. Like, for instance, people try to develop autonomous forklifts to pick packages inside like a warehouse. And then you have exactly the same problems as here. You need to navigate around, and you need to pick those goods off pallets, and that's exactly what we did. One of those projects, and the people who developed scientific results for the industry projects also worked on the RoboCup and vice versa. So this really helped us to achieve good quality and robustness.
Yeah. So do you have? You said it, the RoboCup is good because of it. So is it common that some teams have, even if they don't share with each other from other countries, they come to RoboCup and have the same problems or similar problems?
Oh yeah. And there's a lot of help going on between the teams in the same league and also between leagues, to be honest. We're all one big family here, which is nice. Yeah? So We had logistics issues, for instance, so we talked to someone who speaks Portuguese, and he made the right calls. And then the next day he had some issues with his robot, and so we could help him out on his robot in the rescue league. And it goes back and forth, and even the companies that work here, not work here but exhibit here at the trade show, they're very helpful too. So Universal Robots is here, for instance. They helped out that other team when they had technical issues. We have Unitree here. I'm not working for either of them, so I'm just mentioning different examples.
Great.
They actually gave their platform to a team we know, because theirs didn't work anymore, so they almost, on day one, they were finished. So Unitree said, well, look, take our robot dog and try your best, go for it. And now, so they can compete now. So this is the nice spirit about the RoboCup I really love.
And yeah, it seems pretty amazing. Everybody we're calling our guests are from the organization, and they really say that the spirit of the competition is helping. People are always here sharing so much. It's crazy to think about, to think that people came from all over the world, and just for one purpose. It's amazing.
Yeah, absolutely. The spirit is great, and also the spectators started coming in yesterday and today. It's just amazing, like all the school classes here.
Oh
Everyone's
yeah,
so interested. And,
our kids are amazed for sure. And one last question: why having so many leagues did you choose at work?
Why did we choose at work?
Why did you choose at work?
Yeah, so actually it was very driven by my industry requirements. So when I started, I was supposed to work in this space. Yeah? So I applied for this job to work with industry on smart factory operations. And I knew the RoboCup from earlier, and I thought, okay, I'll check out what is this industrial league about. And maybe that's back to what you mentioned at the beginning, those two industrial leagues. So I looked at both of them, and I decided at work is exactly what I want to do, and it's very valuable for the other projects I do in industry. So it was the right choice, definitely.
Oh, great! So thank you so much, Tobias, for being here. It was a great interview.
It's been a pleasure. Thank you.
Hope your team does amazing. I'm cheering for you. So the next league is MathWorks. We're gonna have them here. Thank you so much.
Welcome.
Bye bye, guys.
Hello everyone, we are back again and now with a very special person, one of our sponsors from MathWorks. So now please present yourself, tell me more about yourself and MathWorks please.
Yes, hi Fernanda. My name is Jose. I am part of MathWorks. I'm one of the principal robotics engineers for education and I'm also a product manager at MathWorks.
Awesome. So look, we could get images from the competition, the challenge, right? Yeah. So it's the ARM challenge. Can you talk a little bit more about the challenge? What is the main objective of it, please?
Yeah, so I think what you're seeing on the screen is the booth that we have here, and then now you're seeing the robots from the ARM challenge. It's a competition that we've put together in partnership with the RoboCup Federation and Universal Robots.
Awesome.
Yeah. The way it works is the competition starts in a simulator, so the students will be given a simulator with a lot of different objects and a robot manipulator, a Universal Robots manipulator with a camera mounted on the gripper. And they have to identify the objects, come up with a strategy of how to pick them up, where to put them, how to be smart about managing the stuff that's on the table.
Yeah.
And then finally they score a bunch of points and they get ranked. They participate from all around the world online, and the top 6 teams are invited to hear
really?
RoboCup finals. Yeah.
And how many teams could come here to do the challenge?
So usually we invite 6 teams to the finals.
Oh.
So the top 6 teams from all of the online qualifiers get invited to the RoboCup finals.
Yeah, that's awesome. And they are already here, all of them. This challenge, as you said, it started long time ago with the simulation, right?
Yeah, so it starts in January. So January of each year, we release the new simulation environment.
Yeah.
And then people can register for the competition and start working on their solutions.
And how many teams were in this phase of the competition?
I think we had over 100 teams register.
Really?
Yeah.
That's awesome.
Yeah.
And was the first year of the competition, the challenge, I'm sorry?
This is the 4th year.
4th year.
This is the 4th year of the challenge.
This is awesome. It's very good to have this here in Brazil, Salvador, together with the RoboCup. And in your opinion, what do you think the main challenge that the teams face?
The thing we're emphasizing is when they come to the finals, they're presented with the real robot.
Yeah.
After working in simulation, So it's what some of the researchers call the sim to real gap.
Yeah. And this happens in all fields, right?
Exactly.
When you do a simulation, it's a very controlled environment, and then boom.
Very ideal.
Real world.
That's right.
Yeah. And I want you to tell me how this challenge communicate with MathWorks.
Yeah, sure. So one of our investments is in robotics and artificial intelligence.
Awesome.
And education.
Perfect.
We've been partnering with RoboCup for almost, I think, 15 years.
Really?
So for a long time, yeah. So it just was a really good match for us to help put together with some of the hardware capabilities that we have. And we're trying to find a way to get new people into the competition.
Oh, awesome.
So that's why there's a simulation emphasis. Yeah.
Awesome. Because the simulation, people from all around the world can participate?
Anybody in the world.
Really?
Yeah. They just download the files to their computer, they get a MATLAB license.
Really? That's
to participate in
awesome.
RoboCup. Yeah. Here we can see one of the teams. Yeah. I think they're testing one of their algorithms right now.
And they starts on January, right? So we just stay tuned. How can we see, okay, I have a new challenge this year? It's from the site or?
There's a site.
There's a site.
arm.robocup.org.
Oh, awesome. So we should stay tuned to participate of this challenge. And as you said, they are testing the robot right now?
Yeah, so the students here in the finals, the 6 teams, in this case we have 5 teams because one of them couldn't make it, unfortunately.
Oh, yeah.
They get assigned slots, so they have half an hour and 1 hour slots throughout 4 days to basically test the code they tried in simulation, but now in the real world.
That's awesome because the simulation sometimes everything works perfectly fine, and then the real world, oh my god, the light, right?
The light, the friction, there's so many other parameters, the parameters of the camera, there's so many things that affect it, yeah.
Yeah. You said you were an engineer?
I am a mechanical engineer by trade.
Mechanical engineer. That's awesome. So, how do you think it's the main challenges of like giving a simulation, the code of the simulation, and going to the real world in terms of hardware? Like they get used to the hardware, but it's simulated, right? So,
Yep.
what is the main challenges of it?
One of the main challenges is the sensors, actually.
Really?
So the simulated sensors are often very different from real-world sensors.
Yeah, I got it.
The physics now, we're in a spot where we can have pretty accurate physics for the objects, the interactions, and but the sensors, however, simulating the different covariants, the different errors that they have, that is something that can make or break that transition from simulation to real world.
Yeah, so putting it all together, right? And how many sensors do we have in this robot? Can you tell me a little bit more about this hardware we are seeing now?
Yeah. So I'm probably not the best person to tell you about the hardware. The best person you just saw on screen a little while ago is the Universal Robots principal investigator. But the sensors have many, the robots have many sensors in them, encoder, force and torque sensors inside them. And they have very sophisticated control algorithms as part of the Universal Robots kind of hardware package. Additionally to that, as part of the challenge, they have a robotic gripper, which is an adaptive gripper.
Awesome.
Yeah, the gripper itself has, some sensors in the motor that can sense if it's squeezing too hard and it should stop. Yeah, so that's why it's adaptive. And then, of course, the camera, which is kind of the main sensor in this competition, which provides color images and also depth images.
Oh, that's awesome. So you said the challenge has tasks, right? Like has some challenges
within the table, yeah.
Within the table, so each table is a challenge, and how this works. Like, can you tell me more about the challenges?
Yeah. So there is various levels of difficulty in the table that we provide to them. Yeah. So in this case, the bottles, the cans, the other objects that are in there will score a different amount of points.
Oh.
So in general, the more difficult the grasp is, so the more logic it requires to be able to be successful, the more points they get. For instance, there's a couple of objects that are occluded or hidden behind boxes or behind other objects.
Oh, really? That seems hard.
Yeah.
And we need to be able to do that with a mechanical arm, right?
Yep. So they also have to work with the limits of the hardware.
Yeah.
So for instance, there is a concept of like grasping hardware augmentation. So there's some objects that are outside of the reach of the robot completely.
Oh, yeah. So the robot cannot reach it.
The robot cannot reach it, and they need to come up with a creative solution to that.
Oh, really?
Yep.
Well, that sounds very, very interesting and funny.
Yes.
So you said to me that have sensors to know when the arm grasps something really hard. How this works? I mean, if I get like a bottle of water and hold it very tight, it can split water. So that's the part of the challenges. Like we have some different objects.
Yeah, that's part of the challenge, exactly. So, for instance, some of the objects that we use, we try to make them rigid, specifically for that case, so not to make it too hard. But we also have a couple of objects that are more difficult. So we have a can that's empty, that can be like deformed. So they have to work within those constraints. And then if they grasp some objects from like a not so good region, then the object can slip out of the hand and they will lose the point.
Oh, yeah, definitely. And where are these competitors from? Like, they're from one country, a lot of countries?
That's a good question. We had probably around 10 different countries participate this year. The 5 finalists that are here are 3 teams from Brazil.
Really?
Yeah.
Oh my God!
So 3
I'm so
teams from
proud right
Brazil.
now.
Yes, yes, they are dominating right now. And there's also 1 team from Poland
Oh.
and 1 team from Mexico.
Oh my God! Poland is very far from here, right?
Yes, yes, they've come a long way.
And I think people are loving to see what is happening here. So we see they are coding, but also having fun. You
They're
know,
having a lot of fun.
I
Yeah.
mean, I think this is very the point of participating of challenges and getting to know new things. It's very, very fun, and the main objective is to make young people learn, right?
Yes, I think that's the main objective of the challenge, and then for them to try something new, right? So
Yeah, definitely.
there's many students that maybe don't have access to. This is a pretty expensive robot,
Yeah.
so you know.
So
they're
you give
really
them
good.
the opportunity to work with it. You just need to be one of the best.
Yes, exactly.
Of like 100, how many teams?
I think we had over 100 registrations,
Yeah.
and then we had a lot of submissions that
So,
were
I
very
mean,
good.
It's not easy, but it's possible to get there, to
Yes.
get here, or to get to RoboCup 2026. Oh, so we can see some of the objects right there,
Yep.
right?
Yep. So there's some bottles, there's some cans, there's some colored cubes.
Yeah.
There's also some markers and some like different type of cans. Like there's like a spam can, and then you can see the box there that has some objects behind it.
Yeah.
And then one of the tasks they have also is there's a weighing scale on the table. They're supposed to like simulate kind of weighing something and putting it in the right place. So like that selection. Yep. So
And what are the like applications of it in the industry, or maybe the health health field? What are the applications of this challenge and the things that the participant will learn with the challenge?
yeah, so it's basically smart manipulation.
Yeah.
So just combining, computer vision, deep learning, image processing with the hardware, in this case specifically for manipulation. They also call it, one of the industrial applications is intelligent bin picking, which is kind of like the most prominent application. So that's something that like shipping companies and commissioning companies in the industry will use, like Amazon to, like, for instance, be smart about selecting the packages.
Oh, really?
Yep.
The package,
So
yeah.
like warehousing, intelligent warehousing is another common use.
And they do these things autonomously, or are people controlling these robots from like outside?
That's a good question. Yeah. So the idea is to get the industry to move towards a more fully autonomous, commissioning.
Yeah, so you
task.
don't need humans to control it,
Yeah,
right?
but the benefit of these robots that we're using is they're called cobots.
Mm.
They're meant to work with humans.
Oh,
So
that's
they have-
awesome.
yeah, they're very cool. They have a lot of safety features to have humans around them, which is why we use them for the competition.
Or the competition, yeah. It needs to be safe, right? And as I say, better safe than sorry.
Yeah, absolutely.
And so we have some user stories for that?
Yeah, absolutely. So our products, MATLAB and Simulink, which is what the competitors use to program the robot. Yeah, so they program all of their algorithm in MATLAB and Simulink. They're used all throughout the industry, right? So they're used by bigger companies in the automotive industry, like Ford, General Motors,
Really?
Tesla. Yeah, all of them use MATLAB and Simulink
To simulate the robots working to...
for different things. So it could be for the design of their self-driving cars, to simulate, to test their image processing algorithm, to optimize the design of their platforms. Again, outside of automotive, like aerospace companies, Boeing, Lockheed Martin, all of
Really?
them use our products.
That's awesome.
So it's also a great way to introduce, the products to like
Yeah,
mainstream audience.
yeah. So people get really, interested in the robots, but then you see the simulation that is really, really important. And can you tell me a little bit more about the importance of the simulation to passing, to doing things and training models and testing things to real world?
Yeah, absolutely. So one of our products, like I said, we have two main product families, MATLAB and Simulink. The Simulink product family of our software is all used to perform a process called model-based design. And what that is basically kind of creating either mathematical or approximate models of your system, and then using that system throughout the design process, so that you don't have to like test on a real robot so many times and break it and be expensive.
Oh, I got it.
So it's the idea behind using a lot of simulations and testing early in simulations and with models, so that by the time you get to your real robot, you have a lot less bugs. You don't break it as many times.
Yeah.
Yep.
I mean, you don't know exactly what to do. You don't have the exactly code, the final code, but you have like more specific bugs and things to solve, right?
Exactly.
I mean, probably not easy. As you said, the problem of simulation to real world happened.
Yeah.
But it's probably more easy than just testing. And this robot, how the robot learn, like, okay, it uses a lot of artificial intelligence, right? Can you tell me more about it, like where artificial intelligence is used and how the robot knows what to do?
Yeah, so basically what a lot of the competitors are doing is they are first positioning the hand of the robot to point at some of the objects in the field.
Oh.
Then they process the images from the camera and they'll train a neural network to recognize them. So first they'll recognize whether it's a bottle, a can, a cube, and then how many of them are in the camera's view.
Oh, awesome.
Then they'll extract the colors from those, and then they'll decide what they have to do next.
Yeah, that's awesome. Well, I would like to say sorry to the public because our studio is near the spectators and we are having a football game right now, a soccer game right now.
Very good match right now.
Very good match, yeah. So this is why this is a little bit noisy, but I'm sure people can hear us, so that's the important part. So, I mean, the robot, it's kind of doing
So this is the demo robot. So this is a demo robot that is part of the booth, the MATLAB and Simulating booth, along with Universal Robots.
No,
and
that's
right
awesome.
now it's just dancing.
It's dancing?
Yeah, it's
Is
just
this a
dancing.
dance?
This is the robot dance. And it's there for people to come over to the booth and just ask questions, learn about the robot. They can even try to program it. Yeah.
So just to invite people here from Salvador, can you tell where to find you there?
We're here in the convention center in
Yeah,
RoboCup. So when you enter, it's in the ground floor towards the left.
Yeah.
If you keep walking, you'll find the MathWorks booth
MathWorks.
with the arm challenge in it, and we have 3 robots.
Yeah.
2 of them are for the competition, and this one that you see here dancing is so that you can come check it out, ask questions, maybe even try to see how they're programmed.
That's awesome. That's awesome. They are similar robots or different? They're
They're
two
the
with
same robot.
Same
There are
robot.
3 of the same robot, yeah.
Okay. I mean, the simulation is something that really gets me because it's very, very important and probably very hard to simulate the environment in real world. So the tasks are the same. Simulation in real world.
Yeah. So the tasks are essentially the same for the teams. They have the same tasks in the simulation and the same tasks in the real world. The reason the challenge is a little bit more complex is because the objects in the table have dynamic
positions.
Yeah, so they can change, they can move, they can rotate. The objects can change randomly. So they have to create a really smart algorithm to be able to like score many points.
That's awesome. And I don't know if you have this information, but like the mean of the ages that the participants have, like are they seniors, are they juniors?
That's a good question. I think a lot of the participants that made it to the finals are on their latter years of college. So they're like juniors, seniors, and maybe grad students. But on the online qualification rounds, we had a lot of different ages.
Oh, that's awesome.
Yeah, we've even
That's
had
awesome.
some like really smart high school kids participate
Really?
with the simulation. Yeah.
Oh my God! I mean, probably next year or next 2 years they will be here working on it. You know, achieving goals.
Absolutely.
That's awesome, and I mean that's the main objective of it. Like, educating and improving it, and people can learn more about it.
And creating learning opportunities, which is what we're trying to do along with RoboCup and Universal.
Yes, and I think this is a very beautiful thing to do and important, because this way we are teaching the youngest to be better than we are in terms of life and technology as well, right? So we're seeing now, it looks kind of easy for us to do, right, these tasks, but this probably involves a lot of calculus, a lot of math behind, and I mean, it makes sense with the name of the company, right? MathWorks. Can you tell me a little bit more about the company?
So our company MathWorks started because we have this product called MATLAB, which is a technical computing environment. Initially, the main two applications were control systems and signal processing, but so we are still really strong. We're the de facto solution for anything related to designing, simulating, optimizing control systems, signal processing algorithms. But now we have over probably 150 products on many different industries and domains. So, like I said, automotive, aerospace, robotics, financial, so many different.
So many different, like anything that can have simulations, and as I said, not only simulation, it's a really wide range of things. So okay, it was awesome talking to you. I would like to thank MathWorks so much, because without the sponsors, I mean, this event wouldn't be possible. And as we see, we have a lot of children here. We have a lot of high school kids getting here and say, "Oh, I think I can do that too." I think
hopefully they get excited.
Yeah, they get excited and they go further. They want to know more. They want to do more. And in this way, we can have a strong army of
new generation of scientists and engineers.
Engineers, and as we say, improving year by year. So thank you so much for your participation.
Thank you for having me.
It was a very good talk. Thank you.
Absolutely.
And now we are going to see At Home League.
Can you tell us your name, where you're from, and what league you're competing in?
Yeah, so my name's Spencer Long, and we're in the RoboCup at Work League here. We're from America. Our team is West Virginia, the state in America, and we built a robot to compete in this challenge, and that's about it.
Oh, that's nice. What are the main challenges you and your teammates are facing?
Well, for us personally, it's just it's our first time competing, so we kind of are a bunch of undergrad students that did this as a capstone project for our university. And a lot of us didn't have programming or robotic backgrounds and really had to learn a lot really fast.
Oh, that's tough. And so what are you thinking of the event? What are your thoughts on it?
So far, it's been pretty cool. It's all of our first robotics competition. We didn't realize how much work it was going to be. We thought it was, going to be less work, more fun, but we've been really at it.
Yes. Okay, thank you very much.
Hi guys, we're back with Fagner again. Such a pleasure.
Hello again.
Fagner, can you present yourself to us, please?
Present myself again. Oh, okay, no problem. Hi, my name is Fagner. I'm the local chair of the at-home competition league, the one about the domestic robots.
Right, Fagner. Actually, we've had Fagner here yesterday 2 times, but his league is it has some different activities. So, can you tell a bit more about your league?
Yeah, so we have different tasks for this league. As I said yesterday, we have 4 tasks for the first stage of the competition and the 4 tasks for the second stage of the competition. We already finished the first stage, and now we are making the first task of the second stage of the competition. This is the clean the table. So the robots needed to get inside the arena, looking for dishes to put in the dishwasher machine, and recognize some objects to put in the dishwasher. The robot can look to the dishwasher, open the door of the dishwasher if you want, or the robot could ask to the referee to open this for the robot, but they will be penalized if they ask it to referee open this door. Now the robot is going to the table. This is the F-bot team. On the table we have some objects, a plate, a knife, a spoon, or maybe a fork, and the robots need to take this object and put in the dishwasher machine.
How participants usually goes well in this stage?
Yes, this is the first task of this stage. So yeah, we need to wait to see how the teams is going on in this stage. But the first stage was very good. We have 8 teams that passed to the second stage. That's very good. So yeah, we have this 8 team now trying to resolve this task. So this is the dishwasher. The robot asked to the referee to open the door of the dishwasher.
And now the robot will get back to the... Oh, no, sorry. Let's see. I think that this team just stopped the task.
Well,
We will see another team now.
the activity cleaning table was before. It's gonna be later.
If the team make this task before in the first
Yeah.
stage, no. This is a new one. It's more harder. This task. So this is a task for the stage 2.
Okay.
This is the Tidy Boy team. So the robot is going to the kitchen. Look to the table, trying to find the objects to put in the dishwasher.
Are the objects heavy?
Well, we have a plate that's not so heavy. We have some knife, spoon, and a fork. This is not heavy too. There is 2 cans. That's not heavy to the robots. There's another object more heavy, like a bottle of Fanta. We're calling orange juice in the task. But this object is not heavy to the robot. Maybe this box of milk could be a little heavy, but I think that the robot will not try to take the milk. Oh, the robot take the sorry, forget the name.
The plate, the kumbuka.
Kumbuka. Yeah, it's a local name here, the kumbuka. The bowl.
Yeah, sure.
Yeah.
I felt so Brazilian now because everyone calls it bowl even in Brazil.
Yeah. Now the robot take a fork, and they're going to the dishwasher.
Oh, he's meant to take 2, or he can. It's no difference between taking 1 or 2 at a time.
There is no difference. The robot can take 1 at a time, but this robot has 2 arms, so they will try to optimize the task. So they take the bowl and take the fork, and now put in the dishwasher.
It makes more points for it for taking 2, or no?
They need to take every object. So the bowl, the spoon, the fork, the knife should be taken inside the dishwasher. We have already the can. So the robot needs to take the can and get it inside the trash.
Oh. Well, I saw he put the bowl.
Yeah, they have some points for this. They're trying to take a can now.
For the dishwasher to wash it properly, the bowl should be turned down. Doesn't it? Does it make any difference?
Here it doesn't make any difference. The robot should just
put it there.
Put there.
Yeah, right.
If the objects fall in the floor, they don't get points. Okay. But here now we just needed the robot to put the object inside the dishwasher, and in the can. Normally should be a empty can, right? The robot should take in, put in the trash. There's a spoon outside next to the dishwasher, and the robot should take this spoon too, and they clean the table with this spoon in the spot where the can was.
What about time? Does it have a set timer
10
or
10 minutes.
10 minutes?
Yeah,
Only
so-
for putting the dishes in the dishwasher?
Yes, yes.
Okay.
The robot have a maximum of 10 minutes to put all the dishes in the dishwasher and take the cans inside the trash.
Okay.
There's a small tablet of soaps, soap that they can put in the dishwasher too. Now the robot will try to get the plates and the fork or knife. Sorry. The robot is trying to find the bad spots to take the objects.
But it's doing a really great job, isn't it?
Yeah, this is one of the best robots we have in the competition. So they're really trying to take the objects. It's a really, really good one.
The team, people from team are from which country?
It's Tide Boy from South Korea.
South Korea.
Next year we will have the competition there.
They're gonna be at home.
Yeah, so they're gonna be at home.
Sorry.
It's a good joke.
Yeah.
So I think the robot
is it
that's
the end?
finished. It was very, very good. They take some objects inside the dishwasher and take the can too. But yeah, this was a very, very good robot.
Those two guys, they are both referees.
Yeah, both referees. Because you need one to take notes about the time, about some mistakes, and another one to pay attention to the robot. I already say the robot has a big red button, so this referee should be attention. If the robot makes some mistake, they need to push down this button at the same time.
Okay. And how they choose, how RoboCup, the organization choose the referees?
Normally the referees is part of the technical committee, the people responsible to make the rules. So these guys know everything about the rules because they wrote them. So yeah, they work every year in these rules. They know every details about the rules. So this is the best one to be happy with.
Great.
And every year we have a election about who will be part of technical committee for the next year and they work in this rule book. Now.
So how you guys define the stages and the tasks of stages? Like, can you this year think putting decisions in the dishwasher is not important, or it's not like that? How does it work?
How we make a decision about
to
how
put
the
a
task
task
is made. Each year you try to make this challenge more challenging.
Yeah.
So put more things more difficult. We divided about simple tasks and more complex tasks. So this one where we needed to open the dishwasher, find objects, take these objects in a proper way. This is a very difficult for this robot. So this is part of the second stage. There is another tasks. Like for example, tomorrow at morning we will have the restaurant task. This is a very good task in this competition because the robots will be outside the arena. So this is a controlled environment. Tomorrow we will be in an open environment. So we will have clients in a restaurant. The robot should take take notes about which clients want and get your order and take it to the client. This is a really good task that we have in this competition tomorrow morning at 9.
Well, we already have some robots for in restaurants, in other countries. I don't know. I'm not sure about Brazil, but in other countries we do have. Is it meant to work like that?
I think what you have here in this task, here not, but tomorrow in this task of restaurant, is something a little more complex, because in what we have in the real restaurant with the real robots today, the robot receives the order with touch in his screen, or ordered by a cell phone or a tablet in the table in the restaurant, and the robot just needed to go to the kitchen. Some person gets the order inside the robot. The robot go to the client, and the client take it from the robot. Here, the robot should find the person in the restaurant, go to the person, take your order by conversation, and get back to the kitchen, take the order by your hand. Of course, the robot should can have some assistance of the helper, but this is the main goal. Go to the kitchen, take the order by hand, and deliver it to the client. So this is more complex that we have in the real life in restaurants.
And also, the robot needs to do, only one robot has to do all these tasks, right? And what we have today are only for doing one task, is that right?
Yeah, this is one task, and we have each team has only one robot, but it's allowed to have two. But for this task, it's only one robot per try. So this is the first try. I think the teams is it's forming a queue outside the wall to the second try. But in each try, it's only one robot.
So the thing about the second robot needs to be the same.
No, that doesn't need to be the same. You mean equal, right?
Yeah, an equal robot. Yeah.
No, doesn't need to be. We have a team that have two robots here. These teams. So one robot have only one arm. Another robot has two arms. So this is the robot that have two arms.
Great.
But this thing has have two robots here. And they can participate with both. If both robots it's safe to participate, they can do the tasks. So the robot is making closing to the table. They're looking to the objects. I think the robot asked to the referee to remove the chair.
Oh,
This
so
is
polite.
This is allowed.
Okay.
And the robot asked you to remove another chair. They will try to.
Oh, that's so sophisticated.
Yeah.
He grew.
We can see the objects in the screen. So the robot see the plate, the can, the milk. They will try to take one of them.
And it's always like the milk has to stay, the plate has to go to the dishwasher, and the can goes to trash, right?
Yes.
So is it always like that? Because maybe a plate was not used. Maybe okay, this is more complicated, but maybe still maybe the milk is over and it's not going into the fridge, but it's going to the trash.
In these tasks, we will always have a very similar configuration.
Okay.
I think that this milk not should stay there, because you should have the 2 drinks, and these 2 drinks need to go to the trash, because it is a simulation of a finished dish, right? A finished meal.
Yes. Yeah.
So the plate should be with some finished meal. The can should be empty. The milk
Got it.
should be empty
Got
because
it.
it's a
It should be all over. Yeah.
a finished meal.
Okay.
So the milk should be in the trash. The can should be in the trash, and the other objects in the dishwasher.
Why the referee moved the object?
I think the robot asked for that.
Whoa.
Yeah, it's allowed, but the robot will have some will be penalized for that.
Oh, we'll lose points. Okay.
Any help the referee can do is penalized.
Okay.
But the robot can ask for this help. Of course, they will not ask for a lot of help, because in the finish
it's
there
just
will
a
be
little help
zero
Okay,
points.
Okay.
Okay, the robot will try to get the milk and throw in the trash.
And how does the coordination work? Because I think he got the milk, but if he press it too tight, the can will.
Yeah.
And if it's too loose, the can will fall.
The milk falls.
God. I think it was my fault. I'm
No,
sorry.
No. The robot will try to get another object. Well, since he has 2 arms, they will try to use it. Let's see what he will try to take. I think he will try the can, because probably the plan is to go to the trash and throw both objects in the trash. But I don't know. Let's see.
If he throws the plate into the trash, what happens? He lose points or like he lose no points. Is it or is he? What's the right thing? How can I refer
about
to
these
this?
robots? I don't know. Some robots has female names. Another robot has male names. This one, I don't know. This is a Tiago robot, so probably is.
But it's not eat like an object.
Yeah, some people ask eat,
But he
there's a lot
Tiago.
of people that call he, call she.
Yeah. What if he puts the plate into the trash?
Yeah, probably the robot will get some points to pick the robot, but they will not have points to place the robots in the right position, and probably they will be penalized to throw the plates in the trash. But there will be points to pick its objects. So the robot is really trying to get the can. Oh, I think it's finished now. Yeah, it's finished. Go out.
Because the time because the time is over, or because something happened.
I don't see. I think it's not time. Probably the team requests to finish.
Oh, okay.
This is allowed to.
Okay, right.
So we will have another team. For this task we have 8 teams. So in the two tries.
In the first stage, how many teams did we have?
14. For this for OPL, this one we have another league, the SPL, with another robots. That was four teams in the first stage, and these 4 teams passed it to the second stage.
Oh,
So the
great.
DSPL, we still have the same robots, the same 4 robots. And here for the OPL, starts with 14 and now we have 8.
Since the door is open, the team cannot touch the robot anymore, or
Yeah.
sorry, or they have to place it in front of the kitchen.
There are some tasks that since it's open, we cannot touch, but there's another task that the start position is inside the arena. So the team get the robot inside the arena and starts at this position. This task is start outside the arena, so the door is open. The robot should enter the arena alone, by yourself, right? And yeah, this is fully autonomous. The team cannot touch anymore. If team touch the robot, the task is finished. I think this one, no, we're coming.
Okay.
Oh, the referees go out. I don't know. Probably this is the finish of the first try. And then we will have a break of 5 minutes.
Okay.
Probably.
Okay. So for us to finish that, we're
Yeah.
coming to an end. What are your thoughts of this edition? People are doing great. People are have great robots. Are they feeling
Yeah.
great?
This is a very good edition because we have so many audience here and the
Yeah.
people is liking, is loving it very much.
Yeah.
I see the face of people. They are thinking that everything here is amazing. They look to the
Yeah.
robot and was very happy. Oh, the robot is. I think they're just trying.
Someone jumping there.
Yeah, there is no
Great.
referee, so it's not official.
Oh, okay. They can train before. Can they train?
No, but I think this is only checking if it's okay, but they go out.
Okay.
Can continue programming, but probably someone will ask them to remove the arena, the robots. So yeah.
So
this is very good to see the face of people here.
Yeah, we have children coming from schools and
Yeah,
they are
yeah.
all amazed
A
by
lot
the
of
robots.
people.
I
A
am
lot of
amazed too.
children.
Not only children are amazing, everybody is.
The children is like it very much.
Yeah.
And it's very good to see the smile
They-
in his face.
Yeah. Thank you so much, Wagner.
Thank
It's
you.
always good to have you here. Thank you for your time, for your patience, for everything. And now, I'll be back in a few seconds. Bye bye, guys.
Bye.
guys. It was not planned.
Yeah. So today was awesome.
Yeah.
Really awesome. And we are very happy to have you guys in the stream of RoboCup 2025. But unfortunately, the live has come to an end.
Yeah. We'll see you tomorrow at 10 a.m. as usual. I think we're already friends.
Yeah.
At 10
Almost
a.m.
best
we
friends.
meet. At 6 we say goodbye.
Yeah,
So,
just like that.
it's
Maybe
usual.
colleagues of work, but friends. You know.
So we have 2 more days. This is the end of the second day. We're gonna have amazing guests.
We are very excited to be here and to show everything for you guys.
Thank you for everything. We hope
Yeah.
we keep sharing. We keep.
Yeah. So I think that's it. Let me see if we have something. Oh yeah. Stay tuned on your social media and remember to share this link to anyone that you know and leave a comment behind, right? What teams you like to see. I don't know if people noticed, but we had interviews.
Yeah.
So if you want to see a specific team or a specific country, tell us.
Tell us everything. Like,
Tell us everything.
Ask in the chat.
Yeah.
Oh, I want to see this team. I want to know how this works. We have amazing people, and I'm gonna tell you, they know how to answer anything you ask.
Yeah.
Yeah, the level of the people here that we are interviewing, it's amazing.
And we are going to annotate these questions and ask them. So you will get a very good answer.
Yeah.
So that's it.
That's it,
It was
guys.
awesome to have you guys. Bye-bye. See you
Bye-bye.
tomorrow.
See you tomorrow.
A Petrobras é líder na transição energética justa.
Porque a nossa energia já nasceu para abastecer o país.
Uma transição energética justa tem que criar oportunidades para que todos se desenvolvam.
Justa para o meu corre. E abraçar novas formas de energia?
Também a transição energética justa. Ela tem que ser justa para todos.
Justa para cada brasileiro.
Justa para você.
Petrobras. O Brasil é a nossa energia.
Face up, 'cause you're a natural. I bleed it out of stone. You gotta be strong to make it. Yeah, you're a natural. Living your life on the road. You gotta be so strong. Yeah, you're a natural.
Toda ideia nasce pequena. Em uma sala silenciosa, num papel rabiscado, num sonho entre colegas. Assim nasceu o CEIA, não como estrutura, mas como desejo. Desejo de transformar ideias em impacto, ciência em solução, tecnologia em futuro. Em 5 anos, fomos muito além do que imaginamos. Criamos tecnologias, formamos talentos, aproximamos empresas e universidades. O futuro já começou. Ele está nas ideias que ainda nem surgiram, nas conexões que ainda vão acontecer, nos desafios que estamos prontos para resolver. E se o passado nos trouxe até aqui, é porque nunca estivemos sozinhos. E o que vem pela frente? Mais ciência, mais impacto, mais gente. CEIA, 5 anos de inteligência que transforma.
do Донуудаа хүн ягаад гэвэл бодож байгаагаа би хэлдэг дуунаар зөвхөн дуунуудыг хүн сонс Хэрвээ намайг мэдээ гэвэл намайг битээ юу гэдгийг хэлэх Намайг битээ ярь гэж байгаа